Should you spend your time learning foundational coding concepts? Or focus on writing clean code on your own? Or integrate AI copilots into your workflow? Or skip everything and just learn how to prompt? It's 2026, and ironically, learning how to code has never been more confusing because of AI. This is the wildest era of software development I've ever seen. On one hand, you must understand the deep foundational logic of full-stack engineering. On the other, if you're not using AI to build faster, you're already falling behind. Even Andrej Karpathy, one of the godfathers of modern AI, has openly said he feels behind. If he feels the pressure, where does that leave you? So here's the real question. How do you become the developer who understands systems deeply and uses AI to cut development time in half? How do you get the best of both worlds? Welcome to one of the rare videos on the internet that answers that exact question. Not in a 5-minute video, but in a multi-hour masterclass. This isn't just another PERN tutorial. I'll give you a 4-tier framework that mirrors the real career path of a modern full-stack developer. Here's how it works. First, during an in-depth crash course, you'll learn the foundations of the PERN stack, what it is, how it works, who uses it, and why it matters. Second, you'll build a massive production-ready full-stack application by writing the core PERN stack code manually, so you truly understand how everything fits together. Third, once the fundamentals are solid, you'll start using AI side by side to speed up development and ship features faster. And finally, you'll rebuild the entire application using AI alone, because now you actually understand what you're automating. You'll learn the concepts, you write the code, then you automate it with AI. And you'll do all of this while building a real, production-grade, full-stack classroom management dashboard. Data-heavy, relationship complex, and architected the way real companies build software. Here's what you'll build. A multi-role authentication system that securely routes students, teachers, and admins to protected areas with custom permissions. A real-time dashboard showing total students, active classes, faculty stats, subject distribution, and more. A complete subject management system. Create subjects, filter instantly, and drill into assigned classes and teachers. Department management with detailed views of every student and faculty member inside each department. Advanced class management. Schedule classes, set capacity limits, and assign multiple teachers across sections. A Google Classroom-style enrollment system where students join classes instantly using invite codes. And the ability to change the theme of your entire dashboard within seconds. But this video isn't just about what you build. It's about how you build it. That's why you'll learn how to do it the industry way, focusing on enterprise-grade security that protects your app from bots and DDoS attacks with Arcjet, a production-ready architecture that keeps your codebase clean, scalable, and maintainable. Asset management with AI-powered optimization and instant CDN delivery with Cloudinary, and advanced monitoring with region-based performance insights and query-level analysis using Site 24/7. This project is intentionally deep enough to teach real engineering concepts, yet structured enough that you never get lost. And we'll build all of this using the best tech stack for 2026. Better-Auth for complex authentication flows, Express.js for a flexible, battle-tested backend, TypeScript for a full end-to-end type safety, Postgres with Drizzle ORM for reliable, type-safe modeling, Tailwind CSS and Shadcn UI for those rapid, beautiful interfaces, and then we dive into Refine Core, a powerful open-source React framework for building internal tools and admin panels. Plus, Refine's AI-accelerated workflows that understand your backend and generate clean, production-ready code. And CodeRabbit, your AI code reviewer that helps keep your code clean and scalable. So that by the end of this video, you won't just know how to code. You'll know how to engineer, secure, and ship a scalable platform using AI the right way. And if you want to go even deeper into system design, AWS, Docker, and advanced database optimization, my ultimate backend course is coming soon. I'll leave the waitlist link down in the description. So grab a coffee. I'll bring the code and teach you how developers are writing software in 2026 and beyond. Before we go ahead and build a PERN stack app, you first need a quick flashback to how the web used to work. Because once you see just how painful things were, everything we use today suddenly makes perfect sense. It's like remembering your old brick phone before appreciating the newest iPhone. Picture this. It's 2003, you're on eBay. You click Add to Cart, and instantly, the entire screen flashes white. The header reloads, the footer reloads, and even the cart icon reloads. For one tiny action, your whole browser basically resets. And that was normal. Every small interaction triggered a round trip to the server. The server then rebuilt the entire page from scratch, wrapped the data directly inside HTML and CSS, and sent that fully baked page back to you. The browser didn't update part of the screen. It threw away everything and replaced it with the server's new version. It's like wanting to move your couch and instead bulldozing the whole house, rebuilding it, and placing the couch in a slightly different spot. Most sites at the time used PHP, ASP.NET, or Ruby on Rails. Different technologies, same workflow. Server pulls data, mixes it with markup, outputs a full page. The browser wipes the screen and loads that entire page again. And all the code lived together in one place. Your HTML sat next to your server logic, next to your styling, next to your database calls. It was one giant code smoothie. Easy to start, messy to scale. This approach caused some real problems. Pages were slow, bandwidth was wasted, full page reloads looked clunky, and felt even worse. And what collapsed this entire model was the arrival of cell phones. Because pulling an entire page over 3G felt like waiting for Windows XP to boot. To be fair, the old method wasn't all that bad. It was simple, secure, SEO loved it, and for small websites, it worked perfectly fine. But the moment the web needed to be dynamic, interactive, and smooth, this model broke. So how did we get from reload everything websites to the fast, app-like experiences that we use today? What was the thing that solved the reload problem and opened the door to modern stacks like the PERN stack? Here comes JavaScript. The solution to the reload everything problem didn't come from a new backend language. It came from something hiding in every browser since the 90s. Something originally created in 10 days and used mostly for animations and annoying pop-ups. It's JavaScript. It was built to run directly inside the browser, manipulate web pages in real time, respond instantly to user actions, communicate with servers in the background, and update specific UI parts without forcing a full reload. So if HTML is structure and CSS is style, JavaScript is what turns a static page into an interactive application. Every browser ships with a JavaScript engine. There's V8 in Chrome, SpiderMonkey in Firefox, or JavaScript Core in Safari. These engines parse the code, compile it to the machine instructions, and run it through a single-threaded event loop. This architecture makes JavaScript fast and responsive inside the browser. So how exactly did this fix the reload problem? Well, early on, JavaScript handled small tasks like form validation, button clicks, and tiny UI tweaks. But a couple of smart developers noticed something important. JavaScript runs exactly where the UI lives, inside the web page. So they asked a simple question. What if JavaScript could intercept clicks before the browser reloads the whole page? That question changed the web forever. Browsers began exposing APIs like OG XML HTTP request or the current fetch request that allowed asynchronous communication with servers. These APIs let JavaScript request only data, not full HTML pages. When JavaScript received that data, it updated the DOM, the browser's live tree of UI elements. The page stayed loaded the entire time. So the new pattern looked something like this. User clicks, JavaScript intercepts, sends background request, server returns JSON, JavaScript receives it, updates only the affected DOM nodes, and the page stays loaded. This was the beginning of a more interactive web. And JavaScript does a lot. And teaching all of it in this crash course would turn it into a full-blown documentary. But if you're thinking, I really need to understand JavaScript properly, that's exactly why I built a full JavaScript course inside of our Pro platform. You can go to jsmastery.com and become a member to get access to the JavaScript course, along with React, Next.js, testing, GSAP, and more. I'll leave the link down in the description. But once JavaScript could update the page without reloads, developers realized something even bigger. If JavaScript can control parts of the UI, why not let it control the entire application? And that triggered the real front-end revolution. First came Ajax, which allowed JavaScript to fetch data in background and update UI without reloading. And then came jQuery, which made this process simpler with less code. But as apps grew more complex, manually managing the DOM became unscalable. This pushed developers toward component-based frameworks, leading to modern solutions like React, the R in the PERN stack. But React didn't appear out of thin air. It required modern JavaScript features, bundlers, transpilers, build pipelines, and all the tooling that powers today's front-end ecosystem. And while the front-end world was evolving slowly, something else was brewing behind the scenes. Something huge. Something that would completely reshape back-end development, influence the front-end world as well, and combine both of them into full-stack JavaScript. Any idea what it was? By the time Ajax and jQuery reshaped the front-end, the internet itself had changed. Users were now expecting real-time dashboards, live chats, instant notifications, and collaborative tools. The kind of experiences the early web stack was never built for. The front-end was evolving fast. The backend didn't. Languages like PHP, Ruby, Python, and Java powered the 2000s, but they were designed for a world of simple request-response pages. As soon as the web became more dynamic, traditional backends ran into major limitations. For example, real-time experiences require a persistent, two-way connection between client and server. This means WebSockets, persistent, and bidirectional. But traditional backend stacks relied on short-lived requests, blocking I/O, and one thread per connection. They assumed that user clicks, server responds, and the connection closes. But real-time apps needed event-driven architecture, non-blocking I/O, and persistent sockets with zero waiting time. There was also another limitation of these traditional servers, and that was concurrency. In most traditional runtimes, one connection equals one thread. That means that if a user uploaded a file, the server stayed frozen until completion. Multiply that by thousands and servers collapsed. What modern apps needed was a model where one thread could manage thousands of concurrent I/O operations through events and callbacks, not thousands of heavyweight threads. So while building a file upload system using Ruby, Ryan ran into the same concurrency issues. Blocking I/O forced servers to sit idle while waiting. He noticed something interesting. JavaScript in the browser already used an event-driven, non-blocking model. The event loop kept the UI responsive while background operations were in progress. The problem? Well, JavaScript lived inside browsers. It couldn't run on backend code. And then a breakthrough arrived. Google Chrome introduced V8, an insanely fast JavaScript engine built to optimize asynchronous operations. It had a high-performance event loop, just-in-time completion, non-blocking architecture, incredible execution speed, and an open-source license. Ryan connected the dots. Instead of fixing PHP or Ruby, what if the backend used JavaScript, the same event-driven model that makes the browser so fast? It sounded ridiculous. It sounded radical, and yet it was the right idea. Ryan pulled V8 out of Chrome, embedded it in C++, and then added everything JavaScript was missing: file system access, networking APIs, timers, a module system, and even updated the event loop. And this new creature came to life. Node.js, the N in the PERN stack. It wasn't just a library. It wasn't even a framework. It was a runtime, a new environment where JavaScript could run forever outside the browser, handling files, servers, and asynchronous I/O at a massive scale. From there, JavaScript basically went from that pop-up language to the most important language on the internet, and soon enough, the most important language in the world. When people first encounter Node, some think it's a new programming language, others assume it's a backend framework like Django, and some even believe Node replaces JavaScript entirely. None of these are correct. Node.js is simply the environment where JavaScript can finally run outside the browser. That's it. Nothing more, nothing less. It lets JavaScript stretch its legs into places it was never allowed to go before. To start working with Node, you simply need to download it from the official website. Once installed, you get two essential tools: Node, which is the program that executes JavaScript files, and npm, which is the package manager that installs additional libraries. You can check your installation with node-v and npm-v. If you see version numbers, your machine is ready. JavaScript can now run the same way Python, Go, or C++ can. If you've used the Python shell before, Node offers something similar called REPL: read, evaluate, print, and loop. Don't worry about the name though. Just think of it as a scratchpad for testing JavaScript instantly. You can open it up by typing node, and then try typing something like 1 + 1, or const name is equal your name, press enter, and then type in just the variable name, and press enter again, and you'll see it speak back to you. You're still writing JavaScript, not a new language. Node is simply evaluating it for you on the spot. You can exit with Ctrl+C. Now, before we continue, I prepared for you a starter workshop. You can get its repo from the video kit down below. This will be your workspace for the entirety of this crash course. Inside the 01 Node.js folder, create a file called hello.js. Inside of it, type console.log, double quote a string, Node is running this JavaScript file. And you can run it by typing node hello.js in the terminal. Instant output. No browser, no HTML, no script tags. Just JavaScript running like a backend language. But here's a twist. If you add console log window and run it again, you'll notice that it says window is not defined. And this totally surprises beginners. But it's important to say that JavaScript language does not include window or document objects. Those come from the browser environment, not JavaScript itself. So things like window, document, local storage, DOM APIs, alerts, and more, those come from the browser. But Node provides different set of tools: a file system, FS, network utilities, streams and buffers, events, and built-in modules like HTTP, crypto, path, and OS. You can try importing one like OS, console logging it, and then console logging the platform. Node will print your operating system. The browser could never do that. This is good, But then how does a server come into the Node.js picture? Well, thinking about it, what even is a backend server? When you enter a URL, your browser sends an HTTP request to another computer. That computer then runs a server program that listens for incoming requests, figures out what the request wants, and sends back a response. No magic. A server is just a program running forever on a machine. So let's create one. Right within your PERN stack starter, within Node.js, create a new file and call it server.js. Within here, go ahead and import HTTP coming from HTTP. This is one of the built-in features in Node.js. And you can see right here that within WebStorm, I can enable coding assistance for Node.js so that it automatically knows where this HTTP is coming from and what it is all about. Right below it, we can create a new server by saying const server is equal to http.create server. Within it, you can open up a new callback function. And within the params, we get access to the request and the response of that server. Then within the function block, we'll say res.writeHead 200 to set the status of the response to 200, and the content type of text/plain, and res.end to end the response, where we can say something like, you just built a server in Node.js. The only thing you have to do is to make the server listen for incoming requests. So I'll set the server.listen to 3000 port, and I'll render a callback function, within which we can console log the message that'll start when we run the server, and it'll be running on port localhost 3000. This is going to be on our local network, so it'll start with http://. So with that in mind, you can now open up your terminal and cd into this 01 Node.js if you haven't done that before, inside of which I have my server.js. The only thing you have to do is run node server.js, and you'll see that the server is running on port localhost 3000. So if you click on it, you should be able to see a blank page that says you just built a server in Node.js. Because a server is nothing more than a program that is running indefinitely, waiting for some requests, and then giving you back some responses. But Node isn't just running JavaScript on the server. It is an entire ecosystem of different tools and libraries built right into it. And covering all of this would turn this crash course into a week-long live stream. That's why I'm currently building the ultimate backend course, which is going to be the most detailed course ever. A deep dive into Node internals, networking, architecture patterns, production systems, scaling, everything. Join the waitlist by clicking the link down in the description. And if you're a JS Mastery Pro member, you'll even get the preview of a couple of lessons as I'm developing it, and a full access as soon as it drops. And great, you've now built a server, so that's it, right? But not really. Building servers using only Node.js becomes painful very quickly. Raw Node requires you to manually inspect rec.url, parse bodies yourself, handle errors repeatedly, re-implement the routing logic, and even build your own middleware system. It works for tiny experiments, but it collapses for real APIs. This is why developers build higher-level frameworks on top of Node. Express, Koa, Nest, Fastify, or Hono. But the one that shaped the industry the most, the one used in countless production systems, is Express.js. It's lightweight, it's flexible, easy to learn, yet powerful enough for apps of any size. It's the E in your PERN stack, and it's what I'll teach you next. Express has been around for more than a decade, which in web development time is practically prehistoric. The fact that it's still the default choice for building Node backends tells you a lot about just how well it was designed. At its core, Express is minimalist. It doesn't force a specific architecture. It doesn't ship with a database layer, and it doesn't try to tell you how your folder should look like. It gives you three essentials: routing, middleware, and request and response handling. Everything else, your choice. You assemble only what you need. This minimalism is a huge advantage. You aren't dragging around features you never use. You aren't fighting an opinionated structure. You build what you want, how you want it. And despite being simple on the surface, Express is a serious production-ready tool. Major companies rely on it. IBM uses Express in their cloud services. Uber uses it for parts of their infrastructure. PayPal migrated from Java to Node with Express and saw dramatic gains in speed and developer productivity. Even companies like Netflix and Trello still rely on Express-based systems. Startups love it, and enterprises trust it. But that doesn't mean Express is the right choice for every project. Express shines when you need a fast, flexible, and no-nonsense backend with REST APIs, microservices, and mobile backends. It gives you complete control without pushing a rigid design. Middleware lets you extend behavior cleanly. Beginners pick it up quickly, and experts can scale it confidently. But you want to skip Express when you want built-in structure and architectural patterns. If that's what you want, go for Nest.js. If you want a full-stack, front-end-driven workflow, go for Next.js instead. And if you need extreme performance and very low overhead, go for Fastify. But for the majority of API-driven projects, Express is the practical, stable answer. And Express is all about building APIs. But what is an API really? The word gets thrown around constantly, but most explanations are either too abstract or too vague. An API is simply a structured way for one piece of software to talk to another piece of software. When you make an API request, you send a URL explaining what you want, a method, which action to perform, with optional data, like a new user to create, and optional headers, like the metadata about the request. So an example request might look something like this. You make a post request to add a new comment with a text of great video and the following user ID. And then the API responds with a status code, a JSON body, and some optional headers that looks like this: 201 created, text great video, created ad, and an ID. Clear, structured, and consistent. And if you want to go much deeper into APIs with diagrams, real-world examples, and plenty of hands-on practice, I break everything down in much more detail inside my upcoming Ultimate Backend course. So join the waitlist if you haven't already. But now, let's build an API. Back within our code, cd out of 01 Node.js and cd into 02 Express.js. Then open up that folder, and the first thing we want to do is initialize a new package JSON by running npm init-y. As you can see, this will have generated a package JSON file. Now, to make this an Express application, go ahead and run npm install express. Then you'll see within your package JSON that there is one dependency called express, and under scripts, we can remove this test script and instead add a dev script, which will start the developer server by running node --watch server.js. This will keep track of all of the changes within a server. So let's create the server, which is going to be very similar to what we had in our original application. So I'll go ahead and copy this entire part and simply paste it into a new server.js file that I'll create within the Express.js folder. This time, it'll be even easier. Instead of importing HTTP, we will simply import Express coming from Express. Then, to create a new Express application, you can just type const app is equal to Express. And this will create a new instance of the Express application, giving you an app object that we'll use to define routes, add middleware, and configure our server. Typically, you also want to define a port right here. So I'll say port is set to 3000. Then, instead of writing this server, HTTP create server, and then server.listen, we'll do it in a bit of a simpler way by saying app.get and we'll listen on /route, which is the root route. And then as the second parameter, you can define the request and the response objects. And then you can open up the function block where you can define what this specific route does. So what we've created right here is a route. So you can say res.send hello from the, and we're now building a specific API. For this demo, we can maybe build a cars API. So hello from the cars API. We'll be returning some car data. And then to actually be able to call this root route, we need to run app.listen on a specific port. And once we start the server, we can also run a console log. Server is running on, and now we can say HTTP ://localhost, and then it's not hard-coded anymore. So instead, we can render a dynamic variable of port. But for that, you have to wrap this in a template string. Now, if you open up your terminal, I'll do it right here so we can see both the code, and run npm run dev. You'll immediately get an error saying that you cannot use an import statement outside of a module. That's because Node.js applications still use older require syntax. To be able to use modern ES6+ imports within your package.json, you have to change the type of the application to module. If you change that and rerun your application by stopping it from running by pressing Ctrl+C and then running npm run dev, you'll see that now the server is running on localhost 3000. If you open it up, you'll see hello from the cars API. Perfect. This is a functioning API with the one API route. But that isn't all that interesting, is it? We have to add more routes that'll determine how our API behaves for different URLs and HTTP methods. So you can add another route, something like app.get /API /v1 /cars with a request and response objects that'll simply res.send all cars. So imagine that here we have a database, and we'll talk about that soon. But if we had it, when a user makes a request to this API route, you will return all the cars from the database. Then right below it, I'll do app.post. So we're changing the HTTP verb from get, retrieving something, to post, which is the endpoint to create something. I'll again make it the same, API v1 cars. Yep, you can have multiple endpoints as long as they're different verbs, request and response. And here I'll do a res.send new car. We have created a new car. See, a post request always implies that the client is sending new data to the server, typically in a JSON format, and expects the server to create something based on that data. Even though this example only returns a text message, this is the endpoint where you would normally extract fields from the request.body, validate them, and then insert a new car into your database. After the get and the post, we have the third one, which is the put route. So app.put, again, API v1 cars, but this time you want to add a :/ID at the end of the route. This :ID segment in the path is a dynamic parameter, which means that Express will replace it whatever value appears in the URL and then expose it through rec.params.id. So for example, if somebody calls your API with the following text, so it's going to be API v1 cars 5123, then this variable will have 5123 value inserted into it. This is called a dynamic route. This is typically used when you want to update the information for a specific resource, in this case, a car. So I'll say res.send update a car. After that, we can do another one to delete a car. So similar to what we've done before, we want to get a specific ID so we know which car we're deleting. And then you simply want to use the app.delete route. Again, typically within here, we would enter our database, find the car, and then delete it. But here right now, we're just sending a message saying that we are about to delete it. And finally, there's one more type of a common route, which is app.get, which we've had so far. But this time, it's cars and then an ID. Not just cars, where we're getting all the cars, but here you want to get the details of a specific car. So this is how a typical, very simple API would look like. But notice the repetition. the API v1 has been repeated everywhere. So if you were to update your API to v2 and then forget to change it in a couple of places, that would just be a mess. So thankfully, Express gives you a cleaner way. They're called group routers. So you can say const router is equal to express.router. Then you can define that router right here at the bottom by saying app.use. So we're using a specific router, and it'll start with API v1, and we'll feed the router that we just created. This means that every single route with this router will start with API v1. So what we can do now, instead of repeating ourselves every single time, we can just simply remove this, only have the needed parts, which is the either / or the colon ID, but then instead of using the regular app, we're now gonna start this with router. Router.get, router.post, put, and so on. Hopefully this makes sense. No need to repeat ourselves because it already knows that all of these routes start with this prefix. But now let's add some real car data. Right here at the top, I'll say let cars is equal to an array where we can have a couple of objects with an ID like 1, a make of the car, like let's do a Toyota. We can do a model like a Camry, and maybe a year, 2022. And we can also add a price. Let's say that it's 28,000, let's say it's USD. And you can duplicate this a couple of times, change the IDs, the makes. In this case, let's say we have a Tesla Model S, year 2023, with a price of 25. And then finally, we have a Ford, let's say Model F-150, and with a year of 2021 and a price of 35. So what you've created right here is a sort of a database. Not really, right? It's just an array, but what's missing to make it into a database is data persistence. We'll talk about that very soon. Now, to be able to retrieve those cards through our API, we have to tell Express to parse JSON from incoming request bodies. We can do that by typing app.use express.json. Without this, when someone sends JSON data to your API, you wouldn't be able to read it. This is one of those essential middleware functions you'll use in almost every single Express app. So now we can replace this getAllCars route by simply saying res.json cars. And then we can also make it /cars, right? Then we're going to return all the cars. You can give it a shot by opening up the app in the browser and heading over to localhost 3000 API v1 cars. Now you'll see that I have an extension opened that renders all of that JSON in a nice format. You can find a simple Chrome extension, something like JSON Viewer, and that should work on your end too. But otherwise, it's going to look something like this. It is just an array of different objects. Perfect. Now what you could do is also implement all of the other functionalities. For example, getting a car by ID. I'll take this code right here and put it in the second place right after getAllCars. And think a bit about it. How would you get a car with a specific ID? Well, first, you would have to know that we can get the ID from rec.params.id, as I explained before. You would also have to know that everything that we get through the params is in a string format by default, which means that we have to convert it into a number if we want to do some comparisons with it. Then we want to find a car that we're looking for by running cars.find. We want to find a specific car where its ID matches the ID that our user is searching for. If there is no car, then we can return some kind of a res.status of 404 and the message of car not found. Else, if we can find the car, we can simply return it by saying res.json car. Now, back within our application, if you search for localhost 3000 API v1 cars and then / maybe 5, you'll see car not found. But if you change that to 1, 2, or 3, you'll be able to see that we directly get back the data. Now, you wouldn't show it to your user like this. You would most likely show a nicely designed car marketplace page, we're going to show that car's price, some photos, title, and more. And now you could go ahead and implement all of these other functions to make this simple API actually functional. I'll leave this as a challenge to you. Try to figure out how you can append a new car to the cars array, how you can update a car, and how you can delete a car. All of it has to do with modifying this array. Pause this video and give it a shot right now. I'll continue with the solution in 3, 2, 1. Okay, how would we implement this post route? It would look something like this. We make a post request to /cars, and then the user that's making this API request will have to pass all the important information needed to create it. In our case, that is the make, model, year, and the price. All of it, which we'll get access to through the request.body. You might be wondering, how is somebody going to pass these pieces of data? So far, we've only seen how GET requests work. You simply change something in the URL, and that's it. That's because by default, when you make a request in your browser, it makes a GET request. But to make a post request, you'll need some kind of an HTTP client tool. It can be Postman, Insomnia, or in this case, I'm using HTTPy. Here, you would type 3000, right, for localhost 3000, API v1 cars, just to verify that our API is working, and we can see that it is. But now, here we have the options to also make all sorts of different requests, like a post request, where we can pass the additional body into it. In this case, we're passing JSON. And as we know, we have to pass a make, a model, a year, and a price. Perfect. It'll look something like this, but we have to think of another one. So let's go with something like a BMW. Maybe we can do a 4 series, year 2020, with a price of about 15. Now, when you click send, this HTTP client will have made an HTTP post request to our server, and you'll see that we got a 201 created, which means that it got added to our array. So now if you again make a GET request, you'll be able to see it right here. The way it works is we extracted all of those values that we passed through the request.body. We checked if some were missing. If that is the case, we threw an error. But if none were missing, we created a new car object by increasing its ID to be the new one in the list. We specified all of its variables, and then we pushed it to a car array and returned the newly created car. Pretty cool, right? Situation is pretty similar for the updates too. So if you wanted to update a car, that would look something like this. You would first figure out which car you want to update. You would then find the index of the car you want to update in the database. If it doesn't exist, you would return a 404, car doesn't exist. Else, you check whether you have provided all the fields needed to update it. If they exist, then you make the modifications to the car in the database, and then you simply return the updated car. And finally, there is a delete a car request, which is even simpler. You again have to get the ID of the car you want to delete. Then you want to find the car. If the car doesn't exist, you return a 404. If it does exist, you simply remove it from the array. And with that, you've implemented a very simple API with a non-persistent database. One part that is missing right here is some kind of logging, because as your API grows, you'll want to run certain code for every request, such as logging, authentication, caching, rate limiting, or performance tracking. Doing this inside of every single route would just be a mess. So instead, Middleware solves this. Middleware allows a specific portion of your code to be called before or after any single request that a user makes. So right here on top, let's add a middleware. You can do it by running app.use. You get a request, a response, and the next object. This next object is what makes middleware, well, middleware, because middleware has to know when it's ready to move the action to the next API call in line. That's what we use this next object for. So, for example, let's create a middleware that simply logs out the timestamp of when a specific request is made. So const timestamp is equal to new date, and we want to get access to the ISO string. So dot to ISO string, and we want to console log it in this format by first rendering array signs, timestamp, and then we want to also render the rec.url as well as the rec method so that we know what the user is doing. Now, every time somebody makes a request to your server, you'll be able to see it in your terminal thanks to this middleware function. Let me show you. I'll open it up, and immediately, as soon as we load localhost 3000, you can see that somebody made a GET request to the root route. But there is one problem. You can see that we never provided the next functionality to this middleware, which means that it intercepted our try to get to the root route and stop there. It simply logged its thing, and that's it. What you want to do instead is whenever your middleware finishes doing what it's supposed to do, in this case, log the timestamp, the method, and the URL, we can simply call the next method and allow it to continue going where it needs to go. So now, back in the browser, we get a notification that we made a request, but then immediately we can see the page we're supposed to go to. So if we go to API v1 cars, you can see that we made a request to API v1 cars at this specific time. Middleware functions can be used for all sorts of different things, like logging, what we've done right here, security, compression of files and images, validation, authentication, error handling, performance metrics, and more. It is the backbone of all Express applications. Now, features like rate limiting, bot detection, or user abuse prevention are all things that developers attempt to build manually and then quickly regret it. That's why throughout this course, I'll show you how to use Arcjet properly so you don't just build, but build in a way that's safe, scalable, and production-ready APIs. Basically, Arcjet provides these protections with clean middleware APIs. Since we'll be using it both on the front end and back end, go ahead and create your free account right now. The link is down in the description. You can click sign up for free, sign in using GitHub, and you got your site key, which we'll use later on to secure our application. So in this one single lesson, you've built a complete REST API. And not only you've built it, but along the way, you've learned what Express is and why it remains the industry standard. You learned when to use Express and when to choose some alternatives, how routing, parameters, methods, and status codes work, how to structure routes cleanly with routers, how to build CRUD operations, how to parse JSON bodies, how to add middleware for shared logic, and how real APIs are shaped in production. But there's one huge flaw in the API we built, and that is that your data disappears every time your server restarts. So if you go ahead and add some cars, then restart your server, and then try to get them, they're not going to be there. That's happening because you stored everything inside of an array. Arrays live in memory. When the process dies, they die with it. So how do you store data permanently on a server? For that, you need a database. And that's where the next piece of the PERN stack comes in. A database is far more than a hard drive where your data sits for decades. It's a full system engineered to store, retrieve, protect, and organize information in a safe, consistent, and insanely efficient way. A proper database handles many users accessing the same data simultaneously. It keeps everything consistent, even when errors occur. It allows you to search millions of records in milliseconds, ensures nothing is lost if hardware fails, and it even manages indexing, caching, transactions, and concurrency behind the scenes. It's not just storage, it's a data engine. So when people talk about databases, you'll almost always hear two categories: SQL and NoSQL. Two philosophies, two models, two very different ways of structuring data. SQL stands for Structured Query Language, a language created in the 1970s and still the backbone of modern data systems today. A common misconception is that SQL is a database. No, it's the language databases use to communicate. SQL databases organize data into tables. Think spreadsheets with rows and columns. Every table has a schema, clearly defining what fields exist, what types of data do they store, and how tables relate to each other. Most popular SQL databases are Postgres, MySQL, Microsoft SQL Server, or Oracle. SQL databases are ideal when your data has relationships and structure. Think users, accounts, transactions, merchants, or companies. These aren't just loose documents. They connect to each other through clear relationships. SQL databases handle this beautifully. They also guarantee correctness through constraints, foreign keys, unique indices, transactions, and isolation levels, which in simple terms means that operations are either complete fully or not at all. Nothing's partial or corrupt. This so-called ACID compliance is why industries like finance, healthcare, and e-commerce rely on SQL systems. But hey, what about NoSQL? NoSQL databases take a very different approach. They shine when data is unpredictable, schemaless, or semi-structured, and it spreads across many servers or it changes rapidly. Think logs, analytics, caching, or event streams. This is why many real-world systems use both SQL and NoSQL. A company might use Postgres for user accounts and business logic, MongoDB for flexible content, and Redis for caching and sessions. This is called polyglot persistence, using the right tool for each job. But when learning full-stack development and when building the vast majority of practical business applications, SQL is the ideal foundation. Okay, so we've decided. SQL it is. But which one? MySQL? SQL Server? Oracle? Postgres? Among all SQL databases, Postgres stands as the most powerful, modern, and open-source relational database in the world. Developers consistently rank it as the most loved SQL database, and not by accident. A couple of reasons why it's so great is that it's truly open source, so developers can use it freely for commercial apps, startups, or even cloud platforms. It has many cool features supporting data types like JSON, arrays, IP address types, and even custom types you define. You get flexibility without losing relational structure. It also includes built-in full-text search, window functions, common table expressions, and advanced indexing, which means you can express incredibly complex logic with elegant queries. It's also serious about data integrity, so it's fully ACID compliant, protecting your data from corruption. It has great performance, best in class, handling joins, aggregation, and complex queries efficiently, even with large datasets. And it also has a legendary community. Documentation is great, tutorials and examples are everywhere, solutions to almost every problem already exist, and modern AI systems work beautifully with Postgres' structured data and metadata. So for modern web development, especially for learning, Postgres gives you enterprise-grade power for free. But here's what most tutorials don't tell you. Knowing what a database is doesn't make you ready for real-world systems. Your database isn't just storing rows. It's handling connections, locks, indices, query planning, background jobs, caching, concurrency, and traffic spikes. And when something slows down, breaks, or behaves oddly, you need to know exactly why. This is where developers separate into two groups. Those so-called vibe coders who hope everything works, and engineers who understand their systems end to end. And the new AI-driven world you're entering rewards the second group. This is where I want to introduce you to Site 24/7, which gives you real-time visibility into your Postgres server and your backend. It detects your slow queries, CPU and memory analytics, disk performance, connection usage, transaction behavior, and even spikes and anomalies. So whether you're deploying a side project or preparing a production app, monitoring is not optional. It's part of building real software. Since later in the course, we're going to integrate proper monitoring using Site 24/7, let's go ahead and create an account right away to make our job easier. Click the Site 24/7 link in the description and then start your free trial. You can simply sign in using Google. And then when you're in, you'll be able to see something like this, which means that very soon, once we start building our big PERN app, you'll be able to implement all of these features within it. And now that you know more about databases, it's time to learn the P in the PERN stack. Before you write your first SQL query, you need a mental model of how Postgres stores information. Once this structure clicks, everything you do afterward becomes far more intuitive. Think of Postgres as a multi-level hierarchy. First, you have the database server. This is your Postgres instance running on a machine. One server can host multiple separate databases. Each database is its own container for data. Your car dealership app might have one database. Another app might have a completely separate one. They don't interact. Inside every database are schemas. By default, everything lives in the public schema, and most applications use that without needing anything else. Inside schemas are tables, the core of SQL. A table is like a spreadsheet with columns that form the structure and rows that contain the actual data. Each column has a data type. Some of the most common Postgres types are integer and big int for whole numbers, numeric or decimal for money and exact decimals, real and double precision for scientific floats, varchar or text for strings, boolean for true or false, date and timestamp, and JSONB for structured JSON storage. Tables can also enforce constraints. Primary key uniquely identifies each row. Foreign key links rows between tables. Not null requires a value. Unique prevents duplicates. And the check validates some custom rules. You don't need to memorize everything. You'll naturally absorb these concepts as you build real applications. Now, how do you actually install Postgres? There are a couple of ways to get it up and running, depending on where you're learning, what you're building or deploying. First, there's the local installation. It's the classic approach. You install Postgres directly on your machine. It works offline, it's great for learning, and you get full control over everything. You can download it from the official website, or if you're on macOS, you can just use Homebrew to very quickly install it. Later, when deploying to production, you'll typically host your database using a cloud provider like AWS RDS, Google Cloud SQL, Azure Postgres, DigitalOcean, or Railway. AWS RDS is the industry standard, but it does have a steeper learning curve. If you want a structured walkthrough for installing Postgres correctly, connecting to it, testing it, and deploying it using AWS RDS, all of that is covered in detail within the Ultimate Backend course. You can join the waitlist by clicking the link down in the description. The second way to set up Postgres is by using Docker. If you don't want Postgres installed directly on your system, Docker is a clean alternative. It runs Postgres in an isolated container with zero clutter on your operating system. You can simply go to Docker Hub and find the Postgres image. Once you're done, you can stop the container and your system stays clean. The trade-off is that you still need a real cloud database when deploying your app. Thankfully, I've also created a full Docker course for JS Mastery Pro members. I'll link it somewhere below. And the third way is something known as serverless Postgres. If you don't want installation pain at all, this is the modern, frictionless option. Services like Neon, Supabase, Vercel Postgres, Zeta, or PlanetScale give you instant, cloud-hosted Postgres databases. They provide a couple of benefits, like auto-scaling, free tiers, backups included, connection pooling, beautiful dashboards, and zero local setup. The only downside is that you rely on the internet access and the provider's uptime. While local installs and Docker are essential skills, they often take beginners into debugging tunnels. So instead of wrestling with setup, this crash course focuses on learning SQL quickly and clearly. For that reason, we'll use a browser-based SQL playground called dbfiddle. It lets you create tables, insert data, run queries, and see results instantly. No installation, no configuration. And later, when building your real PERN app, you connect it to a serverless Postgres instance using Neon. So simply head over to db-fiddle.com and choose Postgres. This means that you already have a database and you can now start creating your first table. In our case, let's continue to the cars example that you've been working on within our Express API before. To create a table, you simply need to say create table and then enter the name of that table. In this case, we can call it cars. So what this does is it simply creates a new table called cars. Then you can open up a pair of parentheses, and within it, we can start declaring different keys, or in this case, columns. First, I'll add the ID, and I'll also make that ID serial, primary, and key. Now, what does this mean? Well, this creates an integer column that automatically increments for each new row. See, serial is a Postgres shortcut that creates an auto-incrementing integer. Primary key means that this column uniquely identifies each row. Then, right below it, we can define our second column, which I'll call make. Let's make this var car, and within it, add 100. Keep in mind that this is not car, it's char, which is short for characters, and we'll make it not null. This creates a string column that can hold up to 100 characters, and not null, well, means that every car must have a make. This field can be empty. We can also duplicate that below, and instead of make, I'll also add a model. Then, right below the model, we'll add a year, which is going to be an integer that is not null, which means that we'll store the year as a whole number. Right below it, we can also add the price of the car, and we'll make it numeric. That's going to be 10, 2, like this, and also not null. What this means is that we're going to store the price with up to 10 total digits and exactly 2 decimal places. This is perfect for money because it's precise. No floating point rounding errors. Then, right below the price, we'll add a created at field. It'll be a timestamp that's going to be default, and by default, it'll be the current timestamp. So if you don't provide a value, Postgres will automatically fill it in with the current timestamp. Make sure to spell it correctly, and you should see it get marked as blue. Notice how by default, we are being thoughtful about our data types and constraints. You're not just storing stuff, you're defining exactly what valid data looks like. This prevents bugs and inconsistencies before they even happen. Now, run this query in your online editor. You should see a success message saying that the table was created, or maybe something like this. This happens because we can't have trailing commas in SQL. This is not JavaScript. And we can also end it with a semicolon. Now, if you click Run again, you'll see that this time, query will get successfully executed. So now that we've created our table, let's learn the 4 fundamental operations: create, read, update, and delete. We'll start by inserting some cars into the database. We can do that right here on the right side by saying insert into cars, specifically the make, the model, the year, and the price. And I'm going to zoom this out a bit so you can see a bit better. And then we'll insert the following values, something like BMW. Let's also do a 4 series. We'll do a 2022, for example, and 2800. Now, if you press run, you should be able to see a success message where one query got executed. Now, we can also add multiple cars. You simply have to say values and then add a comma and duplicate the values that you're inserting within these columns. So the second one can be something like, let's do a Ford Mustang 2021, 25K. Let's also do 2 more. So I'll duplicate it and indent it properly. For the third one, let's go with something like a Tesla Model 3. And for the fourth one, we can do a Honda Civic. Perfect. Now, if you run it, you will see that we have to remove this trailing comma. And with that, the query got executed successfully. So now that you've inserted the cars, you need to know how to retrieve the data. Doing that is super simple. You simply have to say select. So say select what you want to get. In this case, everything. Everything or the asterisk or the star means all columns. This returns every column of every row in or from the cars table. You should be able to see all 4 cars we've inserted. So if you run it, there we go. You can see the table with 4 cars. But often you don't want all columns. So let's simply get the make and the model. So say select the make and the model from cars, and you can run it. This way, you're getting just the table of the information that you need. Much cleaner. Now, let's add some conditions with the keyword where. So select everything from cars where. Now you insert the condition. For example, year is equal to 2022. There should be 1 car that matches that query. So if you click run, you can see the BMW. You can also combine conditions. So let's say that you want to get the year of 2021, where there are 3 different cars. And let's say these 3 different cars have different prices. One is 25, one is 30, and one is 15,000. So we can say year 2021 and price is lower than something like 27,000. So if you now run it, you'll be able to see that both the Ford and the Honda match the criteria of 2021 and the price is lower than 27,000. You can also sort the results by adding the order by keyword price. And then you can do it descending, for example, by saying DESC. So now it's going to show the one with the higher price first, or you can do it ascending, and then it's going to show one with the lower price first. But what if you want to get all the cars like this? So select everything from cars, but you only want to get the 3 cheapest cars. Order by price in an ascending order, and then a limit to 3. This will return only the 3 cheapest cars. Perfect. So now you know all the most important keywords for querying databases using this pretty simple database querying language. But let's say that the price of the Honda Civic has changed. You need to update it. You can do that by saying update cars set price equal to, let's do 26,000, where ID is set to 2. So we're updating the second ID. It is the Ford Mustang, so it is this one right here, and we're updating it from 25 to 26. So if you run it, and then you display all the cars, you'll be able to see that we successfully updated. Finally, how do we delete cars? It's pretty simple. You just use the delete keyword, delete from cars, where, and then you can simply define the criteria. For example, where ID is equal to 2. So now if you click run and you select it, you'll see that we're missing the car with the ID of 2. If you accidentally forget the where clause in the delete and just say delete from cars, would be catastrophic because it would delete your entire database, or in this case, your entire table. So far, you've worked with a single database. Of course, there's so much more to Postgres and SQL, such as relationships between the tables and how we merge and connect the data within them. I might talk about that in more detail when we actually build our application. But for now, the only thing I care about the most is that you now understand how Postgres structures data, how you can create tables, and how you can insert, read, update, and delete data. But how do we connect our Postgres database to our Node server? And how do you use SQL syntax inside your Express backend? The answer doesn't have one correct path. It depends on the tools that you choose. You've now learned how to build an Express API and how to write SQL in Postgres. The next step is connecting the two so your backend can actually store, retrieve, and manipulate real data. This connection is the backbone of any full-stack application. Your React frontend sends a request, your Express backend receives it, and then your Postgres database stores and returns the data. This is what turns your code into a functioning system. There isn't just one correct way to connect Node.js and Postgres. Over time, the ecosystem has produced multiple approaches, each with its own philosophy, power, and trade-offs. So before you start wiring them together in code, let me quickly walk you through the three major options. The most direct way is to use the official Node Postgres library, PG. You write SQL as strings and execute queries using a connection pool, exactly like writing SQL manually, but inside your API routes. It looks something like this. You import pool from PG, you create a new pool connecting to your database, and then you query that pool by writing regular SQL queries. The pros of doing it this way is that it gives you maximum control. It uses 100% of Postgres' features with zero abstraction and transparent performance. But it has its cons. It's very repetitive. You have to write all of the SQL queries from scratch in string-like format. It's easy to make mistakes because you're working within strings, so there's no type safety and no schema management. Raw SQL is powerful, but quickly becomes fragile in real applications. But every other tool builds on top of this foundation, which brings you to ORMs, or Object Relational Mappers. ORMs let you interact with the database as objects instead of raw SQL. You work with models, methods, and types, while the ORM handles generating SQL behind the scenes. There are two major ORMs that dominate modern Node.js. They're Prisma and Drizzle ORM. Both are excellent, but they offer very different experiences. Prisma reimagined ORM design by giving developers a dedicated schema language, first-class TypeScript support, and auto-generated types and APIs, as well as tools like Prisma Studio. You can define a schema something like this: model car, and then you define the ID of a type integer, for example, the make, model, year, and so on, and then Prisma turns that into SQL and generates a fully typed client which you can use to write SQL queries in this way. Const cars, await prisma.car.findMany, and order them. So the pros are obvious. It's super simple, and you get incredible DX, developer experience, and it's fully typed. There are cons though, and that's that it performs heavy abstraction. You must learn Prisma's custom schema language, and it makes it harder to drop into raw SQL thinking. So if you want a clean, opinionated ORM, then Prisma is great. But if you want something light, SQL-friendly, and closer to the metal, then Drizzle ORM takes the opposite approach and says, stay close to SQL, stay simple, yet type safe. It doesn't invent a new schema language. It uses TypeScript to define your tables almost like writing SQL in TS form. Here's how you define a schema in Drizzle. You just import some stuff from Drizzle. You create a cars table by saying pg table cars, and then you start defining key value pairs like you would in a regular JavaScript object in a functional style. For example, ID is serial primary key, make varchar with a length of 100, not null, year, integer, and so on. And your query code will look even simpler. Const all cars is equal to await db select from cars order by cars ID. Pretty simple, right? It's essentially SQL written in a clean, TypeScript-friendly style, and when you need full control, Drizzle even lets you drop down to raw SQL without breaking the flow. It's flexible, powerful, and fits perfectly with everything. For this course, and later during the build and deployment of this project, you'll use Drizzle with a serverless Postgres database. It provides the perfect balance of simplicity, power, and transparency for learning full-stack development. Okay, enough with words now. Let's go ahead and connect a serverless Postgres using Drizzle ORM. Head to neon.tech and sign up for a free account. Once you're in, create a new project. For the project name, you can either choose the PERN crash course, or you can immediately use the project name of the final application that we'll build after the crash course is done. And that'll be Classroom Management Application, something like this. You can choose version 17 of Postgres on the AWS service provider, and you can choose the region that is closest to you, and click Create. Once you create it, you'll have to hook it up to your database, so go ahead to the Connect button and copy the connection string. Then go to 03 Postgres and create a new .env file right within it. There, you can paste the string you just copied, but let's call it properly. It'll be database_URL is equal to this Postgres connection string. Now, if you take a look at this Postgres folder, you'll notice that this is the same code that we've already talked about. You can head over into the server and you'll see this local square-shaped database we created before, but now we're moving it into real production Postgres database while still using the same API. To do that, we can use this Neon documentation page talking about Drizzle ORM connection. So let's head over to this step 1, and it is to create a TypeScript Node.js project, which we've already done. Then we can head over to creating a Neon project, which we have also done. And finally, we're ready to install Drizzle and a driver. So go ahead and copy these installation commands and paste them right into your terminal, but make sure that you are within the 03 Postgres, like this, and then paste the command you just copied. Let's wait a second until the installation is complete, and once it is, we can create a new file right here called drizzle.config.js in the root of our directory. This configuration will tell Drizzle where to find your schema and where to output the migration files. So if we head back right here, that's exactly the next step in the documentation. So let's go ahead and copy it and then paste it right here. In this case, we don't have a source folder, so make sure to remove it from here. So we point to our schema directly by saying that/schema.js, because in this case, we're using JavaScript. Then we have the output, and finally the SQL dialect, in this case it's Postgres, and then the database URL. Finally, let's create another file called db.js that we'll use to initialize and export our Drizzle client. So if you head back, that's going to be the next step. So you can go ahead and copy it and paste it right here. Import .env config, which is used to be able to read our environment variables. Then we're importing Drizzle from Drizzle ORM Neon HTTP and then Neon itself. We want to have a quick check to verify if the process.env.database URL is maybe not present. In that case, we can throw a new error saying database URL is required. Else, if it's here, we want to initialize a new instance of SQL by passing the database URL into Neon. Finally, we wrap the database with Drizzle ORM, and then we export it so we can use it within the other files. And that allows us to start creating our first schema. So go ahead and copy this code, and then let's create a new file called schema.js. This is how it typically goes. You first create your server, then you get your environment variables, and then you choose the ORM or object relational mapper that you want to use with your database, and you choose the dialect of your database. Then you set it up, and finally, we are ready to create our database schemas. Drizzle makes that easy. You can just import the things you want to use from it, and then you create some kind of a schema. Here they give us an example of demo users, but we can stick with something like cars because that's the example we had before. So we're creating a new table, PG table of cars, and then you're passing different properties or keys, or in this case, columns that each one of the rows in the database will have. First of all, the ID, which is going to be serial, which means that it's going to build one onto another, 1, 2, 3, 4, and it's going to act as the primary key of this specific row. Then we have the make of the car, which is going to be a varchar, which simply means a string. So make sure to import that from drizzle pg core. And it's going to be a varchar of make with a length of 100. And it must not be null. I will duplicate this for the model as well. So let's define the model, same thing. And then finally, we'll have the year of the car. So I'll say year is going to be an integer, also coming from PG core, called year, which must not be null. Then we'll have the price. The price will be numeric, also coming from PG core, with the name of price, precision set to 10, and scale set to 2. We typically use these configuration for the numbers when we're talking about prices. It's also not going to be null. And then finally, we'll have the created at field, which is going to be a timestamp. This timestamp will have a name of created_at, and it'll default to the current time. So default now. And with that, believe it or not, we have created and exported a new schema that we can use within our database. Now, for this table to actually get created within the database, we have to generate something known as a drizzle migration. And you can see that right here. So after defining your schema, you can generate migration files with DrizzleKit. This will create the necessary SQL files to set up your database schema in Neon. So let's run this command, npx DrizzleKit generate, and press enter. In a couple of seconds, it'll create a new SQL migration file, which you'll be able to see right here within the Drizzle folder, and you can see this SQL command. So basically, this JavaScript code that we wrote is gonna run this SQL command. And then, now that we have it, we need to be able to actually apply it. This command will then use the Drizzle config for the database connection and apply the migrations to our Neon database. So simply run the command npx DrizzleKit migrate. It's gonna ask you whether you wanna install DrizzleKit. Say why, go ahead please. And after a couple of seconds, you should be able to see either a successful or an unsuccessful message. In this case, it was looking for a drizzle config JSON file, but it was not able to find it. The reason why we got that message is because for some reason, our terminal exited the 03 folder. So cd back into it. Maybe for you, it worked from the start, and then simply rerun the npx DrizzleKit migrate command. This time, it'll be able to find it. And even though there's a warning right here, if you head back over to your Neon console and go over to the tables, you'll be able to see a new cars table created, and you can see that it has all the valid fields, such as created at, price, year, make, model, and the ID. This means that our migration succeeded. Now, back in the code, we want to modify the post request right here within our server, where we're actually adding the cars. So here we have a router.post, and we're inserting a new car in our imaginary database, or for now, we're at least pushing it. But now we want to write a query that'll actually create a car in a real production database. We can do that right here. Instead of this fake logic, we can just say const perform array destructuring to get access to this new car we created, and then make it equal to a call to the database by saying await db, which you can import from the file we exported it, and then you can say .insert. Notice that we're using the await here, so we have to make this whole function asynchronous because creating real records in the database takes time, so it's an asynchronous action. Now you have to define in which specific table do you want to insert this new car. And we want to insert it within the cars table, so simply type in cars, but this is not going to refer to our cars fake dummy array of cars. No, I will completely delete that. And instead, we're talking about the cars coming from our schema.js. These cars, this is the real table. So after saying .insert, we have to say what we're inserting. We're inserting the following values: the make, the model, the year, and the price. that we are accepting as request body into this post request. And we want to say dot returning, which gives us back the data that was just inserted, so we can pass it back to the front end. Great. So now open up HTTP, head over to API v1 cars, but specifically choose the post request, and under the body, pass the make, the model, the year, and the price, and submit it. Oh, and before that, make sure your server is running by running npm run dev right within your terminal. And once that is done, now we see a real 201 right here within our API. And of course, we get the things like the make, model, year, and the price we just passed. But what I'm super excited about is that we also now have the ID and the created fields, which are coming directly from the database. So now, if you go ahead and create a second car, like a BMW 4 Series, let's do that right here, and you click send, you'll see that the ID will be incremented by 1 and that the created ad field will change as well. So now if you head back over to your database and reload, you'll see that under our cars table, we now have 2 cars waiting for us right here in a persistent production-ready database. Now, if you want to take it a step further, you can update our router.get from just returning this fake cars array, which no longer even exists, to returning a real one by first fetching all cars by saying all cars is equal to await db.select.from the cars table. And of course, we want to make this asynchronous, and then we can res.json all the cars. So now if you get back to HTTP and you make a GET request to API v1 cars without passing anything in the body, you should be able to see an array of 2 cars we just created in our persistent database. Wonderful. Now, you should be able to follow along and apply the same approach to the remaining routes using the SQL fundamentals you've learned so far. But of course, you're not just here to write simple queries. These are building blocks. And right after this crash course, you'll take these skills and build a full production-grade application from scratch, including queries, relationships, APIs, and everything in between. You'll get there. But for now, push yourself a bit and try rewriting this fake dummy cars data, which is technically just an array, into a real persistent SQL-hosted database. And with that, up to this point, you've learned Node, Express, and Postgres, the entire backend. But none of that matters to the user unless they can actually see and interact with the data. So, how can you display your data and add features so that users can actually see them on the page? That's what we'll go over next. All right, let's move on to the final piece of the PERN stack, React. It arrived in 2013, right when Node.js and frontend tooling had matured enough to support a component-based architecture. Fast forward to today, React is the most widely used UI library in the world. It keeps maturing year after year, introducing new component types, rendering models, and optimization techniques that push the boundaries of what's possible in the browser. And although I said React is a UI library, it's actually more than that. It's a complete new way of thinking about building interfaces. Some of its core strengths include component-based architecture, because React breaks your UI into reusable pieces called components. Each component manages its own logic, UI, and styling. This makes large applications easier to build and maintain. So instead of manually updating the DOM, React lets you describe what the UI should look like based on the state. And then when data changes, React officially updates what's necessary. It does that by using something known as a virtual DOM to minimize expensive browser DOM operations and makes updates faster, even in very complex UIs. It has a massive ecosystem of libraries that work with it, such as TanStack Query, Redux, Tailwind, and more. And recently, we also got React Server Components. They let you run components on the server for faster load times and improved SEO. And frameworks like Next.js are taking this even further by providing so many different rendering strategies. Let's dive into React. Head over to 04 React.js part of the PERN starter. We can do that by simply cding back into the root of the application and then cding into 04 React. Once you're there, we can set up React by following the documentation from Vite. Vite is a front-end build tool. So if you click Get Started and then scroll down to Actual Installation, you'll be able to see how you can quickly scaffold your first Vite project. So simply copy this command or write it with me by running npm create vite add latest, and you can also add a / to create it in the current folder. Then install the create vite installer, and it'll ask you a couple of questions, such as current directory is not empty. We can say ignore files and continue. We are doing React right here as part of the PERN stack, so choose React. If you want, you can totally go with TypeScript here, but since this is just a crash course part of the course, I'll stick with JavaScript. We can use this experimental roll down Vite. I don't think it's going to make any difference for this crash course. And we can run npm install to set up our project. It'll quickly spin it up on localhost 5173, so you can command click it to open it up right in your browser. You'll be able to see just a simple front end, which is already good. It's refreshing to see something actually moving on the screen as we've been looking at the backend code for so long. Since we're working with frontend, I'll collapse the browser right here so we can see both the code and the website at the same time, now that we actually have something to see. And I'll start by completely deleting the app.css file right here, which will remove the styles. So you also have to remove it from the app.jsx. If you save it, you'll see that some of the styling will break. Then if you head over to index.css, you can also remove everything from here, and we'll write a couple of styles of our own. We'll do a typical CSS reset by selecting all elements and setting the margin and padding to 0 and the box sizing to border box. Then we'll set the body elements with a font family of Arial, and we can also use sans serif as the backup. We'll then do a background color of, let's do hash F0, 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 a color of the text of hash 333, a line height of 1.5, and a padding of 20 pixels. This will give us a nice clean slate so we can actually see some cars on our homepage. So to be able to do that, head over to app.jsx and remove everything from this page, but quickly spin up a new functional component by running rafce. This is a shortcut that creates a new React arrow function export component, so you can save it and you'll be able to see the app. If for whatever reason this shortcut didn't work for you, you might need to head over to plugins or extensions and then search for modern React snippets and install it. You might need to reload your IDE and then it'll work. Once we're there, you can render an H1 that'll say something along the lines of welcome to the car store. That's what this whole demo example has been about. Then we can further style this element by heading over to our index.css and selecting H1 elements, give them a text align of center, a color of 333 if needed, and a font size of 2 rem to make it a bit larger. Now, for the first time ever, we'll create a new component. This is what React is all about, making sure that our UI is composed of multiple repeatable components. So right within the source folder, I'll create a new folder called components. Within it, you can create a new component called car.jsx and run rafce. This will spin up a new car component. Then if you head back over into the app, right below the title, you can now render a UL, an unordered list, and render the car component that we just created. Of course, this is just one single div right now, but no matter how much code we put into this car card and we style it and we render additional JSX, we'll be able to easily replicate it without duplicating the code as many times as we want. So you'll be able to see 3 different car cards. And this may feel like we're rushing a bit And that's because this is only the beginning. React has so many things, from components to props that we can pass into those components, to state, hooks, effects, context, routing, and so much more. So if you want a proper beginner to advanced React knowledge, including hooks, React server components, state management, and best practices, to learn all of this properly, please watch the complete React crash course on YouTube. It takes you from zero to a level where you can confidently continue watching this course. I'll link it below. For now, you'll continue with the part that matters for this project, and that is connecting your frontend to your backend and learning how to create a full stack application. So head over to your 03 folder, which is actually a fully working backend with a functional database. And for that, we'll need a new terminal. So I will rename this to frontend, and I will create a new one called backend. Within it, I will cd into 03, and I will run npm run dev to run it on localhost 3000. Now we have two applications running, frontend in one terminal and backend into another. This is real full stack. So now, if you remember, if you make a regular request directly from the browser in your URL bar, and you type something like localhost 3000 /API v1 cars, what kind of an API request will this make? Which verb will it use? It's of course the GET request. So if everything is working correctly, and if your backend is running, if you run this, you should be able to get a JSON output of the two cars we've created using our HTTP client not that long ago. But now we want to make sure that our front-end application makes that call, not us. And we can do that right here within this application. I'll do that by creating a new use state. So you can use the use state snippet, which will quickly create it. The name will be cars, set cars at the start equal to an empty array. And make sure to import use state coming from React. Then we'll use another hook called use effect, which requires the callback function as the first parameter, and then the dependency array as the second. This dependency array, if empty, means that whatever is within this callback function will be called as soon as this component, or page in this case, mounts. So in this case, only at the start when we reload the page. So what do we want to do then? Well, we want to use a fetch request to point to API v1 cars. And then once we get it, we want to get the data by running response.json on it. Then we want to extract the data, and we want to set it to the state like this. And of course, if some error happens, we can catch it and console log it. So now let's console log the data that we're getting right here by saying console log cars. I will reload the page and open up inspect element where we can open up the console. In this case, I'll go ahead and put it at the bottom so we can see it a bit better. And we do get an empty array, which makes me think that we didn't successfully fetch the data. And there's also a syntax error talking about an unexpected token right here. So maybe the response that we got from here wasn't good. So let's point it to HTTP :// localhost 3000, and then API v1 cars. If you do that, you'll notice that they're operating on different ports. Our frontend is on port 5173, but the backend is on port 3000. And even though both use localhost, the browser will treat each combination of protocol, domain, and port as different origins. So because of this, when you make this GET request, the browser blocks it unless the backend explicitly allows this origin. This browser-enforced rule is called CORS, Cross-Origin Resource Sharing. And CORS exists for security reasons. It prevents websites from making unauthorized requests to the other sites. If the backend does not send headers, such as access control allow origin, then the browser will stop the request with a CORS error. So to fix this issue, Vite lets us create a proxy so that API requests appear to come from the same origin. You can head over into your Vite config right here, and then right below the plugins, you can say server, define the proxy, then say /API is actually going to come from the target localhost 3000, and change origin will be set to true. If you now go back and remove this part that we prepended to the URL, so now it's just API v1 cars. If you go back and reload, you'll see that no longer will have that cross error, but you'll also see that we have an empty array. That's because useEffect by default is not asynchronous, and this fetch request is. So this console log will not wait for the fetch to finish. So to be able to see the cars, we have to put it outside where we actually want to use them. Go ahead and save it, and you'll see 2 cars that are coming from our database. Right here on the front-end side. Just how exciting is that? But it's going to be even more exciting when we can actually display that data on the front end. So what we have to do is pass the data to our component. So we can first map over the cars by saying cars.map, where you get the data about each car. And then you'll create a new car component for each one of these with a key equal to car.id. You have to give a key since we're mapping over it. And then we'll provide the full car data. You can either do it like this, or you can just spread all the car properties to be able to immediately receive them over in the car component. So now, to be able to see the data, hop into the car component and let's display it. We can display it in a very simple way by making each one of these cars a list item. And within it, we can start displaying different tags, such as the make, like this. And the question is, how do we get the make out of this component that we're passing? That's happening through props. You simply have to destructure them at the top because we're passing them into the component while we're mapping over it. So simply destructure the make, the model, year, and the price. Duplicate this 4 times. And for the second one, simply say model. Then for the third one, it's going to be the year. And for the fourth one, we want to display the data about the price. So simply display it right here and save it. And just like that, you'll be able to see that 2 new car components have appeared on the front end. We have the one with the make of Tesla, Model 3, year 2023, and so on, and then the other one with a BMW 4 Series. Now, if you head over to our HTTP, because that's the only way in which we can add new cars at the moment, head over to the post request and create a new post, such as, we can copy this part right here and duplicate it, but this time we will change the actual variables. Well, let's do something like a Ford. We can do F-150, which is going to be 2025, and the price will be a bit more expensive. Now, if you go ahead and click send, as soon as you reload, you'll be able to see that a new car got added into the database. Then the front end made a request to our backend, which spoke to the database and retrieved that car for us and showed it to the user. You can see that the styling right here isn't the best. You can check out the Tailwind crash course to get better styling skills. But yeah, this is it. The next step of this would, of course, be to implement a form on the front end that would not only make a GET request, but rather a POST request, so that through this front-end application, you can retrieve the cars, but also create them. So if you want to take a stab at it, go ahead and do it for practice. After the crash course, together we'll develop a huge full-stack application, which is going to make this one seem like a literal toy. So stay with me, and let's continue learning the PERN stack. At this point, you officially connected Node, Express, and Postgres into a working backend, and then connected that backend to a React application and successfully displayed the real data in the browser. This is exactly how full-stack applications work. Frontend, React, sends a request. Backend, in this case Express, processes it. Then the database, Postgres, stores and retrieves the data. Backend talks to the frontend and returns the updated result. And then the UI updates, instantly showing the changes. So technically, you've just built the full PERN communication loop. But, and this is important, what you've done so far is the foundational version. The beginner-friendly, stripped-down version designed to help you understand the big picture without getting overwhelmed. You've been stacking building blocks like raw SQL, to Drizzle, to express routes, API communication, React fetching data, proxying through Vite, and rendering dynamic UI. This gives you everything you need to understand how a PERN app works from end to end. But this is just the beginning. What comes next is where your real growth begins. You finally reached the end of the crash course, and you should genuinely feel proud of what you've built, understood, and experimented with. Over the last hour, you've stepped through the entire modern web development stack: Postgres, Express, React, and Node. You now understand how these pieces talk to one another. Now comes the build and deploy part of the course, where you'll take everything you learned and actually build a complete, polished, professional PERN application from zero to production. Let's dive right into the code. If you're watching this, it means you have successfully completed the crash course. You now understand the essential concepts, the syntax, and the logic. Huge thing. But theory alone doesn't build careers. Practicality does. So now we shift gears. We're moving from learning the concepts to engineering the solution. You're about to build a production-grade classroom management application with a bit of help of AI in between, and then redoing the whole application with AI again once you know how to build it from scratch in the first place. So let me show you exactly what you're building. You'll start with the auth pages, where you can select your role, either a student or a teacher, add a profile photo, a full name, email, and a password. Because without a successful sign-up, you won't be able to see the dashboard. So once you actually sign up, you can sign in. The system will automatically recognize which role you are, and it'll show the appropriate dashboard. That's the first page that you'll see after the successful authentication. The dashboard will give you a complete real-time overview. You can see the total number of students, teachers, active classes, subjects, and anything else that might be relevant. There's a ton of data, and you can add even more if you want to. And these are not just static numbers. This is live data being pulled with Drizzle ORM. We're going to first write raw SQL queries manually so you understand how it works. And then if you want to get some more data, you can easily use AI and tell it what you want to be done. Then we have departments and subjects. A university is a complex web of connections. Departments manage subjects, and then subjects also have teachers. You can drill all the way down from a specific department that has its own department details page that looks like this, and then head over to the classes within a department, as well as teachers that teach within that department. Within the departments list, you can also quickly create a new department if you are a teacher. And the same process goes for subjects. You can quickly create new subjects too. Then you've got the faculty directory. It features pagination, instant search, so you can see some of the teachers and take a look at the detailed profile views. And now we go to the heart of the application, class management. Here you'll see a complete list of classes to enroll, and you can also search classes by name. For example, we can go to a web development bootcamp. We can find it very quickly. You can also filter them by subjects. For example, if you want to take a look at some software engineering classes, you can find them here, and you can also filter them by teachers. So this works too. You can then also create a class, but this also comes with strict validation, where you can't assign two teachers to the same class. Here, we're also introducing Cloudinary for image upload. You can upload images from your local file system, or you can also just find images online. Cloudinary then has additional AI-powered features and optimizes your images instantly. After you create a class, you'll be able to see its banner image hosted by Cloudinary, as well as the list of additional details from that class, which instructor is holding it, the department it's in, and information to join the class. And finally, we can talk about enrollments. The only thing you have to do is select which class you want to enroll, and you're done. You can just do it instantly. Think of the system as your foundation. From here on, you can easily extend it to include features like classroom announcements, file sharing, assignment submissions, and anything else you can think of. But if you think about it, you can also completely modify the theme of this dashboard. It doesn't have to be related to universities, subjects, departments. It can be anything you can imagine, because every single application out there is a full stack application with different CRUD operations. You're creating, reading, updating, and deleting some kind of documents and rows from tables. Once you master the core architecture of what you're building today, you'll realize that adding those extra features is actually the easy part. It's just repetition. Oh, and I completely forgot. You can change the theme of this application instantly from light to dark mode, but also modifying the complete theme of the application. Yep, I really do mean the complete theme, because I'll show you how to add Tweak CN that allows you to choose between many different themes, and within literally half a minute, you can completely change the look and feel of your dashboard by simply taking the code and adding it within your application. With that in mind, I hope you're pumped. Let's dive right in. Before we dive right into building this application, let me tell you that the PERN stack is an absolutely amazing foundation that allows you to build pretty much anything you can imagine. Most modern apps are full stack apps by nature, from social media platforms to marketplaces to AI SaaS products. And PERN gives you everything you need to build them efficiently and confidently. But building an app that works is only the starting point. That's why, along with PERN, I'll also teach you how to use a few tools that professional developers use in real production apps. These tools will help you build faster, handle images and files properly, keep your app secure, monitor how everything runs, and write clean, high-quality code. This way, you're not just learning how to build an app, but how apps are actually built in the real world. And let's start off with Refine Core. It's an open source alternative to Retool, specifically built for creating internal tools, admin panels, dashboards, and B2B applications with a lot of flexibility. It's 100% pure React with your stack, your code, and no lock-ins. Refine Core will take care of repetitive tasks like CRUD operations, authentication, access control, and state management, while remaining fully extensible and scalable. You basically get the speed of low code on day one with the freedom and control of full code forever. They've also recently introduced Refine, which significantly boosts productivity when building admin panels and dashboards with the help of AI. So in this course, I'll first teach you how to build everything from scratch, and then how to use AI to accelerate your workflow using that knowledge. This tool will be extremely useful throughout the course. I'll go ahead and leave a special link down in the description that the Refine team prepared for me to give to you so you can follow along and see exactly what I'm seeing throughout this course. Next, we'll be using Cloudinary, my go-to solution for all asset management, from profile images and class content to any kind of media assets. But it goes far beyond simple storage. They offer features like image optimization, automatic formatting, widgets, AI-powered cropping, background removal, recoloring, shadows, CDN delivery, and so much more. And that's the reason why major brands like Puma and Adidas rely on it. So go ahead and create your Cloudinary account as well. Thankfully, the Cloudinary team also provided me with a special link through which you'll get extra credits. So open it up and get started. Now, I don't think I need to say much about Arcjet, as you might have seen me use it in so many videos already. It's an absolute must-have for modern application security. Arcjet will provide us with bot detection, RAID limiting, attack protection, data reduction, and more. It's that SDK that offers us a developer-first approach to security, allowing you to ship secure applications faster and with confidence. And since we're building a real dashboard application, security isn't optional. You'll be building this application with security in mind from day one. So don't think twice. The special link is down in the description so we can create an account right away, and then we can later on add it within our application. And while security is a must, there's also one thing that you need to learn: monitoring. And for that, we'll use Site 24/7. It's an AI-powered observability platform that lets you monitor your apps, but also servers, which will come in super handy since we're building a full stack PERN application, which of course has its own backend. You can also keep track of the cloud infrastructure, logs, and user experience, all from a single platform. It'll provide deep visibility, faster root cause analysis, and automated anomaly detection, helping you spend less time firefighting and more time shipping reliable software. Once again, the link is in the description. You can click it and create our account right now so we can easily use it later on. And of course, the code that we write needs to be of good quality. So I'll teach you how to use CodeRabbit that'll help us write clean and scalable code from day one while getting familiar with the real-world industry workflows. Pull requests, Git management, and collaborative code reviews. We're going to do all of that throughout this course. I'll also give you a special link down in the description so you can open it up and set up your account so that once you're done with that, we can actually dive in and get our hands dirty. To start creating our application, head over to Refine Core and let's head over to the docs. Here, you'll see a bit more information about what exactly is Refine, but don't worry, we'll go through that in detail throughout the rest of this course. So let's immediately head over to the quick start guide. You'll be able to see that Refine works on any environment that can run React. So it can be Vite, Next.js, Remix, and so on. But in this case, we'll use their CLI to quickly bootstrap a new Refine project. So go ahead and copy the installation command, and then you'll have to open up your IDE. Throughout this course, you'll see me use WebStorm. It's a super powerful production-ready IDE that as of recently became free for non-commercial use, which means that you get all the powers of a real IDE. And trust me, there is a difference between an IDE and a text editor, completely for free until you start developing commercial projects. I'll leave the link down in the description so you can download it and set it up. And another part that makes WebStorm great is the inclusion of Journey. Journey is JetBrains' coding agent. You'll also see me use it throughout the course, and it'll help us in many different ways, from general productivity to code some parts of the app faster, but also by discovering some alternative solutions, proposing a full execution plan, adjusting to the tasks that we're working on, and so much more. So before we get started, go ahead and install Journey. Once that is done, go ahead and open it up and create a new project. We can create a new empty project, which I'll call Classroom. And click Create, expand it, and then you can open up the integrated terminal. Within it, you can paste the command from Refine that we just copied, npm create refine app add latest, and press enter. You might need to install the installer, and you can choose a project template. In this case, we'll proceed with Vite. You can then select your project name. In this case, I'll go with Classroom-Frontend. Keep in mind that we'll have two separate applications and two separate repositories for this full stack application. Specifically with Refine, we're developing the front-end part of the app. And then you can select the backend service you want to connect to. In this case, we're going to go with the REST API option because we want to develop our own full stack PERN application. And then you can even choose the UI framework of your choice. And here we'll go with ShadCN UI. So press enter. We don't need any example pages or authentication logic to be provided by default, although that is an option. And that's because I'll teach you how to do everything from scratch. And with that in mind, the installation process will start. So pause this video for about a minute and I'll be right back. Once it's installed, you'll be able to see that within the Classroom folder, we now also have a Classroom frontend folder within which we'll naturally develop the frontend of our application. So what we can do is cd into this Classroom frontend and then run npm run dev to spin it up on localhost 5173. You can then go ahead and open it. I'll put my browser side by side by my editor so that we can see the changes that we're making live. And let me first walk you through the files and folders, starting with the public folder, which will store all of our assets. Then within source, components, Refine UI, you'll be able to see all the different components created by Refine, such as buttons, data tables, forms, layouts, and more. We'll use them soon. Below that, we also have Components UI, which is going to contain default ShadCN components. After that, we have the hooks folder, which contains the use mobile hook. This is a hook used to make sites responsive for mobile sizes. Some of the components use it to immediately provide mobile responsiveness. Then, below it, we have libutils, which for now contains just generated ShadCN utilities that allows us to render strings conditionally. Then, below it, there's the app.css, which contains the generated theme by ShadCN components. Here, you can later on create some custom Tailwind CSS components. Then there's the app.tsx, which acts as the starting point of our application. It contains all the route definitions and refined settings for the data provider and more. I'll teach you everything you need to know about these as we continue developing our application. There is also a Docker file, which you can use to run your application in a Docker container. And then there are other usual files like ESLint configuration, packages where your scripts and dependencies are, vite-config, and some TypeScript-specific stuff. Now, keep in mind that there's a complete sample design that I'll share with you completely for free in the video kit link down in the description. But here's the key part. Our final application won't look like this. It'll look completely different. And your final design might look different from mine. As a matter of fact, there can be hundreds of us developing this application, and every single person watching can have a different design. Let me explain what I mean. The dashboard that we'll build today will be fully compatible with the tool called TweakCN that allows you to design your perfect ShadCN theme. So head over to tweakcn.com and click Start Customizing. Here, you can see an example dashboard that we'll have within our application, and then you can either manually change all of the primary, secondary colors and more, just like this. Or what you can do is choose one out of 43 themes that we have, and that will immediately and completely modify the design of your application. You can go with some crazy retro designs all the way to really modern feeling like this one right here. Pretty cool, right? And I don't want to impose my opinions for you. Simply go ahead and choose the one that you love the most. In this case, I think I'll go with Claude. Looks pretty good on dark mode too. So what you need to do next is head over to code, and then you can copy this index.css. Then head over within your application, specifically within the app.css, and you'll want to collapse everything so we can see it better. There's some layer, base, and so on. But you'll want to replace the theme inline, the root, and the dark. So these three things you want to delete. And then all the changes in the theme are coming right after these two layer bases. So this we want to keep, and then you want to paste what you copied right after. This is going to include, let's collapse it and see, the new root, dark, and theme, which is going to immediately impact the way your application looks and feels. Right now, we have this boilerplate created by Refine, which has this background image, so not a lot has changed, besides maybe the font. But trust me, very soon, you'll be able to see your app taking shape into the design that you chose. And the best part is, if you get tired of that design, you can always head back right here, choose a different theme, and just copy and paste new styles and immediately change the look and feel of your entire application. So now that you understand the theming of our application and that we're done with the setup and you understand the file and folder structure, in the next lesson, we can get started setting up the initial front-end routes. Let's dive right into the routing of our application. We'll have many pages, so we need to be able to, route to them. Thankfully, it's one of the fundamental guides and concepts on Refine core documentation. So let's give it a read. Routing is essential for any CRUD application. Refine's headless architecture allows you to use any router solution without being locked into a specific router or framework, which is great. Refine also offers built-in router integration for the most popular frameworks such as React Router, Next.js, and Remix. These integrations make it easier to use Refine with these frameworks and offer some built-in benefits. Since Refine is router agnostic, As you'll notice, it's agnostic to many other choices that you make while developing this application, which is exactly why many developers love it. You are responsible for creating your own routes. So if you continue reading through it, you'll be able to see different integrations and then relationships within resources and routes. More on that later. This is going to be super useful once we start defining our database, schemas, and more. But for now, let's create some routes. So first things first, you can head over into the source and create another folder right within it, which you can call pages. Within pages, create our first page, which is going to be called dashboard.tsx. You can see WebStorm is asking me if we want to add it to Git immediately. In this case, we can say, sure, go ahead. And within it, you can simply run RAFCE. This stands for React Arrow Function Export Component, and it's a simple shortcut that I often like to use. If this didn't work for you, you might need to set up the plugin or an extension called Modern React Snippets, and then install it. You might need to reload your IDE or editor, and then it should work. This creates an empty page. Now, to be able to see it, we need to head back over to our home page, which is the app.tsx, and then we need to remove the previous welcome page routes and define the new route. So we can do that right here, where we have the routes. We have a single route right here, and instead of rendering the welcome page, we'll do something different. Let me show you. We'll say route, and we'll give it a path set to just / with an element set to dashboard. So this is the component that we want to render. It's a self-closing component. And if you save it, immediately you'll be able to see an empty piece of text that says dashboard. Now, alongside just setting up the route, I also want to quickly dive into the concept of the resources. In Refine, a resource is a central concept representing an entity, which ties together different aspects of your application. It typically refers to a data entity like products, blog posts, or orders. In our case, it's going to refer to different classes, subjects, students, and so on. Resource definitions allow you to manage your application in a structured way, abstracting complex operations into simpler actions through different providers and UI integrations. You simply need to define them here. And I think this little code example gives you a pretty good idea of what the resources do. In this case, the resource is product. And then you can list all the products. So this would be like a get all route. You can then show a specific product. This would be like get details. You can edit a product or you can create a product. It basically is an easier way to managing your application routes and tying those routes directly to resources within your database. So let's head back. And right here at the end of the refine component, we can also define the resources. I think if you hover over it, you should be able to see some information about it. And we'll define it as an array where the first resource will have a name of dashboard. It'll have a list of /, and then it'll have a meta where we can define a label set to home, as well as an icon set to, it's going to be a home icon, which you need to import over from Lucid icons. Let's make sure that it's coming from there. Right here, Lucid React, we have the home icon. And we can also put this into multiple lines, so it's a bit easier to see. And another route that we want to add right here is going to be a route that'll have an element equal to a layout. So we want to render some kind of a layout right here, coming from components, refine UI layout. And then within it, we want to close it and render something known as an outlet. This outlet is going to come from React Router, and it's a self-closing component. An outlet renders a matching child route of a parent route, or nothing if no child route matches. Basically, it's a special component used to render child routes inside a parent route. You can see some more information in the React Router API reference. But in this case, it will simply render the sidebar, which Refine will pass as child automatically for us within other pages. And we will then pass this route that we created, the home route, within this route containing the outlet. And you can immediately see what happens. We get a sidebar where we can display other pages, we can change the theme, and we can mention the name or the icon of our project. Oh, and take a look at that. After changing the mode, you can more clearly see the theme that I chose with the following primary color. For you, this might look completely different. Now in this app, we can also remove this GitHub banner at the top because we don't need it. And we can similarly create routes for our subjects. That's going to be the first resource of our application. That'll look something like this. Like we'll have a table of different subjects and departments, descriptions, whether we have attended them or not. And that's what we want to display right there. So right here within our pages, create another folder called subjects. And within it, create a new file called list.tsx. So specifically within this one, we want to list all the subjects. So I'll simply run rafce, and then we'll import it right within our app.tsx as a new route that we want to add. So right here under resources, I'll add a new resource with a name of subjects, a list route pointing to /subjects. Then we'll have a create route pointing to /subjects, /create. And then we can also add some meta information, such as a label of subjects and an icon of something like maybe a book open icon coming from Lucid React, because we're talking about the subjects. Perfect. And now we can scroll down to the routes, and we can also add a new route group right below the current route. So it'll be a route that'll have a path of subjects. And within it, we can create a new route, which is going to be the index route of that route group. And it'll render the subjects list component. Of course, we have to properly create this within the subjects list page. So let's do that. I will rename this list to subjects list. And I will also create another page right here called create.tsx, within which I'll run rafce, and I will rename it over to subjects create, just to be consistent. Then if I get back to our app.tsx, we can now easily import the subjects list. There we go. And below it, I'll create another route. Let's just close this one properly first. This one won't be an index route. Rather, it'll be under the path of create, and it'll render the subjects, not list, but this time create. So now if you save it, believe it or not, immediately right here on the sidebar, you'll be able to see a subjects link, which is gonna navigate you over to the page where we can list all the subjects. It's pretty cool how Refine just makes all of this work immediately. It's fully mobile responsive by default with different theming options. But again, the fun starts when we actually set up something known as a data provider, because then we can combine our routes with the resources that I briefly touched on a bit before. So at this point, even though we're just starting, you should already have a pretty good idea of how we'll define the resources and the routes throughout the rest of this application. But don't worry, we'll do it many more times in the future. For now, since we have a nice starting point of our application, since we want to stick with proper programming habits, I want to teach you how to immediately initialize this repo with Git. So simply open up your terminal. I will call this one Frontend, and then I will open up a new terminal, which can be called just terminal. And within it, you can again cd into classroom frontend. Don't forget to do that. And run git init, git add dot, git commit -m, initial commit. Then head over to github.com/new, choose yourself as the owner, and enter the repository name, such as classroom frontend, and go ahead and simply create a new repo. Once you do that, we'll have a couple more commands we can follow, such as you can modify the branch to switch over to the main branch, then connect your local repo with the remote one over on GitHub, and then finally push the code over to that remote repo. Once you do that and reload, you'll be able to see the new code that we just created. Now that our code is on GitHub, later on, once we start implementing more intricate functionalities and code that's not just UI and can potentially break, it'll be much easier to just open up a PR and let CodeRabbit review that code for us, which we can then make a part of our natural workflow of continuing to develop the application in the future. That way, our code remains clean from one feature to another. With that in mind, let's move over to one of the main parts of our application, and that is dealing with data. Now comes the most interesting part of the build. We'll dive straight into managing the data of our application. I'm talking classes, subjects, students, and more. Data makes the application. So instead of going the traditional application route where we implement the authentication first, this time I'll teach you in a different way where we build foundations, more core features, implement seeders, and then connect it all with authentication at the end. It'll be a raw developer way of developing things where you try to get the MVP done as soon as possible and then keep polishing it alongside implementing more features. And to do that, we need data. So we'll touch on maybe the most important concept of Refine Core, which is the concept of a data provider. A data provider is where you define how your API, or any data source for that matter, works. So Refine knows where and how to fetch the data. Once it's set up, Refine Core will automatically call the right API for each page and give you the data. So you don't have to manually write fetch or Axios calls anymore, or set up TanStack query for automatic hashing, refetching, and so on. Refine Data Provider will handle all of that for you so that you can focus on the business logic of the application you're developing. So let's implement a simple page and see how the data provider works in action to better understand and use it. Let's go over to our pages, subjects, list. This is going to be the first data point that we're going to work with. So we can also navigate within that page on our application. And let's wrap everything within Refine's list view. At the top of this list view, we'll render a self-closing breadcrumb component coming from Refine UI breadcrumb. And that's simply going to tell us where on the dashboard we're on. Right now, we're just on the home and subjects page. Then right below it, we can render an H1 that'll have a class name set to page-title. And it'll simply render the text of subjects. Now, you can see that I added this class name of page title, but that's not doing anything right now. And if you search for it, you won't be able to find any declaration on the rest of the code base. So this will be a custom class that we're going to define within our app.css. So if you head over to our app.css, below everything that we have defined right here, there we'll also want to add some additional class names, such as the .page-title class name, where we can define different font size or something else. Since this is not a Tailwind crash course, and since these are just some utility classes, I'll provide them all for you within the video kit link down in the description. Simply find the codebase for app.css and copy everything besides the root, the dark, and the theme inline. These keep track of our theme, so don't override it. And I just noticed that I have the double layer base, so I'll just keep one and then paste everything from the app.css within the video kit link. There's not a lot of class names. You'll see that one of them is page title, which simply applies a font bold and a larger font size. Perfect. So now if we head back to the list, we can continue developing it. After the H1, I'll render a div, and that div will have a class name set to intro-row. And right here, I'll render another p tag that'll say quick access to essential metrics and management tools. So we can have it all in one place. Then below it, I'll render another div with a class name set to actions-row, and within it another div that'll have a class name of search-field, within which we can render a search icon coming from Lucid React with a class name set to search icon, and an input component coming from components UI input that'll have a type set to text, a placeholder set to search by name, a class name set to padding left of 10 to divide it a bit from the icon on the left, and a W full, so it takes the full width of the container. And it has to have a value. The value will be a state that we'll create within this page. So I'll create a new use state snippet. It'll be called search query and set search query at the start equal to an empty string. And don't forget to import use state from React. Once you do that, we can simply say the value is set to the search query. Of course, we naturally need an onChange as well, which is going to get the key press event and set the search query to be equal to the value of that key press. And just like that, you have a nice themed input. Now, right below the input and the div wrapping it, we can create another div that'll have a class name set to flex, a gap of 2, again, a W of full for the full width, and in small devices, W of auto. Within it, we can add a select element coming from components UI select, which is ShatCN. And here we'll be able to select the department that we want to get the subjects for. So that's going to be the purpose of this select element. So let's go ahead and create a new use state field that's going to be called selected department. And at the start, it'll be equal to all departments. Then we can head to this select and give it a value, same as we gave it to the input, set to the selected department, as well as the onValueChange, which can be set to set selected department. Perfect. Now within this select, we can render a select trigger component, also coming from components UI select, and within it, we can present a select value. Not coming from Radix, but make sure to import it properly from components. And it'll be a self-closing component with a placeholder set to filter by department. There we go. So now we have this little select that soon enough we'll be able to click on. Now below the select trigger, we can also render a select content. That select content will render a select item. Again, make sure that item is coming from components. It needs to be coming from here. And we'll give that item a value of all departments. So we can make it say that, all departments. And again, make sure to import it properly from components. There we go. So now it says all departments. Now, alongside all departments, we also want to render a list of the actual departments that we want to display. So let's create a list right here. It's going to be something like an array of computer science. Maybe we can do math, and maybe we can do English as well. But we don't want to map over these here. This is what I would consider data, not presentation, not JSX. So what I would much rather do is take this out and move it into the constants folder. So right within the source, create a new folder called constants. And within constants, create a new file called index.ts. Within it, we can create that array and export it. So export const array, where we define a couple of different departments. So let's call it departments. And typically when something is a constant, when it doesn't change, we can call it with all uppercase letters. And it's going to look like this. So we do CS, math, English. If you want, you can add more departments within this university. Now, we'll also have to map over these to present it in the right format to be displayed as a list. So I'll export const another variable called department options, which is going to be equal to departments.map, where for each department, we can automatically return a new object. So when I say automatic return, you have to have an object, but you first have to wrap it in parentheses for it to act as an immediate return. And then here you can define the value, set department, as well as the label set to the department as well. Now, back within these departments, we can just say department options, which you can import from the file we just exported it at, .map, where we get each individual department. And for each one, we can automatically render a select item with a value of department dot value, and we can also give it a key since we're mapping over it, set to department dot value. And in the same way, we can render within it the label by saying department dot label. So now you'll be able to see all departments, CS, math, and English, and we'll use this later on to filter the list of our subjects. Finally, let me show you one very cool thing. If you head below the select, here you can render one special button called a create button. Typically, there's not such a thing as a create button, but this one is provided to us by Refine. And if you render it, you'll immediately notice a nicely structured button that says create. And believe it or not, by default, it automatically redirects you to the create subject page. So this is what I meant when I said that Refine really makes the routing and the data portion of your application seamless so that you can focus strictly on the business logic. And now, most importantly, the goal of this page is to be able to display or list some data because we're in the list page of the subjects. So head below the create button and below all these three divs and render a data table. That'll render a table called subject table. And of course, this is something that we have to define above because it's going to break the application right now. So let's define that subject table right here. Const subject table is equal to use table hook coming from Refine dev React table. This is a hook provided by Refine on top of React table, which allows us to fetch data according to sorts, filters, and pagination states, and then display that data accordingly inside of the table. And yeah, this is built on top of the React table package, which is now called TanStack table. To this use table, we can provide a type and say that the type of the table is going to include the subjects. And this is a type that we are yet to define. The best place to define those types is within its own types file. So right here within the source folder, create a new folder and call it types. Within types, create a new file and call it index.ts. Here we can export and create our first type called subject. It'll have an ID of a number. It'll have a name of a type string. It'll have a code of a type string as well, a description of a type string, as well as a department that it belongs to of a type string, and a created@ field of a type string as well. And now we can very easily import this type right here by specifying subject type coming from types. And now we know exactly of which type will this table be. And now we can start defining the options of this use table hook. The first one is the resource. So which specific resource is this table showing the data for? In this case, it'll show the data for the subjects. And we'll nest this resource option within Refine core props object, so we can put it right here. So that way, if you need some more information about a specific thing, you can hover over it and get more information about it. So alongside subjects, we'll also have the pagination, so how we want to paginate over those resources. We can set that to be a page size of 10 by default, as well as a mode, which is going to be set to server, which means that we want to paginate it on the server side. Then, if needed, still within the Refine core props, we can define the filters, which for now I will leave empty. We can also define the sorters, which for now I'll also leave as an empty object. And finally, and most importantly, we need to provide something known as columns, which I'll add at the top. So these are the columns of the table that we are working on. You can see that the whole red squiggly line went away as soon as I added the columns part. Columns is simply an array that we are going to create. So let's start crafting them together. I'll first wrap it in a use memo hook coming from React. Now, why are we memoizing the columns? We're doing that to avoid recreating each column on every render. Then we can define the type of the data within that use memo, which is going to be a column def, as in column definition, specifically of a type subject, and it'll be an array of subjects. And then we can start defining a callback function of that memo, which will simply resolve in an array like this. And now within that array, we'll have different columns. Each column will have an ID. The first one will be the code of the subject. So we can say code. Then we'll have the accessor key, which is going to be the field name from subject data. And that I'll also call code. Then the size of the column, which I'll set to a width of 100. And actually, let's put each one of these into its own line, so it's a bit easier to see what's happening. And then we'll display the header. We can make that a p tag with a class name set to column-title and a margin left of 2, and it'll simply say code. So we're talking about the code for this specific subject. And finally, below the header, we need the actual cell data in the table. What will it show? Here, we can have a callback function where we can destructure the getValue property that's going to give us the value of the actual cell. And then we can automatically return a badge in this case, which is going to be a component coming from UI badge. Within it, we'll display a getValue, and this will return the value of this specific cell. Since we don't know the type of the value, here we can say that the type will be of a type string. You can see that the use memo is complaining a bit, and I think that's because we forgot to provide the dependency array right here to the end of the use memo, which is going to be simply set to an empty array so that the columns never change. Also, we have a little note on the header that it's not expecting an element, rather a callback function that returns an element, so we have to define it like this. And now we have a single column within our table that'll soon enough display the data. You can see it right here, and the rest of the data is loading. So it's pretty cool that we immediately got this nicely structured container, which is fully mobile responsive, that soon enough will display the actual data with loadings, lines, hovers, and all the columns and everything else without ever defining anything in JSX. We just said data table, and that's it. The way that works is thanks to the data table component. When you're building admin dashboards, you so often need to display lists of data, whether it's posts, users, products, you name it. The data table component handles all the common table functionality you need, such as sorting, filtering, pagination, and action buttons. It's built on 10-stack table, as we discussed, which integrates directly with Refine's data fetching hooks, so you get features like server-side sorting and filtering without extra configuration. Thankfully, I already showed you how to set it up. You basically have to define the different columns right now, which we'll do right away. So let's continue with the other columns that we have. I'll collapse this one. The next column will have an ID of name. It'll have an accessor key of also name, a size of 200, a header, which is going to return the name, and it'll just be a column title. And then we'll render a cell, which will get access to the value of this specific cell. And this time, it won't be a badge, but rather it'll be a span element with a class name of text-foreground. And we will extract the value by saying getValue, and it'll be a value of a type string. So similar to what we have done before. Of course, we don't yet have the data to show, but trust me, we'll have it soon. For now, we're just forming the structure or the skeleton of the table so we can display the data once we do have it. Specifically for the name, we want to allow filtering by name. And this is not easy to do in practice. I mean, it's not hard, but it requires a lot of manual work to enable filtering or sorting or searching. Here, it's super simple. The only thing you have to do is apply something known as a filter function. So right after the cell, I'll say filter fn and set it to includes string. This will enable text-based filtering on this specific column. Now, let's also add two more columns. One will be about the departments. So let's add a new object with an ID of department that'll have an accessor key of department, a size of about 150, a header set to the column title that's going to say department like this, and it'll have a cell where we can get access to the value, And this time for the department, we'll also display a badge. So I'll render a badge displaying the value with a variant this time of secondary. So this is just going to change the color of the badge. And finally, let's do the same thing for the last column in the table. And this one is going to have an ID of description about this specific subject with an accessor key of description, a size of 300 because it's going to contain more text, a header set to the description, as well as a cell of get value, and this time we'll return a span element. By the way, did you notice that I was just pressing tab the entire time? That's because as we're continuing to develop this, WebStorm is learning about the project and suggesting which code comes next. So here, we're basically rendering the description. We'll truncate it if it's too long, and apply a line clamp to so it cannot exceed 2 lines. Perfect. So you can see now that we can also horizontally scroll across the table. Can't wait to actually fill it in with data. And now we'll just have to apply some filters to this table. Let me show you how we can apply the filters. We want to do it based on the departments and also based on the search. So I will collapse this columns part, and we want to deal with the filters and sorts. So to enable filters, we want to enable something known as permanent filtering. So I'll say permanent, and within it, we can define an array of different filters. We want to be able to filter by department as well as by search. So let's actually define these filters above, as it's going to be easier to then use them within the filters part right here. I'll say const department filters is equal to, we'll check if a selected department is currently set to all. In that case, it's going to be easy. We won't apply any filters. It'll be empty. But if a selected department is not all, then we want to have an array where the field that we're filtering for, specifically set to the department, we're looking for the operator of EQ, as in equality. So we're looking for a specific match as const, and we want to match it the following value of the value selected department that is currently stored within the state. So now we have these department filters that we can simply spread right here. So hopefully this makes sense. If the selected value is all, it'll return an empty array with no filter params. But if any other value is selected, it'll return the params with which the field will be filtered against. Then these will be passed to the data provider by Refine, which will then call our backend API with those parameter values and return the data that we need. Now let's also do the search filters, which is going to be equal to, we're going to check whether a search query exists. And if it does, it's going to be an array where we're going to have a field that we're searching for, and that's going to be a field of name. Then it's going to be an operator set to contains as const. And finally, the value, which is going to be the search query. Perfect. So now we have the search filters as well. And right outside of this array, we also got to say, if there is no search query, then don't apply any filters. Perfect. So now we can also spread those filters right here in the filters array. And just like that, we have enabled the functionality for filtering, but now we can also do the same thing for sorting. For sorting, it's going to be even simpler. We simply want to say initial sort, right? It's going to be set to the field of ID and in the order of descending, which means that the newly created IDs will appear on top of the table. Perfect. And that's it. You simply define the filters, you define the use table, and this will handle all the logic of fetching all the necessary data and then displaying it within this nicely rendered table, which is fully mobile responsive. But of course, now if it tries to fetch the data, it'll try, but then at the end of the day, it'll say 404, I wasn't able to fetch it, and it'll fail. And you can see just how well this looks like on the full screen. I mean, we should be looking at this dashboard more or less on the full screen because that's how dashboards are typically used. Not on small phones, even though it's good to know that it is fully mobile responsive by default. The reason why we get no data to display right now is because currently the data provider is pointed to a fake REST API. How do I know that? Well, if you check right here in our source app.tsx, where we have the general refined settings, you'll notice the data provider options pointing to a fake REST API, which of course doesn't consist of any subjects within it. So for this subjects path, Refine is trying to make a call to this API, and then you can see that it actually works. It has a lot of useful data, users, posts, and so on. But what Refine is trying to do is making a call to this. And then, since we're on the subjects list, by default, it applies the /subjects part, which of course doesn't contain any data. Let's fix this by creating a mock data provider and connect it to the Refine UI. Right here within the source of the application, I'll create another folder, which we'll call providers. Within the providers, I'll render a new file called data.ts. And here we want to export and create a new data provider of a type data provider coming from Refine Dev Core to an object where in the parameters we get the get list functionality. And what this get list does is it fetches all the records used by useTable, useList, and so on, so that every time you'll implement a list resource page, Refine will make a call to get list to get the data and pass it to the useTable or useList behind the scenes. So this is going to be an asynchronous function. Specifically, it'll return the data of tData, which extends the base record. Basically, this is a type that is not yet defined. Rather, we'll specify what it is later on, so base record. And then we open up a function block that'll accept that resource and return of a type getListParams coming from Refine Dev Core. And then all of that will return a promise that will get resolved in getListResponse coming from Refine Dev Core. Specifically, that'll resolve in tData. So whatever we pass into it, that's how we'll resolve it as well. And then we open up a new function block where we can start defining this. This was a lot of TypeScript, I know, but we want to make sure that we're heavily typed at the start so that everything works as it should. And this base record, also we need to import from Refine Core. Perfect. Now, within this function block, we want to check if resource is not equal to subjects. Maybe it's another list resource, say classes. We have to handle this because every single call to this data provider will go into the get list, whether we're calling classes or something else. So if it's not subjects, in this case, we can return data, which is going to be set to an empty array as tData array, and the total, which is going to be 0 in this case, because there's no subjects that match it. But if it's good, we can return some kind of an object containing the data, which for now I'll set to an empty array, and the total, which I'll set to maybe like 0 for now. We have to fill this in with real or dummy data very soon. This data provider will also need other parts alongside the get list. It'll need a function called get1. And this one fetches a single record by ID. So let's simply mock it by creating an asynchronous function, which simply returns and throws a new error saying something like, this function is not present in mock data provider, right? We need to add this so that the refined data provider does not complain about throwing a JavaScript type issue. So we're simply throwing it ourselves, throw new error, and this has to be within a function block like this. And now I will duplicate this 3 more times, get one, then we'll have create for creating a resource, then update, and finally delete one. We'll implement all of these soon. Finally, there's a function called getAPIURL that allows us to get the URL of our API as the name says. And now we need to generate some kind of mock subjects data that we can display within our table. So we could write it by hand, saying something like mock subject and write it one by one. But I think these types of boring situations are perfect for AI to help us with them because it can very easily and quickly create a lot of these mock data points. So I'll press Command-Shift-P and type in Junie to open it up within my WebStorm. We can allow semantic indexing, and I will give it some more space. Let's write a prompt together that'll generate this code. So I'll say create mock subject data in TypeScript for 3 university courses. Each subject should include an ID, course code, name, department, and a brief description. Okay, I think this should be good, and it should figure out where we want to include it. So you can see that now it's going to get the structure of our files. It's going to read through our code base and update the task. So the subject type and department constants are already defined. I will now create mock subject data in a new file and then render it right here. You can see that it actually created a new file containing these mock subjects, and then it imported it right here. And it did that within a couple of seconds. So mock subjects is now coming from constants. You can see them right here. It even gave them their type. And you can see CS 101, for example, for computer science, math, English with a description and everything they need. So now very easily, we can simply return this data from the get list of our data provider. Oh, look, Junie did that as well. So it's returning mock data as unknown as tData array, and then it's returning the length of that array. Perfect. And with that, you've created your own mock data provider. Very soon, we'll connect this with a real backend, but for now, we're working with fake data, which is totally okay. So now, head back over to your app.tsx, and where we have the data provider, we can now simply do it like this. Data provider is equal to the data provider, but not one coming from refine dev simple rest. Rather, we will remove that import and import it from providers data.ts. This is our own data provider that we've created. If you do that and reload, you'll immediately be able to see a list of subjects rendered within the UI. That's the beauty of Refine. You defined routes, you wrote the UI, you defined a data provider, and Refine handled everything from making calls, in this case mock data, but we will add an API call later, and then pass it to the right component page. Home is empty, but subjects fetches this nice list. And notice how it's instantaneous, so it's even cached and it's handled on the server. If you try out the search, you'll notice that right now it doesn't work. And that's because Refine uses server-side filtering and searching, which means that on the front-end side, Refine already implemented the search. And we can verify that if you head over to the Refine DevTools under Monitor and you switch a filter, you'll notice that a new use list request gets made. If you scroll down, you'll specifically notice that it's applying the filters right here under list, filters, and you can see department equals CS as in computer science. So it's properly communicating it to the backend. But the thing is that our mock data provider right now is stupid and it always returns all the data, so it doesn't yet filter it. But later on, once we implement our own full stack application and our own backend data provider, we'll implement the complete search, filtering, pagination, and more from scratch. So stay tuned. But with that in mind, we already have a lot of functionalities right here, so it might be good to push them over to GitHub. We can do that by either heading to the terminal, or you can use Ctrl-Shift-G to open up the Git terminal directly here within WebStorm, where you can check out on which branch you're on, and you can create a new branch from the main branch if you want to. So full Git functionalities are built right here into your IDE. For now, I'll show you how to do it manually as well by running git checkout -b to create a new branch, and we'll call it feat as in feature data-provider. This will check us out to the new branch, run git add dot, git commit -m, implement data provider, and then git push to push it over to the new branch, but we'll have to set the upstream to the remote branch on GitHub because right now it's connected to the local version. Back on GitHub, you'll see that we have some new changes. So let's go ahead and open up a PR out of those changes. There we go, implement data provider, create a new pull request. Now, if you properly connected CodeRabbit at the start by clicking the link down in the description, then creating your new account with GitHub, and within your CodeRabbit workspace, if you have added your repo, Then you should get a message right here that CodeRabbit is currently processing the changes in this PR. This may take a couple of minutes, so let's give this rabbit some time, and then I'll be right back to review the changes we've made together with you. And the review's in. Let's see what the rabbit has to say. First, we get a recap of new features that we have added to our codebase. We introduce the Subjects Management interface with integrated search functionality and department filtering. We also improved the application styling with a component library for improved visual design. But now, let's get to the specifics. First, CodeRabbit gives us some nitpicky comments that we can fix if we want to, such as some better CSS class names, using static timestamps for predictable mock data, renaming func to function, and stuff like that. But where CodeRabbit truly shines is with the rest of the code review process. It shows critical issues. For example, it seems that we have a duplicate layer-based definition. I thought that we fixed this, but if I head over to app.css and check out layer base, nope, it looks like it's still doubled. We have one here for the theme, and then we have one here as well. So we definitely want to get rid of one of these. Again, I was checking this file, but I completely missed that we have a double layer base. So we easily fixed this issue. Now, the next one talks about the use of our new data provider. It says that the delete operations on subjects will fail at runtime. The mock data provider throws errors for delete one operations. And since the delete button component uses the use delete button, clicking a delete button on any subject will trigger the unimplemented delete button method. Yep, this is indeed true. If you head over to our data.ts file where we're implementing the data provider, you'll see that the get one, create, update, and delete are all simply throwing errors. This is just for now until we implement the real provider. So for now, we can just skip this suggestion. And there we go. This is the part where we talked about filtering, sorting, pagination, and search. Right now, the current implementation ignores the get list params, which are all about the filters, pagination, and sorting, and always return the full mock subjects array. Yep, this is exactly what we noticed when we tried to filter the table a couple of minutes ago. So CodeRabbit is simply telling us these features won't work until you fix this part, and it tells us exactly where we have to fix this. Good to know. With that in mind, we are ready to merge. But before I do that, I'll just commit the change or the deletion of those extra duplicated class names in the CSS file by running git add dot, git commit -m, remove duplicate classes, and git push. This way, we'll automatically get the change right here, and we'll be able to merge this now code reviewed pull request into our main branch. And this is why I love using CodeRabbit. It's a super quick and natural way to keep your codebase clean consistently, even if you're just working on a project solo, but it gets even more useful when you're working within larger projects within a team, so that it automatically gives your team some starting point to start reviewing the PR, such as what this PR is all about, what you're implementing within it, and which things might fail, so they can then check it further and suggest additional fixes. With that in mind, this PR has been merged. So let's check out back to the main branch by running git checkout main, and then running git pull to pull the latest changes that we pushed over into it. It's important that you do this because later on, as we start implementing other features, it's always important that you're staying on the main branch so that from that branch, we can continue branching elsewhere. Great. This was the first big lesson of the course. But in the next one, things will start getting even more interesting. It's definitely not fun to play around with mock data because you're here to learn real things. So head back over to your IDE and let's create a new folder. Right here next to the classroom frontend, I'll create a classroom backend folder. And we are ready to start creating the backend parts of our application, similar to what you learned in the crash course, using Node, Express, TypeScript, DrizzleORM, and Neon Postgres. So let's initialize a new Node.js project with a package.json file by creating yet another terminal window. This one we'll rename to backend, and we will cd into the classroom backend folder, and then this one will remain just the regular terminal one. Once you're within the backend folder, run npm init-y to initialize that package.json file, and you'll be able to see it right here. Now update the type of the package.json from common.js to ES module by typing module right here, which will allow you to use the import and export statements that we're using within React. Then go ahead and install Express by running npm express. And then we also want to install some dev dependencies by running npm install-d, such as TypeScript, TSX, add types/node, as well as add types/express. We'll use TypeScript for type checking, of course. TSX is a development runtime that will run TypeScript files directly inside Node.js, providing us with hot reloading and replacing TS Node. Then types node will provide some TypeScript definitions for globals, and same thing for Express. Now, to create a new TypeScript configuration, you can run npx tsc --init. And then as soon as you do that, you'll be able to see a new tsconfig appear right here. Now, I actually took some time to play with the configuration and to make it work with our backend application, and I'll provide you with the final tsconfig that I came up with within the video kit link down in the description. So if you go there and find the tsconfig file, simply copy it and paste it here. Then we'll also create a new .getignore file. This one will ignore all the files that we don't want to be pushed over to GitHub. And then on the web, if you head over to github.getignore, you'll be able to find a collection of useful getignore files. There's so many. You can use one for node.getignore, and you can simply copy it and then paste it right here. Now, remember, we have to have the starting point for running our server. So let's create it in form of a file. We can first create a new folder within which we'll place that file called source. And then within source, we can create a new file called index.ts. Since I've already taught you how we can create an Express.js server within the crash course, you can use this opportunity to recap what you've learned and try implementing it again on your own. Or what we can do instead is ask Junie to do it for us. So I'll press Command-Shift-P and open up Junie, and then we will start again, and we will ask it to do it. I'll say, set up a simple Express.js server in TypeScript that listens on port 8000, uses JSON middleware, has a root get route that returns a short message, and logs URL when the server starts, and press enter. I'm assuming this is a pretty simple job for Junie to do. It'll first try to fully understand what the task is, and once it did, it already did it in a couple of seconds. It even asks us if we want to run it, but for now I'll skip. But yeah, just so you know, Junie can also run terminal commands too. With that in mind, it has implemented it and it is done. So let's close it. You can see that we are simply importing Express from Express, setting up the port to 8000, setting up a simple route, and then a console where we're listening to it. Now, to be able to run this TypeScript backend application, we need to use TSX, which is that development package that we just installed. And for it to work, we have to add some package.json scripts. First, the dev script has to run the file using TSX. Oh, and this is possible, but did Junie actually do it for me? If I check this out, oh yeah, it actually updated the package.json to use TSX. This is great. The only change that we can add is to actually make it watch over the changes over the file. Then I'll also add a couple more scripts, such as the build, which will simply run tsc, which will compile TypeScript source files into JavaScript for production. And then finally, as soon as I fix these string signs, we also want to add a start, which is not going to watch over the changes. It's just going to run it. So we can do node dist server.js. This is going to start the production server. But now we most care about running it on the development side of things. So open up your terminal and run npm run dev. And you should be able to see a server running at localhost 8000. And if you actually open it up and zoom in, you should be able to see, hello, welcome to the Classroom API, which means that our backend is running. Now you can again head over to github.com/new and create another repository. Yep, this is a dual repository project as it's a real full stack application. So let's call it classroom-backend and simply create it. Once you create it, we can stop it from running and run git init, git add dot, git commit -m initial commit, then git branch m main, git remote add origin, and finally git push u origin main. With that in mind, if you head over here, you'll be able to see the code, specifically the new server that we just ran on the backend side. Congrats! We officially have the server. Now, in the next lesson, we'll allow this server to contain persistent data by introducing a database. To do anything with data, you need a database, you need to define schemas, and connect it and all that. And we went through that entire process throughout the crash course. So we'll repeat it right now together while building this larger full stack application. In the crash course, we already created an account over on Neon, so now we can just log in and you'll be redirected to your projects. There's one for classroom management already created, which we used as our car database. We can use the same one right here. Specifically, we'll connect from Drizzle to Neon. And take a look at this. Pre-built prompt for connecting Node and TypeScript applications to Neon using Drizzle RM. Since in the crash course, we went in depth into the actual process of connecting it from scratch and by hand, this is the right situation to just copy the prompt and let AI do the heavy lifting for us. You can use any coding agent to paste this prompt into. Of course, for me, I'll be sticking with Journey. So right here, you can paste the prompt that you just copied. It contains all the information needed for Journey to set up Neon and Drizzle RM. We can also tell it to use Neon serverless, like this. Journey will now go through our application and try to figure out exactly what we're doing. And this is the feature that I've just recently come across, and I love it a lot. When Journey thinks that you might want to have a say in what it does, it actually asks you a question on how you want to get some things implemented. So in this case, this is an important decision. It's asking us to choose between our preferred driver and Drizzle adapter, such as Neon Serverless, Neon WebSocket, or Node Postgres. In this case, I'll just press 1 to proceed with Neon Serverless. Perfect. It verified it and will now proceed with everything. Now, to be able to do this properly, it also needs to run some terminal commands. So it's going to ask you whether it has the permission to do that, and you can just allow it. You can also follow along in case you don't have Journey, and you can write these installation commands on your own, or you can follow the docs over on Neon. That's npm install, Drizzle ORM, as well as Neon Database Serverless, and .env, as well as npm install-d Drizzle Kit. It's also asking us whether it can create our envs for us. Sure, let's say yes. And you'll see that now it'll start adding more files for us. The Drizzle config, the schema.ts, db.ts, Drizzle demo, and even updates to the package.json. Perfect. That's it. It has successfully integrated our project with Neon and Drizzle using Neon Serverless Driver. So let's go through the codebase together and let's see exactly what happened. Now we want to make sure that these files follow our own structure. So right here, I'll create a new folder within the source folder, which we'll call db. We'll move the db.ts file inside of the database, and we'll simply rename it to index.ts because it is already within the db folder. Then within the db, we'll create another folder, which is going to be called schema. And we will move this schema.ts inside of it, and we'll rename it to index.ts as well, as it's acting as the starting point of our schema. Now, this file won't contain an actual schema like it does right now, but rather it'll export all of the other schemas. So let's create a new file called app.ts, within which we'll write the schemas for our application. And then within this schema.ts file, we can simply export everything from /app.ts. Make sure to add the extension. Very soon, we'll start applying the schemas right here. But before that, let's check out the Drizzle config. Here, we're importing .env config as well as the find config. We're then setting up the database URL and then exporting the configuration. The only thing we have to do is modify the path to our schema by saying /source/db/schema/index.ts. And we have to make sure that we have our database URL right here. Neon just filled it up with blank data, but we have to get our own directly from the workspace. So head over into your application, click connect, and copy the connection string. Once you do that, you can simply paste it here and call it database URL. Perfect. So now that we have that as well, we're set with the database connection. You'll notice that we're using the same connection that we had within our crash course. So you can head over to tables, and the only thing you have to do is delete the cars table. After you delete it or drop it, you'll notice that it'll basically be an empty database waiting for us to add new stuff to it. And now it's time to define schemas for this application, which is about deciding where and how to store the data. So that is the perfect time to show it to you visually. I have this image right here that shows you the wrong approach, where you have different kinds of subjects and teachers, but we're storing everything as strings. So department is science, 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 math, math, math. So essentially, when you need to rename a subject, it'll be super difficult as you have to rename it across every single row. Same thing goes for the teachers. You're repeating a lot of information. But if you look at the database from the entity approach, this will just make sense. You first have to create a new entity called a department that has just one name mentioned once. And then you can create different subjects and teachers that reference that department. So if you decide to change it in the future, it is super easy to rename it. It is also scalable because you can add new pieces of info to it, and it allows you to manage multiple subjects and teachers, which is always super handy. So if you think about it, this department within our application isn't just a label. It's a real thing. It manages multiple subjects within it, has teachers attached to it, and might later have its own information, like a head of department, description, and settings. So if you try to store it as strings, it just feels wrong. So we always want to store things as entities. The big idea here is when something has its own identity, like a department, and it connects to multiple things, like subjects and teachers, then it deserves its own table. That's the kind of mental shift with database design. You stop thinking in terms of fields and start thinking in terms of real-world objects and relationships. And once you do that, the schema almost designs itself. So head over into schema app.ts and let's start defining it. First things first, we can export and create a new departments table. It'll be equal to PG table coming from PG core. That'll have a name of departments. Then we can provide some columns, such as the ID, which is going to be of a type integer with the name of ID. It'll be the primary key, but first make sure to actually import integer coming from PG core, and then you'll be able to make it a primary key. And you can say generated always as identity. This will tie it to that entity. Then each department also has a code. It's going to be a varchar coming from PG core called code with a length of about 50. It must not be null and it must be unique. Let's also give it a name, which is going to be a varchar of name with a length of about 255, and it's going to be not null. And let's give it a description, which is going to be a varchar as well. This one maybe can be null. Then we want to create the timestamps. It's going to be the created at and updated at timestamps. But instead of creating them right here for every single entity that we have, what we can do instead is just define them right here by saying timestamps is equal to an object where we define the created at set to the timestamp coming from PG core. And then we can call it created at and make it default to now and make it not null. We can also then add the updated at, which is going to say updated at, defaulting to now. And it's going to have a special $on update property where we simply want to set it to the current date when it gets updated. And it also must not be null. So once you have the timestamps, now it's very easy to just destructure them at the bottom of every new table. Now we want to do a similar thing with the subjects. So here we have the departments, which I will simply duplicate right below. I will rename it to subjects. It'll still have the ID primary key generated as identity. It'll have not a code, but a department ID. This is important. So this is going to be an integer called a department ID, which is going to be pointing or referencing to another table. So here you can say dot not null and dot references. And here you can create a callback function and make it reference the departments.id. And specifically on delete, we want to restrict what we are able to do with that. Then each subject will also have a name, same as before, and each subject will also have a code. So I think we can just copy the code from before. Varchar, length 50, not null, unique, and then finally a description. And then we spread the timestamps. So now we have created two separate tables, but let's actually create the relations between those tables as well by saying export const department relations, which is going to take in the departments table, and we can destructure something known as many right here, and then automatically return subjects, many subjects, like this. But you have to wrap this in a relations part coming from Drizzle ORM. This will create a relation between departments and subjects. And if you need a better explanation about anything that we're doing within our code, you can also open up Journey, copy that line, and say explain it simply, and paste it right here. And it'll give you a full explanation of exactly what this code is doing. It won't try to modify it or anything, it'll just provide an explanation. So in this case, this line tells the database, hey, I want to define how the departments table relates to other tables. The many helper is used to indicate that one department can have multiple related items. In this case, it can have many subjects, okay? So why are we doing this in the first place? Because it'll create a virtual property called subjects that we can use when querying data. Without this line, if you fetch a department, you just get the department info. But with this line, you can easily ask the database to give me a department and include all of its subjects in one go. That's super useful. So let's also do the same thing for getting the departments related to a specific subject as well. I'll call this subjects relation. I'll say relations subjects. In this case, we'll get both one and many, and we want to define it like this. Department is going to be one departments, but then from within it, we want to get access to fields, which is going to be an array of subjects.department ID, as well as references, which is going to be an array of departments.id. And I'm just noticing that this line is a bit longer, so we'll actually put it in multiple lines. And let's make sure that we're properly closing it as well. There we go. This is looking good. And now we can let TypeScript know what we just did by exporting a new type of department and make it equal to the type of departments dot $infer select. This will use type inference from database table schemas, so your app types always stay in sync with your database. Basically, it'll auto-generate types for you based off of your database schema, so you don't have to define types manually. And we can do the same thing for a type of new department, which is going to be type of departments that $infer insert when we're inserting a new one. And we want to do the same thing for the subjects. So I will duplicate this below and rename it to subject as well as new subject. Perfect. And these are our schemas. Now, of course, Neon Postgres won't understand this by default because this is drizzle code. So to make sure that Neon understands whatever we've written, we have to generate the corresponding SQL from the defined schema. And the command for that is automatically created for us by AI, Journey in this case. So if you head over to package.json, you should be able to see a db generate command, which is going to run drizzlekit generate. If it's not there for you, you can create it. But with that in mind, let's see if our index is properly mentioning the app.ts. So export everything from app.ts. Maybe we don't have to add the ts extension. Then open up the terminal, make sure that you are in the backend folder, and then run npm run db generate. You can see that the new SQL migration file has been generated for us. You can see it right here. There we go. It's much easier to write that drizzle part rather than writing this SQL by hand. But on that note, I'm now preparing a complete backend course, which will include drizzle as well. But if you want me to dive deeper into native SQL, writing it by hand with all the benefits that it provides, let me know in the comments down below and sign up for the backend course waitlist so that I can share the first lessons with you as soon as I create them. With that in mind, now that we have this SQL generated for us, we can then run another command, which is going to be npm run db migrate. And this will actually run the SQL migrations and we'll be able to see it within Neon. So if you head to the Neon console and reload, you'll be able to see departments and subjects. And now we can create a couple of records so that our database is not empty. We can do that right here through Neon's SQL editor. Let's clean it up and follow my lead. We can type insert into departments. Specifically, we want to add the code, the name, and the description. And specifically, we can insert the values of, let's do ECE, which stands for electronics and communication. And then we can provide a description such as circuits, signal processing, and telecom, just for example. Then we can also insert into subjects. We need to connect this to a specific department ID, like this. Give it a code, a name, and a description. And now we can enter some values, such as department ID of 1, which is going to be CS, computer science. It's also going to be a string. Then we can do data structures. And we can say some description like algorithms, lists, and more. And then we can do maybe another one like 2, which is going to belong to this newly created department, which is going to be ECE. The subject is going to be signals. And description can be something like analysis of EC signals. And now you can run it. Make sure you close this line with a semicolon right here, and you'll see that it'll run it successfully. So if you head back over to tables, you should be able to see a new department created for us. It automatically got these new created at and updated at fields, and it also has subjects linked to it. And now if you head over to the subjects, oh, it looks like there are no rows right here. Let's head over into the SQL editor, and let's maybe just add the subjects on their own to see whether it succeeds. Oh, it looks like I missed a comma right here, which is why they weren't added. Oh, and this is good. I also put ECE, which is actually the code of the specific department. So it can also be the code of the subject. Subjects need to have specific, maybe IDs attached to them, like ECE 204 to be good. So right here, I'll do CS 2010, and then maybe ECE 101. And run it. Looks like we still have an issue, so I'll go ahead and try to fix it with AI this time. It nicely comments it out. This is pretty cool to see AI solve this in real time for you. So to fix this, we need to ensure that the department IDs you're using, 1 and 2, already exist in the departments table before inserting subjects table. If these department IDs don't exist, you should first insert them into the departments table or use existing department IDs from the departments table. Okay, this is pretty clear. So what I'll do is I will bring this back by uncommenting it, and then I will check for existing department IDs. In this case, I think we only have the ID of 1 department ID. So I will make both of these regard some kind of ECE stuff right here. and run it. There we go. It went through. So now you can see we have 2 subjects and all of them are related to a specific department of ECE. And that department also now includes 2 subjects. Wonderful. We just inserted our first data into the database. With Postgres, you can always execute direct SQL queries to get the desired data. And the reason why I'm trying to say that is that you know that you don't necessarily have to rely on ORMs like Drizzle. Sure, we use them to make our life easier, but you can switch at any time and still use SQL if you want to get access to some more complex data queries. Now, let's open up our terminal, still in the backend part of the code, and let's create and check out to a new branch by running git checkout-b, and we can call it feat database schema. Then we can run git add dot, git commit-m, implement database schemas, and run git push. Of course, we'll have to set the upstream to the origin remote repo. Immediately, you'll see that your backend repo, not the frontend one, has some recent changes, which we can open up the pull request for. So let's go ahead and verify our code works properly. If you haven't already, also hook this repo up to CodeRabbit so it can provide proper code reviews. It's gonna take a couple of minutes, so let's hold on a bit while CodeRabbit ignores us and works on the code review. In this PR, we have added the database infrastructure with departments and subject data models for structured data management, and we introduced database migrations to initialize and manage schema changes. Okay, and after a more detailed review, CodeRabbit was able to provide us with a bit more information, telling us that this PR introduces a complete Drizzle ORM and Neon Postgres database integration, including configuration files, SQL migrations, schema definitions, database client init, and a demo script for testing CRUD operations. It specifies what we're doing per cohort of files, and it says that a mere human would take about 25 minutes to review this PR. And it even provided a quick poem that we can read, specifically dedicated to the changes that we implemented in this PR. Hop, hop, hop through data's hall, Drizzle brings the SQL call. Perfect. TLDR, we have our database. So now let's go through the potential changes. You can see that there's some nitpick comments that Drizzle provided. These are mostly renaming changes, which you can go through if you want. But what I care more about are these potential issues. This one being critical. It says that we have the incorrect table reference for subject types. Ooh, this was a good one. You know that I duplicated this code from departments, and even though I changed their names, I forgot to change this part right here. So still, the subject and new subject are referencing departments instead of subjects. This will cause incorrect type inference. I love this. This is easy to miss because it wasn't a typo nor an error. The code is syntactically correct, but the issue is there. So this is a critical issue, and we are immediately given a proposed fix, which we can just copy right here, get back over to our schemas, and just modify it. So now these subjects are actually referring to the subjects. Good. Going back, we have another critical error saying that the barrel export is incomplete and will cause a runtime error. Demo users imported in source Drizzle demo, but not exported from the app. Okay, this is one file that was created for us by Junie, where we're inserting some CRUD operations and some basic users, but I don't think we'll actually need this, so I'll delete this Drizzle demo.ts file. Good Rabbit told me that we don't need this extra file. And finally, there's a potential critical issue where the demo users table is not defined in schema. This is again from the Drizzle demo file that we just removed. Perfect. So now don't forget to actually push the changes by running git add dot, git commit-m, implement code rabbit suggested fixes, and run git push. Again, make sure that you are within the backend repo. It'll automatically recognize the changes and you can merge them. Notice how if we stay consistent and if we open up PRs for every new feature that we implement, we'll be able to caught the issues on time, which is why I love using CodeRabbit on my projects right from the start. Perfect. So now that we have created our database, hooked it up to our backend, and even added some departments and subjects within it, what do you say that we go ahead and hook it up to our frontend so we can display the real data there too? Let's do that next. In the last lesson, we implemented the database. Now our frontend is ready to showcase the data coming from it. But what remains is the backend that will facilitate the connection between the database and the frontend. So let's create that backend API, a waiter in a restaurant between a chef and a customer. We can do that by creating a new folder called routes within the source folder in the backend part of the application. And then within the routes folder, create a new subjects.ts file. Within it, you can define a new router coming from Express, and then define the route by saying router.get, where you're going to get the request and the response. I don't think it's needed to heavily type them right here, so you can just define the request and response like this. This route will get all subjects with optional search, filtering, and pagination. Perfect. So to implement it, we can first wrap it in a try and catch block in case something goes wrong. We can simply console.error, and we can be descriptive about it, saying get/subjects error, and then we can render the actual error right here. And don't forget that we also have to return something. Specifically, we're going to return a status of 500 that's going to bring back a JSON object that says error and then failed to get subjects. This way, if something goes wrong, we know exactly where it went wrong. Now, remember when I told you that we are doing some filtering and search on frontend, but our backend at that point wasn't yet accepting those props? Well, they are coming here. So let's destructure them. We get the search prop, the department prop, the page, which we can set to 1 by default, and the limit, which is going to be 10. And all of these are coming from rec.query. Then we can get access to the current page by saying current page is equal to, and we need to ensure that the page number is at least 1. So I'll say math.max 1, and it's going to go all the way up to the limit, so plus limit. Then we need to ensure that the limit per page, like this, is at least 1 as well. So that's going to be math.max 1, and then plus limit. And this one here was supposed to be plus page. So it's going to be at least 1, but it can potentially be the page number that we pass into it. Same thing for the limit. Then we need to figure out the offset. That is how many records to skip to get to the next page. We can do that by getting the current page -1 times the limit per page. Then we'll define an array to store the filter conditions. So say const filter conditions is equal to an empty array. Now, if a search query exists, we want to filter it by subject name or subject code. We can do that by saying if search filter conditions dot push, so we're pushing additional conditions, we'll use the OR functionality coming from Drizzle ORM, as well as the I like, also coming from Drizzle ORM, where we want the subjects, which are coming from our DB schema, dot name or dot code, to match the thing that we have in the search. Okay, so if search query exists, filter by subject name, or this is that or by subject code. Then we want to do the same thing for the department. Right below, I'll say if department filter exists, match the department name by pushing the additional condition departments.name. So make sure to import the departments coming from our schema. Now we can collapse those two. Finally, we want to combine all filters if they exist using the AND operator. Again, this AND is coming from Drizzle. Then we need to get the count of all the elements on the page. So that's going to be count result is equal to await db dot select. So specifically, we want to get access to the count, which is going to be SQL number, and then we want to specify the count of all the elements. This SQL part is coming from Drizzle ORM. and it allows you to run native SQL queries. Specifically, we want to get the count from the database, so make sure to import this DB, and it'll be coming from /DB at the top if it doesn't get auto-imported. So we are selecting that right here. After we select it, we also want to take it specifically from the subjects table. So it's going to be from subjects. Then we want to apply something known as a left join. So .left join, where we want to join the departments table as well. Specifically, what a left join does is it returns all rows from the left table and the matching rows from the right table. So we want to take all the data about the subjects, but we also want to get access to the department ID, so subjects.department ID, where it matches the ID of a specific department, so departments.id. And we have to get access to this EQ operator coming from Drizzle. And finally, we want to say where, and where it matches the where clause, which are our filters. That's going to give us access to the total count by saying count result 0 ? Count, or if it doesn't exist, we'll make it default to 0. And then we want to query the data. We can do that by saying const subjects list is equal to await db.select, and we want to select the spread of get table columns. And this is coming from Drizzle ORM, to which we need to pass the subjects. So what get columns does is it gets all the columns of that specific table, but it also adds additional columns that you want to add. So in this case, we are getting all the columns from the subjects, but we also want to add the department column where we will spread get table columns for the department as well. And I will put this into multiple lines so it's a bit easier to see, just like this. And here we pass the departments. Now I'll put this into a new line just so we can see it a bit better. And to this select, I will chain .from subjects .left join, and here we want to attach the departments. Specifically, we want to attach the subject's department's ID, where the department ID matches the one attached to the subject. We want to attach the where clause, and we also want to order it by. So .order by, it's going to be in descending order, so make sure to import that from Drizzle based on the subjects.created at. We want to limit it to the limit per page that we had, and we want to offset it by a specific offset. I know this was a long query, but this will give us the data that we need. It's going to contain both the subject's data as well as the department's data. So now let's return it by saying rest.status of 200 and then .json. And now we can format that data in the way that we want, such as data will be the subject's list. And then for the pagination, we can pass additional information such as page, which is going to be set to the current page, the limit, which is going to be set to the limit per page, the total set to the total count, and then finally we can pass the total number of pages, which is going to be math.ceil of total count over limit per page. Perfect. And this is now a query that will return all of those subjects with the department data attached, and also at the same time allow for querying, filtering, and pagination. So now let's go over to the source index.ts, and let's create a new router for the subjects by saying app.use. It's going to be /API /subjects, and we'll pass in the subjects router that we just created. Not the subjects coming from the schema, but rather the subjects router, which we needed to export from here. So I'll say export default router, and then we can refer to the router we just created, but we can rename it to subjects router because later on we'll have some additional routers as well. This is coming from routes subjects. And again, make sure that it is actually exported at the bottom by saying export default router. And now if you open HTTPy and create a new request, let's see whether it's working. we want to point it to 8000. That's where our backend is hosted, /API/subjects. And of course, let's make sure that our backend is running by running npm run dev. Oh, looks like we're importing DB in routes subject, but we cannot find it there. So let's make sure it's coming from the right place. DB, it is being exported, but let's make sure that it is exported in the right way. We can export the DB right here, not the index. If you do it like that, it'll be able to properly recognize it. Let's see if that is the case. We're using the DB right here. So we can say DB, and then at the top, we can say import DB as a named import. And you can see if I type D, it's directly coming from here, and it is correct. So now the server is running on localhost 8000, and we can try to make a request. And take a look at that. We get back the data with a couple of subjects. We have subjects with ID of 5 and 6. It's signals and data structures, having specific code, having the description of the subject, but also having all the necessary information about the department that that subject belongs to. So now we can very easily extract additional information about the department. And we also get some additional information about pagination, such as the page we're on, the limit, and the number of total documents. We can also try seeing if search and filtering works. So for example, if we do $search is equal to, well, let's do signals, it should be able to give us just this one and not the one with data structures. So if I do search, you can see that we get back only one, and the pagination data has fixed. What if we try to get the information for the second page? By setting the page to 2, you'll see that there's no data to show on the second page. Pretty cool, right? And finally, if we also try to fetch the data by department, by setting it to something like, well, what do we have? I forgot. I'll leave it empty for now. Department name is electronics and communication. So maybe if I just start typing electronics, it should be able to find it, and it actually finds both because the department for both is set to electronics. Wonderful. Now you can follow this same exact template of sorting, pagination, and search for rest of the API endpoints, like getting a list of departments, classes, users, enrollments, whatever it is. The process will look exactly the same with a tiny bit of changes on the main data query where you might want to join some tables. But I suppose you already have a pretty good idea of how it works. Okay, great. Now, before we use this API on the front-end side, we have to enable CORS. Remember at the start, I was telling you a bit about how CORS works. Browsers block front-end apps from calling APIs hosted on different origins. And without explicitly allowing the requesting origin to be able to make calls, the browser will refuse responses before our server code even runs. Enabling CORS tells the browser which origins, methods, and headers are safe to use so the client and server can exchange data securely. In practice, setting CORS is vital for modern apps where the UI is often served from a different domain than the port on the backend. So to set it up, you can simply head over to your terminal, make sure that you are still on the backend. So that's going to be classroom backend, and run npm i CORS. Then let's install the types for CORS by running npm i --save-dev at types/CORS. Now within our backend code, not frontend but backend, head over to your env file, and below the database URL, add a frontend URL so that it knows who it is talking to. It'll be equal to http://localhost 5173. And don't add an additional / at the end. Keep it like this. Then go to our server file, which is the index, and right here below the port, define CORS by saying app.use CORS. Provide additional options, such as the origin, which we're going to set to process.env.frontend URL. This is going to be the React app URL. And then add the methods that will allow, such as the get, post, put, and delete. and provide additional credentials by saying true, which simply allows for cookies. And make sure to import course coming from the new package that we just installed called course. And that's it when it comes to course. So now that we have added these changes, let's go ahead and push it over to GitHub. Before I push it, I'll pull the latest changes. Oh, and we have to make sure that we're on the right branch. So do a git status. It seems that we're currently still on the database schema branch, which for now is still okay. So what I'll do is I'll run git add dot git commit -m implement get all subjects route and run git push. This will push the changes over to GitHub, and you'll see that we have some recent changes 4 seconds ago. I'll open up another PR. This one only had 6 little file changes, mostly the file where we actually created this additional route. The rest was the setup. So this should be super simple for CodeRabbit to go through. All faults understood. Let's give it like literally half a minute, and I believe it'll already prepare a code review for us. If you take a look at the walkthrough, it's clear that we introduced core support, as well as added a subjects API endpoint with search, department filtering, and pagination, as well as applied updates to the Drizzle configuration to reference this new schema. What I love about walkthroughs is that we're also getting sequence diagrams. And I think this is the first time in the application where it actually makes sense to start seeing one. So you can expand it, and this explains exactly what we'll focus on next. The client, in this case the browser, will make a GET request to the API subjects API. It'll provide optional search parameter, department, and page params to our Express application, which will then process the request through the course middleware. It'll validate it, and only once it's validated, it'll speak to our API subjects, which will then speak to our database, getting the count, selecting the needed things from the database, joining the rows, and then finally return that data over to the front end. This is a beautiful diagram explaining exactly what we have implemented and the flow of our application. So let's scroll down and let's see whether we have some fixes. Okay, this is potentially a big one. It's a critical issue where we need to update the schema path to reference an existing schema file. The path index.subjects.ts does not exist. I don't even remember making this change. Maybe it was done by my IDE automatically when I was renaming files. So again, this catch is absolutely huge. I can't even imagine that we have this mistake directly within our code right now. But hey, it looks like it's here. So this is incorrect, and instead, it should only be pointing to the index. So remove the subjects. Huge catch. Then we have another one, potential issue, major. Validate frontend URL environment variable for security. The course configuration uses it without validation. If it's undefined, the origin will be undefined, which will result in an error or a security vulnerability. So the proposed fix is to add a simple if statement, which we can do right here at the top of our index.ts file, where we can check if process.env.frontendURL doesn't exist. We can then simply throw a new error. I like this. Then we have some validation and maximum limit enforcement. The current implementation has 2 issues. If non-numeric values are passed, plus page or plus limit will produce not a number, and math_max1 will return not a number, which leads to invalid SQL queries. Interesting. So we definitely have to apply the fix right here, and the fix is to properly parse integers. So let's go ahead and copy these changes and paste them over right here where we have our subjects route, where we're doing the number count up. We will remove these 2 lines and instead add the 2 new ones that are properly parsing the numbers without resulting in not a number in edge cases. There's another one, which is critical. SQL injection vulnerability in department filters. Okay, the department parameter has the same SQL injection vulnerability as the search filter. User input is directly interpolated as the SQL query without proper escaping. This is huge. So what we need to do is escape specific patterns. So I will copy these 2 additional lines, head over to where we have the department query, and I'll paste them right here. Let's make sure they're properly structured. There we go. And this will protect us from SQL injections. Soon enough within this application, we'll also implement Arcjet, which will take an even deeper dive into protecting us from all sorts of different attacks. But the fact that CodeRabbit was able to catch this SQL injection vulnerability is a huge plus. And finally, the last issue is a syntax error. Interesting. There's a syntax error in line 51, okay, where a stray period dot appears before the order by. Oh no, it's not a mistake. It was supposed to be on line 52, but it's just here. So the only change we have to make is just add it at the start of the line and not at the end. Okay, it's not gonna break anything, but I agree it is a bit weird. So we'll just take this dot from here and put it right here. Okay, overall, very, very valid feedback and code review done by CodeRabbit. So let's go ahead and implement those changes by running git add dot, git commit -m, implement suggestions from CodeRabbit, and then git push. Once that is done, you can merge the pull request because we know it's good and safe. And then back within our application, you can switch back to the main branch and pull all the latest changes by running git pull. That way, we have a clean slate to continue working on the application. Because in the next lesson, we'll dive straight back into frontend so we can consume the backend API we just created. And now we are returning back to the frontend side. So let's make sure our application is running, which it is. But let's say we have gotten tired of the current theme. So for a second, I'll head back over to Tweak CN and I'll choose another theme of our dashboard. There's the boring default, there's the amber, amethyst, bubblegum. So for the time being, let's go with, I like this one, cyberpunk. So let's go ahead and take the code, simply copy it, and then back within our source, app.css, we need to replace the theme inline, the root, and the dark. So these are the three that we need to remove. Keep the layer components, but remove the theme, dark, and root. As soon as you do that, our application will completely change. I'll keep this theme for some time and then we might switch it back later on. Now, in our last front-end lesson, it was all about learning how the data provider works, where we created a mock data provider with static data. We implemented the endpoints and used them on the subjects page to display all the subjects without filtering and pagination. In this lesson, we'll replace that with a REST data provider, officially making this a full-stack PERN course. Now, Refine offers a REST data provider that makes it easier to build custom data providers for REST APIs. You just have to give it your API's base URL and rules, and the Refine will automatically handle fetching, creating, updating, and deleting data without manual fetch or Axios calls. So let's install it by opening up our terminal, this time switching back to our frontend side, so cd classroom frontend, and run npm i @refinedev/rest. And before we implement the REST data provider, we'll have to code out a lot of different types that we want to use throughout this application. Thankfully, we already have the types file where we only have the subject. But now we'll also have to keep track of the departments, of all the different responses, and everything else that needs types in our application. Since this isn't a TypeScript tutorial, I won't bother you with typing these out manually. So in the video kit link down in the description, you'll be able to find a full types index.ts file, which you can copy and paste over here. It starts with the subject and then moves over to the list, which should seem familiar because this is exactly what our backend is returning. Still, if you want to get a full TypeScript course, let me know down in the comments below and I'll create it. Now, let's create a new .env file, this time in the frontend part of our application, and add a vite backend base URL, which is going to be equal to http:// localhost 8000 /API / at the end. And instead of importing this variable everywhere by simply typing this, import meta, env, vite, backend base URL, and so on, we'll create a constant so that we can simply say backend URL. Much simpler, right? To do that, we can head over to source constants, where we have declared these departments. And I'll now provide you with a list of full departments, department options, and everything else that is static within our application. I'll also leave it linked in the video kit down below, so you can copy and paste these constants index.ts. One of the lines right here is that backend base URL that we created, which now we can use by simply referring to a variable instead of this string of characters. Don't forget to add your .env in the git ignore part of the application if it's not already there. I can't see it, so I'll definitely do .env right here to make sure that it doesn't get pushed over to GitHub. Now head over to source providers data.ts and let's implement a new REST data provider. Idea is the same with the get list and get one endpoints, but the syntax will change a bit. So let's start implementing it from scratch one more time. I'll first define the options that we need for our data provider of a type create data provider options coming from refine dev rest, and that's going to be equal to an object where we can define the options specifically for get list. And then we'll create a new data provider by saying const destructured data provider is equal to create data provider coming from refine dev rest, and then pass in the backend base URL coming from constants, as well as the options. Finally, export the data provider like this by saying export data provider. Now, within this get list, we can define something known as get endpoint, which is going to take in the resource and it'll simply return that resource. Then we can also map the response. That's going to be an asynchronous function where we get access to the response, and we want to get access to the payload that we're passing over of a type list response is going to be equal to await response.json. And then we simply want to return the data that we get from the payload by saying payload.data, or if it doesn't exist, it'll be an empty array. And finally, we want to get the total count, which is going to be equal to an asynchronous call that's going to take in the response. It'll first take in the payload, as before, of a type list response. That's going to be equal to await response.json. And then from it, we'll extract the total by saying return payload.pagination (total), or if it doesn't exist, payload.data (length), or if it doesn't exist, then 0. So we now created 3 different endpoints that we can call that return the responses and the total count. If we do this properly, then Refine will handle it in a way that allows us not to have to change anything within our application. So if you now head over to the subjects list, we don't have to do absolutely any changes here for this to work properly. But still, the application will break. If you check it out, you'll see that we get an error. That's okay. It's breaking because of the department value. Earlier, when we mocked subjects, department was a string, but now department is an object. So to fix this, go to the subjects list and change the department value in the subject column. So that's going to be right here under columns. And we have the department, and the accessor key is going to be the department.name because the department is an object. Now, just before we test it out, make sure to head over to your .env and make sure that the name is spelled correctly. For me, it doesn't say base, so just make sure this is correct. Then if you head over to the browser, would you look at that? These 2 rows are coming directly from our database. The descriptions we wrote, the departments, the names, and even the codes of those subjects are here, and we can see the department. this is working great. Finally, we can see the real data that we have in our database on the front-end application. But hey, if you search for it, something like data, you'll notice it doesn't do anything. And if we try to map over the departments, yeah, these departments aren't yet real. This is just fake dummy data for now. So that's not gonna work, even though we tested it and implemented it on the backend. Well, to make it work, we have to build the search query params and let Refine know about them. So head back over into our data under providers, and right here below the get endpoint, build query params. It's going to be an asynchronous function where you get access to the resource, the pagination, as well as the filters. And then we can do something with them, such as we can set the page to be equal to pagination, (current page, or 1. This is coming from the backend. Then we can set the page size to be equal to pagination, (page size, or 10. And then we can set the params to be equal to page and the limit, which is going to be page size. Finally, we want to loop through all of the Refine filters by saying filters, (for each filter. We want to extract the field name. So field is equal to field in filter. If it exists, it's going to be filter.field or an empty string. Then we want to convert the filter value to string for query params by saying value of string filter.value. And then we want to handle the filters only for the subject's resource. So if resource is triple equal to subjects, in that case, we can check if the field is triple equal to department, then we want to set the params.department to be equal to the value, like this. And similarly, if the field is equal to name or field is triple equal to code, in that case, we want to add that as the search param. So this is the department param, and this is the search param. Just so TypeScript knows what the params are, we can define the type of these params, which is going to be a record that accepts a string and a string or a number. And finally, we have to build those params, which means that we have to return them. So say return params. Perfect. So now we're building out the params that our API will be able to consume. So now if you try to search by code, I think we implemented the search by code. So if you type 101, you can see that you'll get the one that matches that code. If we try to search by name, such as signals, that also is working. What about data? Yep, data structures, that works as well. And that's exactly what we wanted. Now we have to make it work for the departments, because currently we're displaying a list of fake departments that don't yet exist within our application. To implement that, we have to make a GET request to call the department router and then display it. It'll be similar to subject router GET request that we implemented before. We'll do that later, as you already learned the main thing, and that is getting back the data with support for pagination, search, and filtering. It's all about practice. You can get the departments by yourself by pausing this video and trying to implement it, or we can do it later. For now, let's push this over to GitHub so we can get it checked by CodeRabbit. I'll first run git status to check which branch we're on. It seems like we're on the main, which is great. And then we can create a new branch by running git checkout -b, and I'll call it feat rest data provider. Then we can run git add dot, git commit -m, implement rest data provider, and finally git push, but we'll have to set the upstream to the origin branch. So copy and paste this command. Once that is done, head over to GitHub, but open up your frontend repository, not the backend one, and then compare and open up a pull request. Then let's wait a couple of seconds for CodeRabbit to wake up and a couple of minutes for it to provide a code review. And there we go. This PR establishes backend integration infrastructure by introducing envs, configuration files, restructuring dependencies, and completely redesigning the CSS theme. But we did that in a couple of seconds. So here's the diagram, but this time from the client side. client or React requests the list of resources alongside with filters and pagination. Then Refine data provider maps filters to backend format, such as the department or the department name. It makes a GET request to our backend API, which returns the payload with the data. And finally, we can render it back to the frontend. In this case, there's a slight issue with ESLint and a minor issue with a Refine dev simple REST dependency. Now that we're using the REST API, no longer do we need simple REST. This is such a nice catch that allows us to very easily remove an extra dependency to our application that we don't actually need. And finally, we have some minor issues of unused options within the constants, but we're planning on using these later on, so that's good. And another suggestion right here is that we can add checks and verifications to make sure that our environment variables actually exist. But we can do that once we actually add them. But this is potentially huge. Here in the provider, we're trying to read the payload multiple times, but without cloning it. Since a response body stream can only be consumed once, the second call will fail at runtime. So we have to use response.clone.json in both functions to independently read the response body. So the fix is clear. Both in the map response and in the get total count, use await response clone JSON. We can do that right here by heading over to the data in the provider. And then instead of response JSON, we can use response clone JSON. Similarly, we need to add the validation for the missing backend base URL. Based on the search results, both of these require that base URL, which is coming from here, but envs could be undefined if you misspell them like I did. So what it's suggesting is that we add this validation within the data.ts file, which is exactly what I'll do. So if we head here at the top, I'll check if there is no backend base URL variable, then we simply want to throw a variable letting us know that we need to add it to the env file. With that in mind, I'll go ahead and add those additional changes by committing them and saying implement CodeRabbit suggestions and pushing them. Once the changes are recognized, we can immediately merge the pull request and get back to our application by checking out to the main branch and running a git pull, so we pull the latest changes to the main branch as well. And with that, we are ready to continue with the development of the application. Before you move on to building the next parts of the application and learning new concepts, let's pause for a moment and try something a little different. So far, you've learned a lot, and we wrote a lot of code manually. So now I want to show you how we can develop the same thing we've done so far with AI. The goal here is demonstrate how you can take everything you've learned and then with help of AI, in this case Refine, recreate it and extend it in a matter of minutes. This lesson is all about teaching you how to prompt efficiently and how to use AI as a development coding partner, as a tool that amplifies the knowledge you already have. For this, we'll be using Refine, which I found to be one of the best tools for generating dashboard-style applications with AI. It's built on top of Refine Core, the same foundation you've been using throughout this course, so everything will feel familiar. You'll find a special link to Refine down in the description. It is completely free to get started with, no credit card required, and specifically with the link down in the description, you'll get more than enough credits to build multiple projects. So let's dive right in and see just how far AI can take us. To get started, click the Refine link down in the description. It'll redirect you to this landing page telling you a bit more about exactly how Refine works, but I don't think you're here to read the docs or click on the tabs on the landing page. You're here to see just how powerful it actually is. So first, go ahead and sign up for free. You can do it using GitHub, and that'll redirect you directly to a place where you can start crafting your project. The first thing we have to do is either connect to Supabase to start creating our backend, or to connect to a REST API. Thankfully, we have already developed a huge portion of our REST API, but we haven't quite yet finished it, at least not at this point in the video. So for now, to show you how Refine works best, I'll provide you with the final hosted backend, as the goal is to learn how things are done. You will then use this backend to help Refine understand the API and generate a complete frontend with full functionality. But again, don't worry, because after this lesson, we'll continue developing this API on our own. I'll provide the full link in the video kit link down in the description. Alongside there, I'll also provide the full final code base so you can check it out completely for free. The second step that we need to do is to upload our Swagger schema. That way, Refine can learn about our API. Swagger is built on the Open API specification, which is a standard format written in YAML or JSON. Its goal is to describe your API endpoints, request parameters, request and response bodies, authentication methods, and status codes. I've already prepared a complete Swagger file for you for the final deployed website. I'll also include it in the video kit link down in the description. Once you get it from there, you can simply create a new JSON file, drag and drop it, and click continue. It's nothing big or complicated. It's just a proper documentation for the API you're about to develop in this video. Once you click continue, Refine will start creating your project, starting from analyzing your database, analyzing the relationships, table structures, planning the optimal UI, generating resources, and more. But already in a couple of seconds, we can see that Refine generated some diagrams. There's a lot of stuff here that we're gonna do later in the course. But even at this point, you should see that this is the application you're building. It has the subjects, classes, and very soon we're also gonna add users. So how exactly do we have this, and what is it that we're looking at? Well, Refine will analyze your entire backend and generate a clean diagram that shows just how your database schemas are structured and connected. As you can see, these are all the main tables used in this application, such as enrollments, classes, subjects, departments, and users. It doesn't include any authentication-related tables, but it clearly shows the core data of the app. Of course, in the video, we haven't yet added enrollments or classes, but don't worry, because we'll move on to the database design part 2 and design the database for the entire application in the next lesson. If everything is looking good, and it is on my end, you can just click Complete Setup. That'll start the project, and within less than a minute, you'll be navigated over to this view, where on the left, you'll be able to see exactly what's happening, alongside with the preview. Then there's the editor, the plan, resources, and all the secrets that you have within your code. So what is really happening here? Well, Refine will help us plan and build our internal tool. It'll first check the project configuration to figure out what's happening, and it can see that we have a classroom management system already configured with the resources, authentication, and roles, which it can figure out based off of our backend API. So now it's asking us what kind of an admin panel or dashboard would we like to build. In this case, we're going to go with something else, and then prompt it to achieve exactly what we did so far in the video. I mean, it took us a long time to build all of this manually, so let's see how fast we can recreate it with Refine. I'll say implement, only 2 pages for now. We need a dashboard page with a welcome message and a subjects page with a list of subjects. Filter by department, search by name, and complete pagination. No auth, at least not for now. And then click send. It's gonna think for a couple of seconds and create a plan for a simple dashboard and a subjects page. And it came up with a plan. Phase 1 will deliver a simple dashboard with a welcome message and a complete subjects list with everything we wanted. We can read through the plan in more details right here, and we can even collapse specific phases. It's pretty cool that it already knows what our backend is all about, subjects, classes, and departments, so it created upcoming phases where we can dive deeper into our application. But for now, we want to stick to phase 1 to replicate everything we developed up to this point in the course. Since phase 1 is looking good to me, let's go ahead and just click execute. Refine will now start executing the tasks one by one, and it'll mark the task as checked once it finishes executing. First, it's starting with creating the dashboard page with a welcome message. And I love it when AI tools just actually tell us what they're doing while they're doing it. Otherwise, we'll just have to wait a long time. But here, you can know exactly what it's working on. And you can also check the preview live on the right side. Or if you want to take a look at what it's doing with the code, you can also do that by heading over to Pages, Dashboard, and take a look. Editor is read-only because Refine is streaming the response as we're looking at it. And to be fully honest, I am absolutely amazed by, first of all, the UI that the Refine team was able to come up with, and even more so, the UX, user experience, specifically DevX, right, of developing Refine AI. It feels like the most seamless way to develop apps using AI today. There we go. So we can see that the preview is updating live. And if you head over to the editor, you'll see that now we'll have a new subjects page. If you remember correctly, this is the same thing that we were developing within our code, but it took us a bit longer to get to that point. On the other hand, Refine is already done with the subjects page. We have a nice looking table right here, and it looks like it already has the pagination, and it handled the filtering a bit differently. And I didn't think that was going to be possible, but I actually prefer what Refine did. You can just click on the department right here and filter it with even more options by directly choosing filters right here. This is great. It's now going to proceed with adding the search to this table. As before, the app is fully functional, and here you can also change the theme of the application. Looks like search is almost done. It added the UI component, but I think it's adding the functionality as we speak. So maybe we can search for something like intro. Oh, would you look at that? It didn't mark it as finished yet, but it already works. That's great. Were you keeping track of the time? I mean, I probably should have, because learning the entire PERN stack crash course and implementing everything up to the subjects page took us, around 3-4 hours? It's absolutely crazy that Refine just implemented hours of work in, less than 5 minutes? And what makes it even more impressive is that Refine didn't just generate code quickly. It generated the code that is clean and well-structured. I mean, if you open up the editor view, they're not hiding anything here, you can see that this structure looks almost identical to the code that we write. And this is something that many other AI tools still struggle to do properly. And that makes Refine stand out even more. So it has the subjects, it has the dashboard, the list, the tables. The utils are even in its own file. Everything is structured in a super clean way, exactly how I would write it myself. It's a bit weird that the search is working here, but it's still loading. So let me just reload the page. Oh, it looks like that was needed just to make sure that this checkmark gets filled in. I reported this to Refine and they're already fixing it. So by the time you're watching this video, it's possible that you won't have to reload at all. And with that in mind, the pagination has been implemented as well. This marks the phase 1, or in other words, everything that we implemented so far within our project: the classroom management portal with a clean dashboard page, a subjects list page with a table displaying the name and everything, filters for the departments, the search, and then pagination functionality. So does this mean that your learning efforts were wasted? Well, absolutely not. What it really means is that you first invest time in learning things properly, just like you did now, and then use AI to speed up your work. When something breaks or when AI gets confused, you know exactly where the problem is and how to fix it. Because of those 3 hours that you spent learning, this is exactly how AI will shape the way you learn and build your career. And you experience that today. Now let's get back to coding and dive deeper into learning even more concepts of the PERN stack. And then later in the course, we'll come back to Refine and see whether it can develop all of the other functionalities of our class management dashboard. In this lesson, we'll develop a way to submit a class to a database with all the needed information, like the class name, description, code, teachers, and even a class banner. All of it using React hook form and Zod. So create a new route component right here within Classroom Frontend under Source, pages, and create a new folder right within it called classes, and create a new file called list.tsx, which will render a list of all the classes. You can run RAFCE to quickly spin it up, and it'll work in a similar way as with listing the subjects. Then we can create a new route component under classes, but this time it'll be create.tsx, and you can also run RAFCE. This is going to be responsible for rendering a form through which we'll create a new class. Now we need to define the class routes and use these components within app.tsx. So right here, where we have the resources, dashboard, and subjects, now we will also have classes. So I will duplicate the subjects right below, and I will rename all the instances to classes, as well as a label of classes with an icon of graduation cap. There we go. So now we have it here, and we'll also add it as a new route by duplicating the subjects. And this route will be for classes. It'll render the classes list, so we can import it right here. And there's going to be the classes create. Both of these will be coming from the pages we just created, so we have to import them properly at the top. Similar to what we have done with the subjects list and subjects create, now we can import classes list and classes create coming from classes list and classes create. Perfect. Now, if you head back over to localhost 5173, check out classes right here on the sidebar, and there's a list. If you modify the URL to go to 5173 classes create, you'll be navigated to the create page. Stay on that page, and later on we'll add a button on the class list page that takes us to the creation page. Now, within source lib, within it, create a new file called schema.ts. Within the schema, we can define a Zod schema to validate form inputs and make sure that the user is submitting the right form. So export const a new faculty schema, which is going to be equal to z.object, and the faculty will have a name of a type z.string. Now, z, of course, is coming from Zod, so make sure to import it. You can say import asterisk as z from Zod, and then .min, it'll have a minimum of 2 characters. If you want, you can also provide an additional message if that condition is not met, such as name must be at least 2 characters. And then we can continue adding fields, such as the email, which is going to be z.string.email. Then we'll also have a role, and this is going to be an enum, which means one of the predefined options, maybe like an admin or a teacher or a student. Then we'll have a department, which is going to be of a type string, not deparation, but department. After that, we'll also have an image of a type z.string, and this one will be optional. And finally, an image CLD, Cloudinary, pub ID, as in where it'll be published. And this will also be optional, the same way that the image is. Now, we'll also have a couple more schemas that we'll use throughout this application for subjects, schedules, classes, and so on. Just so we don't have to write them by hand, I'll provide them to you within the video kit link down in the description, so simply copy it and paste it here. You'll notice that we have the schema for enrollments, for the classes, schedules, subjects, and the faculty schema we just created. And now we're ready to develop the form that'll allow us to create classes. Since we're working on the front end, I can bring back the browser so we can see the changes that we're making live. And let's start with JSX. I'll wrap it in a create view. This is a special component coming from Refine with a class name set to class-view. Within it, we'll render breadcrumbs coming from Refine UI breadcrumb, just so we know where we are. An H1 that'll have a class name set to page-title, and it'll say create a class. Below it, I'll render a div that'll have a class name set to intro-row, and within it a p tag that'll say provide the required information below to add a class. I mean, it makes sense, right? Then I'll render a button. This one will be coming from components UI button. On click, we simply want to go back. So I'll render a callback function and I'll call the back method. But for that to work, we have to use the use back functionality or use back hook coming from refine dev core. To initialize it, you can just say back is equal to use back, and then we can call it within this function. If you're calling it without any params, then you can just define it like this without using a callback function. And this button will just say go back. So if you save it, you can see it. And then if you go from, for example, classes to create, then you'll be able to go back to the page you came from. Of course, this is supposed to say back, not use back. We'll test it out later on. And I don't really like this primary color. So what do you say that we change it one more time? You can head over to tweak CN. And this time, let's go with, let me click through it until I find something that I like. Let's go with Vercel. Why not? It's very plain, but it'll do for now. I'll expand it a bit, take the code, and we can head over into our app.css, and I'll replace the last three, root, dark, and theme inline, and we get new ones right here. Within a matter of seconds, we have a new theme, which I definitely prefer. Now we can head below this div that's wrapping the button and create a separator coming from components UI separator. Below it, another div that'll have a class name set to margin y of 4, my4, flex, and items-center. And within it, we want to render a new card component. Not a car, but a card. This card will be coming from UI card. It'll have a class name set to class-form-card, and within it, we'll render a card header that'll have a class name set to relative with a z index of 10, and within it, we'll render a card title that'll say the text of fill out the form, and it'll have a class name set to text-2xl, padding bottom of 0, and font-bold. Below the card title and the card header, we can render another separator. And below the separator, render the card content that'll have a class name set to margin top of 7. This is how it looks like 100% zoomed in, but looks like I was zoomed in a bit more. And right within it, we can render a form. This is going to be a classic React hook form. So what do you say that we simply find it within ShatCN by searching for ShatCN, do a Command K, and search for a form. It'll simply say that forms are tricky, but they're one of the most common things you'll build within a web application. So thankfully here, they provide us with an anatomy of a form and a complete example. So let's go ahead and follow the example that they provide because we are using React hook form here. So first things first, we have to make this component rendered on the client side. Oh no, I forgot. We are working with React, so this is going to work right off the bat. We just need to import Z from Zod and then define a form schema, which in this case we have already defined in a special file. Then we have to define the form itself by importing the Zod resolver and use form coming from React hook form. So get those two. Then define the form right at the top of our component. Let's make sure that you properly copy it. Const form is equal to use form. I'll remove the types from here. And specifically, we need to define the resolver that is resolving in a class schema. We have created it before, so you just need to import it. And then we can define the default values. In this case, it'll just have a status of active. And we'll also provide a special prop of refine core props, which will be resource of classes, and an action of create. This will let Refi know exactly what we want to do with that form, and it'll handle the rest. Then we can define an onSubmit function. So let's define it right here below. And it looks like our resolver is complaining a bit. We'll look into that very soon. For now, we can define our onSubmit. That's going to be const onSubmit is equal to an arrow function. Let's also import Zod. That's going to be import everything as Z from Zod. And the type of schema is going to be class schema, coming from libschema.ts. Then we need to open up the function block, and for now we can console log the values. I'll also apply a try and catch block. Within catch, we will simply console log the error by saying console log. This error is coming from error creating new classes. And here we can just console log the values. Once we have that, we can bring in all the imports needed to create a form. I'll bring them right here. A button we already have, and we can delete the form that we imported before. It's going to be coming from components UI form. And then finally, we can copy that form and use it right here within JSX. It's form where we spread out the form information. Then we have an onSubmit that calls handle submit with the onSubmit function, a class name of space-y-5. As a matter of fact, you can immediately see this demo form that we just imported, but we'll modify it a bit by creating a new div right here within this form with a class name set to space-y-3. And within it, I'll render a label coming from components UI label. And within it, we'll say banner image with a span that's going to say asterisk, which means that it is necessary, mandatory, with a class name of text-orange-600. There we go. So banner image is needed. And then below it, I'll render a p tag that'll say upload image widget. Very soon, we'll add an upload image widget coming directly from Cloudinary, my personal choice for asset management when developing any kind of applications. Now, below this div, we can render our first form field that'll render the control. This control will be coming from the form. So right above the onSubmit, we can destructure the handle submit, the form state, specifically the is submitting state from it, as well as the control. And this is going to be coming from the form like this. So now when you say form.handle submit, it's just enough to say handle submit without specifying the form. And same thing here, we're just passing the control. We can give it a name of name. And then we're rendering a form item with a label of class name. And again, if you want to, you can add the same span element that we created here. That signifies that it is required. The form control will remain an input with a placeholder of something like introduction to biology. That's a demo name for a class, like section A. And then in this case, we won't be needing the form description, but rather just leave the form message and call it a day. So now we have the placeholder for the banner image, which we're going to upload soon, and the first input for the class name. Below this input, we can render a div that'll have a class name set to grid. On small devices, grid-calls-2 with a gap of 4, and we can start adding more inputs right within it. So I'll start by duplicating this form field and pasting it within this new div that we just created. This div will have a name of subject ID. It'll render the form item that'll say subject. It'll also be required. And instead of rendering an input, we want to render a select component within form control. So simply render a select coming from components UI select with an on value change equal to a callback function where we accept the value, and then we call the field .onChange and pass in the value, but first we convert it into a number because this is going to be for the ID. And then we can define the value itself also within the select by making it equal to field.value.toString so we can properly display it. Within the select, we can render a form control. So actually form control is supposed to go within the select, and then we'll render a select trigger, how we'll open the select coming from components with a class name set to w-full. There we go. So you can click it in the full width. And then finally a select value right within it. Damn, we are indented all the way to the right side of the screen. We're losing space. So I'll do a select value right here coming from components UI select. That'll be self-closing, and it'll have a placeholder equal to select subject. There we go. And finally, now we have to map over the example subjects that we can go over. So let's go ahead and create some dummy data for the subjects and the teachers. Later on, we'll fetch real values from the backend in the upcoming lessons, but for now, we can generate some fake ones. We'll do it right here below the onSubmit, and we can actually ask Journey to generate it for us. I'll say something like create 2 arrays, one for teachers, the other for subjects. Each one can have a couple of objects. Teachers only need an ID and a name, and subjects need an ID, which is a number, a name, and a code, which is same as name, but all uppercased and shortened. I think this should be enough for Journey to generate it, and it should be able to do so within seconds. It wants to take a look at this file. I mean, I didn't really tell it to do it in this file, so it'll most likely create a new mock data file, but then it should import it here as we want to use it here. There we go. It's trying to see whether data points like these already exist, so it does it properly. But in this case, we really don't want it to be anything special. There we go. It looks like it added them directly within the constants. So that is under constants, index.ts. And there we go. We have teachers and subjects. For now, we can just copy this and keep it within the same component directly below the form, because later on we'll remove it anyway. So I'll simply collapse it. It needs to look something like this. And then we'll do the same thing for the teachers. Perfect. And now, directly within the select, we can map over those subjects. But that's going to be happening below the form control within select content. So make sure to import it. And within it, map over subjects by saying subjects.map, where you get each individual subject. And for each one, return a select item component that's going to have a value of subject.id.toString and a key. We have to have a key since we're mapping over it of subject.id. And you can open up the component right here. And within it, we can render subject.name as well as in parentheses, the subject.code. That's going to look something like this. When you click on it, you'll see mathematics, math, computer science, CS, physics, and chemistry with their names and codes. Okay, now let's head a bit below. We're going to go below this form field all the way here, and we will create a new form field below. It's also going to be a select. So I'll go ahead and copy this entire select form field right here, and I will paste it right below, still within the same div. But this time, instead of subject IDs, it's going to be talking about the teachers. So it's going to be a teacher ID. It's going to say teacher right here. Then it'll say select a teacher. And under select control, we will simply map over the teachers. There we go. And we can render just a teacher name. So that's going to be teachers.map, where we get each individual teacher. And we will make all of this teacher.id without rendering its code. So now you can see different teachers. If you expand this a bit, you'll notice that it'll look much better on larger devices. Like even on a smaller one, if I'm not super zoomed in, like I am right here, the two of them are going to fit in a single row. Now, there are a couple more inputs that we need to write, but as you can see, this is getting pretty overwhelming as we have went all the way to the end of the indentation. Maybe my code is a bit too large, or at least the font size is. So instead of writing it all by hand, I'll provide the other form fields, as it's mostly just repeating stuff, in the video kit link down in the description. So you can delete the entire component or the entire file and override the one which you can copy. Once you paste it, you'll notice that we will have added a couple of additional form fields, which will result in a page that looks something like this. We have a form where soon enough we'll be able to upload images as well to it, but for now we can enter a class name. We can choose a subject related to that class, select a teacher, a capacity for the class, as well as the status of the class and a description. And if you miss filling out some important fields like the class name or selecting a teacher, and you tried submitting before that, you'll notice that our Zod validation is working and it's giving us errors on all of these fields. Now, in the next lesson, we'll implement Cloudinary to allow users to upload images to the cloud and store them so that we can later on pass them into the backend and store them into our own database while not taking any space from it, as they'll be stored in Cloudinary and they'll just give us the optimized versions of the files that our users upload. So let's do that next. Content is moving faster than ever. And if you're still manually cropping videos that your users upload or worry about the image sizes of the uploads, you're losing customers. That's why for this production-ready build, I'll teach you how to use Cloudinary, the world's most powerful AI-driven image and video platform. Whether it's Adidas delivering global campaigns or AMC managing movie media, the biggest names in tech trust Cloudinary to automate their visual experiences. With a single line of code, you can transform, optimize, and deliver any asset to any device instantly. And what I like a lot are the content as code tools that let you instantly resize, crop, or add filters to images just by changing the link. So click the link down in the description and get started. Specifically for you watching this video, Cloudinary is offering 3 extra credits when you sign up. If you're signing up for the first time, you'll have to answer a couple of questions. In this case, we want to optimize the assets to improve website performance, and you'll be right in. We get some information on how we can start using Cloudinary, but don't worry, as I'll show you how to do it from scratch. So head over to Settings, API Keys, and first copy your cloud name right here at the top. Then head over to your .env, specifically within the frontend folder. You can add a comment for Cloudinary envs. And the first one will be called Vite Cloudinary Cloud Name. And you can make it this key you just copied. Next, we can head over to the upload part where you can create your first upload preset. You can enter the upload preset name, such as classroom_app. The signing mode can be set to signed, and I think we can leave most of the settings as they are. Then you'll be given the preset name. So if you head back, you can type Vite Cloudinary upload preset and make it equal to the one you just copied. Next, we'll use Cloudinary's upload widget, which is a plug-and-play solution that handles complex tasks like drag and drop and allows you to upload from different sources. To learn how to implement it, you can head over to the Cloudinary's documentation, specifically talking about the upload widget. It offers an interactive widget that enables your users to upload files from many different sources. This is how it looks like. And if you scroll down, you'll get a quick example. This is a script that we want to add over to our HTML file. So back within our application, find that index.html file. And right below this script for index.tsx, you can also add a script for Cloudinary. Then let's create a new component that's going to be right here in the components folder. And you can call it upload widget. So that's upload dash widget dot tsx. Make sure to spell widget properly. Run rafce and import that widget within our form component. That's going to be right here within classes create, specifically where we have that image upload widget. But instead of this p tag, we will now render the upload widget. So if you head back over here, you'll now be able to see a text that says upload widget, and to it, we'll pass some additional fields to make it work. It'll be within a new form field, so remove this div and everything within it, and create a new form field, which is going to be a self-closing component, and it'll have a couple of props. It'll have a prop of control, which is going to have access to the control functionalities of React hook form, the name, such as banner URL, and the render field. As all of the other render fields, take in a callback function within which we will destructure the field that we're working with, and we can automatically return something. That something is going to be a form item. Let's properly close it. Within it, we'll render a form label that'll say banner image, and we also have to give it this span that'll make sure to say that it is mandatory. You can see that name right now says that there's an issue with the banner URL, but I think that's because to this form, we have provided default values of only status. But since there are more, it's not going to recognize them. So if we remove them, now you'll notice that it's actually not complaining about the banner URL name. Okay, now we have this form label, and it's saying banner image and rendering a span element. Then right below it, we'll render the form control, within which we'll render the upload widget component that we just created. To this upload widget, we'll need to provide a couple of props, such as a value of field.value. And if that exists, then we want to pass the URL set to field.value and a public ID set to the banner public ID or an empty string if it doesn't exist. And this banner public ID, we can define right here at the top. We can do it here. Const banner public ID is equal to form.watch banner CLD pub ID. So whenever we get it from Cloudinary, we can just add it right here. And then if we don't have the value, we can say null like this. Then we can add an onChange, and I'll turn this into a new function because it's going to be easier to handle, where we'll say set banner image, and we can call it right here. Const set banner image is equal to a function that accepts a file into it that we're about to upload. And within it, we can check if a file exists. In that case, we'll call the field .onChange and pass in the URL of that file. So file.url. Now, since we're calling it, we also have to pass the field as a parameter. So I'll pass it as the first parameter right here. We can modify that as we're calling it. So here onChange, the first parameter that we get access to, I believe, is a file. And then as the second one, we can pass the field. And then we can call this function with a file and the field. And now I noticed I changed the order here. So it's file and then field. So if a file exists, then we want to change the URL of the field and use the form to set a value. Here we're modifying the banner CLD pub ID with the file public ID, and we'll pass some additional options such as should validate, which I'll set to true, as well as should dirty, which I'll also set to true. Else, if a file doesn't exist, we can do that right here. We'll call the field.onChange and reset it to an empty string. And we'll again call the form.setValue, banner CLD pub ID. We'll set it to an empty string, again with the same options, should validate and should dirty, both set to true. Now, right below, for now, we can set these as of type any. And then below the form control, we can render the form message. That's going to be a self-closing component. And finally, we can render any errors if there are some. So I'll say errors.banner CLD pub ID if it exists, And if no, errors dot banner URL. In that case, we can render a p tag that'll display the error message of errors dot banner cld pub id dot message question mark dot to string. And we can also give it some kind of a class name set to text dash destructive as well as text dash small. Right now, we don't have access to any kind of form errors. This is the first time that we're introducing them. So we can get access to them right here through the form by destructuring it from the form state. Next to the is submitting state, we also get access to the errors. Now, you might have been wondering what the should validate and should dirty fields mean. Should validate simply reruns Zod validation after we submit it, and should dirty will mark the form as modified as soon as the image is uploaded. And now we can dive into the upload widget component and we can implement it. We'll first do the JSX part by giving this div a class name set to space-y-2. And now we have to figure out whether we're previewing the file that we're working with or we're showing the upload widget for the first time. For that, we'll need to manage a state. So I'll create a new use state snippet called preview and set preview at the start set to the value that we're passing through props. If a value exists, then we'll show it, else it'll default to null. Make sure to import use state from React, and let's get access to the props that we're passing into the upload widget component, such as the value, which if it doesn't exist, we'll set it to null, the onChange, as well as the disabled state, which I'll set to false by default. We'll also need access to a widget ref. So create a new widget ref by making it equal to use ref, and that's going to be of a type Cloudinary widget. At the start, set to null, so it can be either the widget or null. We'll use this to persist the widget across renders. We'll also need another ref, which is to handle the change, so we can avoid stale closures. So that's going to be const onChange ref is equal to use ref, and to it, we'll pass the onChange prop that we're passing in. Now, when it comes to these couple of states that we need to create, first is that preview state, which is going to be either the upload widget value or null. Then we'll also need the delete token. So that's going to be another use state snippet field, delete token, and set delete token, which is going to be either a string or null. At the start, set to null. This is used for client-side deletion, if somebody uploads something and then they want to delete it. We also need another state for is removing. So if we are removing something, we can change the UI. At the start, it'll be set to false. We'll also need a couple of functions, such as the function to open up the widget, which is going to be equal to a regular arrow function. And if it's not disabled, then we can simply run widget ref dot current question mark dot open, which will open it up. We'll also need another function called remove from Cloudinary, which is going to be an asynchronous function that'll remove the uploaded image from Cloudinary using the delete token. We'll implement that one soon. But for now, let's focus on the rest of the widget, or let's start implementing the widget in the first place. First, we'll check whether preview is turned on. If that is the case, then we will render a div. Let's also properly close it with a class name set to upload preview. Else, if we're not in the preview, if nothing has been uploaded yet, then we'll render a div that'll have a class name set to upload drop zone to allow users to upload in the first place. There we go. So since we don't have any uploads yet, let's start working on the second part of the ternary first, how the upload zone will look like. I'll also give it a role set to button, a tab index set to 0, and on click, we'll actually open the widget. So we can call this open widget function right here, but we also have to handle the on key down. When somebody presses, we want to figure out which event was it, and then if the event key is set to enter, in that case, we want to run event.prevent default, as well as open widget. So on enter, we can also open it. Let's make sure we're properly closing this right here. There we go. And now right within this div where we're showing the widget, we can render a new div with a class name set to upload-prompt, within which we'll render the upload cloud icon with a class name set to icon, and below it a div within which we'll render a p tag that'll say click to upload photo, and below it another p tag that'll say PNG, JPEG, up to 5 megabytes. There we go. This is looking better. Now let's make the widget actually open up. We'll do that by creating a new use effect that'll change whenever the value of the input changes. When a value changes, we'll set the preview to be equal to the new value. And if there is no value, we will set the delete token to null because there's nothing to delete. I'll also create another use effect. This one will have onChange within its dependency array. And its goal will be to always keep the latest onChange parameter right here. So onChangeRef.current is set to onChange. I'll collapse these so it's a bit easier to see. Then we'll need another use effect to initialize the Cloudinary widget for the client side. This one won't have anything in the dependency array, and it first needs to check if type of window is undefined. In that case, it's going to exit because this works only in the browser where there is a window object. We then want to create a subfunction called initialize widget, which is going to be equal to a function where we check if there is no window.cloudinary or if widget ref.current exists, then we will return false. This means that we exit if Cloudinary is not loaded or if a widget already exists. And now we want to create a new instance of the Cloudinary upload widget by saying widget ref.current is equal to window.cloudinary.create upload widget. Create upload widget accepts the settings where we actually set everything up by using our environment variables. So I'll say cloud name is set to Cloudinary_cloud_name. This is coming from our constants, but it's actually reading it directly from our envs. And this might be a good idea to do what CodeRabbit suggested, and that is to add the validations whether we actually have access to all of these envs. Because if we don't, then the application shouldn't work. So what I'll do is I'll copy this part, I'll open up Journey, and I'll tell it to add validations for these envs, and I'll paste them right here, just to get a meaningful error message in case we don't have something, so we're not wondering what's actually not working. Let's see if we can figure out what we want it to do. There we go, it analyzed it, and it looks like it updated it. It even created a helper function to do that. There we go, so let's check out the code. Get env var. If the var doesn't exist, then simply throw an error. Perfect. I wanted to hard code it, but it looks like it found a simpler solution. This is great. So now if you don't have access to a specific variable that needs to get used, in that case, you'll get an error in the console or somewhere that's going to say you're missing this environment variable. Okay, so Cloudinary cloud name, I believe we do have that. So if we head over to our .env, I think you got it from the Cloudinary settings. Yep, this is good. And now we can continue passing other parts. The next one is going to be the upload preset. That's going to be Cloudinary_upload_preset. Then we can say multiple set to false because we only allow a single file upload. We'll move the files over to the folder called uploads, and we can set the max file size to 5 and then 6 zeros. This is going to be 5 megabytes. So I'll say max file size. We can also do client allowed formats, and we're going to set that to PNG, JPEG, and we can also do this. We can also allow for WebP as it's more widely used nowadays. Finally, after the settings, we can provide the error and the result portion, which is the callback. So I'll say error and result. And here we can define what happens if there's an error. First of all, if there's no error and if result.event is triple equal to success. In that case, we want to handle the successful upload by getting access to the payload, which is going to be of a type upload widget value. We'll set the URL to be result.info.secure_URL, which is going to be the public image URL of that image, as well as the public ID, which is going to be result info public_ID. So we're extracting the required upload data. Then, once we have it, we can set the preview to be set to the payload we just created. And we can set the delete token coming from result.info.delete_token or null if it doesn't exist. This will allow us to delete the uploaded image. And finally, onChange_ref.current.payload. So we are modifying the onChange with the most recent payload. Finally, outside of these, we're going to simply return true because the upload is complete. Then, right below it, still within the use effect, check if initialize widget. This is the function that we just created, but it looks like I misspelled it. So I'll say initialize widget. Once called, we'll return true or false. If it returns false, then we will simply return exit out of this function because something went wrong. But if it's good, we're going to proceed with creating an interval ID, which means that we will poll until Cloudinary script finishes loading. So that's equal to window.setInterval. We're going to do it on a 500 millisecond delay. And if initialize widget, if it hasn't yet been initialized, then we will keep trying by saying window.clearInterval with the interval ID. Finally, we can return the cleanup function, window.clearInterval with interval ID. So when the component unmounts, we clean it up. And this is that use effect that deals with initializing our widget. If you reload the page, it looks like we have an empty screen. But if I open up inspect element and head over to console, take a look at this. Feed Cloudinary upload URL is missing. This is great. This makes sense, and now we can fix it. If you head back over to your envs and write vite Cloudinary upload URL, it'll be equal to https://api.cloudinary.com/v1_1, and then you'll need to enter your Cloudinary cloud name, which you have right here, and then /image/upload. Now, it looks like that the validation for our other environment variables that we're going to soon have in the future within our constants, that's going to be the vite API URL and so on, is throwing an error because we haven't yet created them, but they're coming in the future. And we can remove it like this. But then, of course, we'll have to add the import.meta.env in front of it. Then if you reload, you'll see the same thing will happen for a couple of other envs that we're going to implement soon. So you'll also have to fix this part so that the application is not breaking while we're not yet using them. There we go. If you fix these three, it should work. And if you click to upload photo, take a look at this. We get a mobile first widget, but if I open this up on full screen and click again, we'll get a larger widget that allows us to upload images either from our files by simply drag and dropping them, or through a web address, a camera, Google Drive, and even Unsplash. This is great. So let's go ahead and try to upload an image. If I head over to Unsplash, there we go. I'll search for, what do we have a class about? Let's say it's about computer science. So we can select maybe this open black laptop, and we can select the size and upload it. There we go. It's uploaded, and we can click done. Now, even if it uploaded correctly, we wouldn't yet be able to see it because right here, we haven't yet implemented anything for the upload preview. So let's do that next. First things first, within this div, I'll render a regular image tag that'll have a source of preview.url and an alt tag of uploaded file. We can't see it right now because it looks like the preview didn't get properly filled in. So before we continue creating the preview, we have to figure out what went wrong. There are no apparent errors in the console, But the error could be happening because the upload preset must be whitelisted for unsigned uploads. This is referring to one of the settings right here. If we head over to Settings, Upload, and the mode is set to Signed. So we have to edit it and set it to Unsigned and save. If you do this, retry it, you'll see that it's going to process the upload. And since we implemented this image right here, we can now actually see it. And you know what? In this case, I don't think we even have to implement the button to remove it. If somebody wants to reset it, they can just reload the screen. So for now, I'll remove this remove from Cloudinary thing, as well as remove everything that has to do with a delete token. There we go. Perfect. It's also being used in this use effect right here. So now we can once again try to upload. Let's go with biology this time. There we go. We can go with this leaf. We can select the size and upload. And there we go. We can see the preview right here. Now, the fact that we can see the preview is great. It doesn't only mean that we are uploading it locally, but it means the file is actually getting uploaded to Cloudinary servers. How can we know for sure? If you head over to Assets, Folders, Uploads, you'll be able to see the two images we just uploaded. And I mean, just take a look at the size, 370 kilobytes. That's great. So now that we know that file uploads are working, let's go ahead and test just how clean our upload library code actually is with CodeRabbit. We can do that by pushing the code over. So I will clear the terminal, check which branch I'm on by running git status. It looks like we're on main. And I'll create a new branch by running git checkout -b feet / Cloudinary image upload. And I'll run git add dot git commit -m implement upload widget and git push, after which we'll have to set the upstream. Now head over to GitHub. You can go to your own repos, specifically to the Classroom frontend. There you'll see a new pull request. So let's open it up. And let's give CodeRabbit some time to wake up. Oh, and it looks like its GPUs are ready. So hopefully it finds some bugs. In this lesson, we introduced a class management feature with Cloudinary image uploads. We added environment configuration, upload widget component, validation schemas, and corresponding UI pages for creating and listing classes. So let's see how clean the code is. It looks like we have a couple of suggestions, mostly about a very critical mistake that we've done, and that is pushing our env file to GitHub. So it's not only suggesting that we remove it from there, but that we also remove it from Git history by running git rm cached.env followed by git commit amend. Then create a new example file and regenerate Cloudinary credentials if these have been exposed. Since this is a tutorial course, I'm totally fine with these being leaked as they are not real keys, but this is such an important critical issue, and with CodeRabbit, we were able to immediately figure out that we leaked our own envs. Otherwise, it might take us days until we actually notice that this env file has been pushed over to GitHub. It's suggesting some other potential issues, such as missing error handling for potential failures. It also figured out a minor issue, which is that I added WebP into one of the supported formats, but I didn't actually mention it within the widget. So that's definitely an improvement that we can make. Other issues are primarily in constants, so we can remove the Cloudinary upload URL and so on. And let's see if we have some more important ones. Oh, I think this is a big one. Remember those warnings that we were getting over in our form, where it was saying that we cannot use some names or that it's not recognizing the schema? I mean, even if you head over into it right now by going to classes create, you'll see that it still complains about this resolver. And I wasn't entirely sure why, but thankfully CodeRabbit let me know. The use form is important from React hook form, but refine core props is a configuration option specific to refine dev React hook form. So we need to change the import from use form React hook form to use form from refine dev React hook form. I'm not even sure how the heck is CodeRabbit noticing all of these, but this is super useful. So if I head over to the import of the use form, which is going to be right here, I'm just going to modify it with the one copied over from here. And now the error should immediately be gone. Perfect. And our form should now know that it's accepting things like the onSubmit right here and the name of the banner URL and so on. Everything is coming directly from the form, and we have all the proper types. And finally, there's another one within our upload widget. It says that we have an incorrect onChange callback because the upload widget passes a single payload, not two. Oh yeah, I know what this is. This onChange was supposed to be done right here, but I extracted it into a new function right here, so it's easier to see. Still, I made a mistake in how it's getting called. We have to fix it by defining the onChange like this. Right now, we have the file and field right next to it, but it has to be just file that we get access to right here of a type any, but then to the function, we pass both the file and the field. And for now, we can set the types of these to any. Later on, we can make them more specific. This was another great catch. So let's go ahead and commit those changes by running git add dot, git commit -m, implement code rabbit, suggested fixes, and run git push. With that, we can now merge this pull request, knowing that our code is clean and safe, and we can confirm the merge. We can then check out back to the main branch and pull the latest changes that we just pushed. Wonderful. So far, you've done a great job setting up the subject schema and getting them to show up neatly on the UI. But now things are getting interesting. You've already built the Create New Classes page, but have you thought about what happens when you click the Create Class button? How is the backend supposed to process that request? Or more importantly, where is that data actually going live? To store these class details properly, you need a blueprint. So, do you have a database schema ready to handle things like banner images, teacher assignments, or student limits? Not yet. And that's exactly what we're going to tackle in this lesson. Before you can save a single class to a database, you need to define exactly how that data should be structured. Think back to the class structure that we already defined on the front end. That class form with an image upload. You've got the banner, the name, the subject ID, the teacher ID, and capacity. You did it all, but how does the backend actually make sense of that? You'll have to define all of those fields on a schema named class, a separate table. But your class can't live in isolation. A class belongs to one subject and has one teacher. So how do you link these two things together? For that, you'll need to arrange your relationships. So what does that mean? Well, there's subjects and teachers, but there's also students. How do they fit into the picture? And more importantly, how will you actually enroll them into a class? To solve that, you'll need another table called enrollments. This one will act as a bridge. And since one student can take many classes and one class can have many students, we'll have a many-to-many relationship in between them. Don't think of putting all of the enrollments within a class table itself. If you do that, you'll have to create a students array which will show a number of students assigned to a class. It works, but you'll lose on that relationship mapping. You'll have to make the n number of requests for n number of students listed in that array to get the user information. There is simply no relations, hard coding everywhere, which is a recipe for database failure. That's why you need a separate enrollments table, which will connect both the classes and students together. In this separate table, you'll also add a unique constraint to stop a student from enrolling in the same class twice. It's a little rule that keeps your database clean. And all of that sounds great, but where do these teachers and students actually come from? You don't have a table for them yet, do you? So before you assign a teacher or a student to a class, you'll need to know who's who. And this is where we set up authentication. We're going to follow the Better-Auth standards. It's basically the gold standard for modern applications. And why reinvent the wheel when you can use what the pros use, right? To make this work, you'll need 4 main pillars. So, Better-Auth requires the following tables to be present in the database. The types are in TypeScript format, so you can use these corresponding types in your database. First is the user table. This stores the basic information like name and email. But how do you tell an admin apart from a student? For that, we'll have to add a role field right here to define them. Then there is the session table. This tracks signed in devices. How will we know if a user is logged in on their phone versus their laptop? This table tracks these tokens and IP addresses for you. Then there's the accounts table. This is the how. Do they log in with a password or Google? This table connects the user to their chosen provider. And finally, there's the verification table. This is all about password resets or email links. Where do these temporary expiring actions live? You keep them separate here so they don't clutter up your main data. It's all here in the docs. You're going to define your schema exactly like this with a bit of customization to the user table to define their role as well as a Cloudinary ID for the image they'll upload as a profile photo. This is your overall foundation. But is this all your app will ever be? Probably not. You can always think about the future, but the beauty of this setup is that it's fully extensible. You can add additional tables such as schedules, attendance, assignments, anything you want to add as a feature to this application. But once you have the base, adding new features is just icing on the cake. You can grow as big as you want without breaking the core. So let's head back over to WebStorm and bring these schemas to code with a little twist. Since you already know what your table should look like, the fields, the names, the relationships, do you really want to spend the next 30 minutes typing it all out manually? Writing every line of code is so 2020. In today's AI world, there is a much faster way. Why do the grunt work yourself when you can just have an AI agent do it for you? That's why I prepared a short but powerful prompt that you can feed into your AI agent. In this case, I'll be using Journey. So head over in the video kit link down in the description, copy the prompt, and paste it right here. Just think about how much time you'll save by letting the AI generate your schema code in seconds. We'll put it to the test soon, but first, let's go through it together to make sure that we fully understand everything. This is also another great way to learn. The prompt says, study the Better-Auth documentation and then implement the correct Postgres drizzle schema. Keep the table structure outlined in a Better-Auth and only add 2 extra fields, role, which is going to be default to student with options such as student, teacher, and admin, and image CLD pub ID, which is going to be the Cloudinary profile photo. Then I give it a couple of requirements. Edit the Auth.ts file, create all of these different tables, following the Better-Auth documentation, add the fields that we told them to add, ensure the schema matches Better-Auth expectations, and use singular table names like user, sessions, account, and so on, not plural names. So let's give it a shot. It might ask you to run a couple of commands, which I'll allow. There we go. It said that it's confident with the implementation, and it'll do the final check of the file contents. Finally, it added new files, auth.ts. So let's go ahead and check it out together. It'll be right here in the backend part of the application under schema, auth.ts, and you'll be able to see the Better-Auth recommended tables for our authentication. It even nicely created a role enum with all the roles, the timestamps, the user information that we need, including the role and the image CLD pub ID for the profile photo. Then there's the session data, the account information, the verification, and even some relationships in between users, sessions, accounts, and so on. Everything we need for a fully functioning authentication. Just to be safe, if something is a bit different for you, I'll provide the final output of the auth.ts file below in the video kit down in the description, so you can also copy it and get the similar output. But with that said, let's also do a similar thing to generate database schemas for classes and enrollments. I'll start again, and I'll also give you access to another prompt within the video kit. This one will be about analyzing the existing drizzle schemas for departments and subjects and extending it for classes and enrollments. So let's go ahead and run it. And it is done. It added the drizzle ORM schema in our app, and it has been extended with classes and enrollments as requested. All the changes should be within the app.ts file. where now we have these new additions for enrollments, classes, and the relations in between them. And now go to our database, schema, index.ts, and also export the auth schema so Drizzle config is also aware of it. So export everything from auth. Now we need to generate SQL for newly created schemas by running a new command within our terminal. We'll keep the front end running, but we'll do it within this other one. Make sure to navigate over to Classroom Backend, and there run npm run db generate. You'll see so many new tables created, and then migrate these SQL definitions to your database so it knows what it has to do by running npm run db migrate. It'll apply all the migrations. If you want, you can head over to your Neon workspace to be able to see all of those tables in action. But for now, we'll just go ahead and push this over to GitHub so we can see just how well and how clean we, or in other words, AI, generated these database schemas for us. CodeRabbit's going to give them a check. So we can run a git status to figure out which branch we're on. We're on main, which is good. So we can check out to a new branch called feat database schemas number 2. This is going to be the second part. And we can then run git add dot git commit -m design database schemas and run a git push to the correct upstream origin. Perfect. Now back within a repo, we can open up a pull request. We've added 1,000 new lines of code across 6 different files. Most are just SQL migrations, but what matters most are the changes in the schema of our application, as well as in the schema for our authentication. And let's see what CodeRabbit has to say about it. This pull request introduces a comprehensive Postgres database schema using Drizzle, defining auth entities, user session account verifications that we went through, and these are gold standard by Better-Auth, and application domain entities such as classes and enrollments, with supporting enumerations for the role, class status, foreign key relationships, and indices. A schema grows with tables so fine, users, sessions, and classes align. And let's see which changes has it recommended. In this case, there's one change in our schema app.ts, which is great news for Journey because in this PR, we actually had fewer CodeRabbit recommendations than in the PRs that we ourselves wrote the code for. There's only one minor potential issue, which is a redundant unique constraint on a composite primary key. The unique enrollment student ID class ID unique is redundant because the primary key already enforces uniqueness. Okay, so this is not even a mistake, but we just have a redundant line of code. Amazing. This means that it's ready to be merged. We can head back over to the code, check out back to the main branch, and run git pull. Again, make sure that you're on the backend repo. Before you rush into building the next feature, whether that's creating classes, enrollments, or finishing authentication, we need to make sure that our app is actually production ready and not just vibe ready. It's all fun and games until vibe coding meets those crazy users or a botnet that's hitting our API with 10,000 requests a second. I've seen a few of these developers on X complaining about how their platform is down or why they suddenly have a $1,000 server bill to pay. Instead of actually fixing the problem, they just suspend the app because they have no clue what's actually happening under the hood. I mean, there's a reason people get CS degrees, right? Anyway, if you don't want your app to become another cautionary tale tweet, you need this. Real security. Because security isn't just nice to have. It's a core feature for any professional application. I mean, think about it. As you build more complex routes for things like creating classes, managing enrollments, you're opening up more doors. And if those doors aren't locked, your API is vulnerable for abuse, bot spam, and brute force attacks that can crash your server or inflate your costs. So to handle this, we need a security layer that protects both the frontend and the backend. And that's why in this course, I'll teach you how to use Arcjet. Arcjet is a security as code platform that lets you implement expert-level protection like bot detection, rate limiting, and email validation right inside your codebase. So instead of setting up complex infrastructure on your own or managing a separate firewall, you just import the SDK and define your rules. That's it. So in this lesson, we're going to start by securing our endpoints. We want to make sure that when we add new creation routes, they're protected from day one, so no one can abuse your API or script fake enrollments. So if you want to follow along and learn how to do this within all of your future projects, click the Arcjet link down in the description. It's the fastest way to make your app security aware without the headache of custom coding every single protection from scratch. Once you click the link down in the description and create your free account, you'll be able to create a new site that we'll call JSM Classroom and click Create. From here, you can grab the Arcjet key and put it within your .env file on the backend and say arcjet_key is equal to, and then I'll also add the Arcjet environment, which in this case will be set to development. Later on, we'll be able to switch this to production. Now, we want to follow the steps and install Arcjet SDK for Node.js. In this case, we can go with Node and Express, and you can continue to the docs. To get started, we can just install Arcjet. So let's copy this command and paste it within our terminal, within the backend folder. So make sure that you are within Classroom backend and run npmi add arcjet/node and add arcjet/inspect. Once that is done, we can follow the second step, and that is to set up our key. Thankfully, we have already done that. And then we are ready to add some rules. This configures Arcjet rules to protect your app from attacks, apply a rate limit, and prevents bots from accessing your app. We'll need to update our index with the following contents. Specifically, it's referring to this AJ instance right here. So let's simply copy the part from AJ all the way until the end. And we don't necessarily have to get this part because this is a minimal example that shows you how Arcjet works for one route. But rather, we'll take this part and then I'll show you how to make it extensible so you can use it across all of your routes. So once you copied it, head over to source and create a new folder right within the source folder that we'll call config. Within config, you can create a new file called arcjet.ts and paste what you just copied. Of course, we'll have to import a couple of things, such as Arcjet, coming from Arcjet node, and from that same place, but this time as named imports, we'll also get access to shield, detect bot, as well as a sliding window functionalities. Don't worry, as I'll explain all of these one by one. Also, let's add some validation for our API keys right at the top to make sure we actually have it. So I'll check if there is no process.env.arcjet_key and process.env.nodeenv is not equal to a test environment. In that case, we can throw a new error saying something like arcjet_key env is required. Perfect. And finally, we're creating a new instance of Arcjet by passing some additional options to it. We first pass the key, which is our Arcjet key coming from envs. I'm adding the exclamation mark so TypeScript knows that it is actually there. And then we start defining the rules. For the first rule, we have something known as a shield, which protects our app from the most common attacks. For example, SQL injection. And this is pretty crazy that you can just set it up like this and it just works. Applying this rule, Arcjet protects your application against most common attacks, including OWASP top 10. It does that by analyzing every request to your application to detect suspicious activity. And if you want to learn about what OWASP 10 is, you can see that these are the most common security concerns that actually get ranked every year. So they're constantly changing, but you don't have to worry about that because Arcjet just protects your applications automatically. Then there's the bot detection rule, which does as it sounds. It allows your application to detect bots. But sometimes bots are good, such as Google crawlers, crawling your website to be able to show it on Google, Bing, and so on. So you definitely want to allow some of these bots. And you can do that through this allow array. So you can say allow search engine and also allow link previews. Finally, in the demo example, Arcjet provided a token bucket rate limiting method. But in this case, we can use a different algorithm for rate limiting, such as a sliding window. We can also set the mode to live, set the interval to 2 seconds, which is going to refill it every 2 seconds, and then a max of 5 requests per interval. This is pretty self-explanatory, right? So we can make 5 independent requests during this specific interval of 2 seconds. Of course, you can make this much stricter by allowing 1 request every 2 seconds or allowing 1 request every 60 seconds, but that would just make your application unusable. So let's use this cautiously. Now, head over into source and create a new file called express.d.ts. This file will declare the user role for each request. It'll be set by our authentication middleware later on. You can do it by saying declare global namespace express with an interface of request, and you can notice that here we're defining the user role, which is going to be either admin, teacher, or student. And now let's define the security middleware so that we can call it before every important request. We can do that by heading over to source and creating a new folder called middleware. And within it, create a new file called security.ts because we're creating a middleware for security right now. Within it, we can create this new middleware by calling it security middleware. And it's going to be equal to a regular asynchronous function. As with every middleware, it has to accept 3 different parameters: the request and the response, as any typical request, as well as the next function. Depending on whether it rates the request as a thread or not, it can allow it to pass to the next request or not. We can also make this heavily typed by defining this as request, this as response, and finally next as next function. Perfect. And all 3 of these are coming from Express. So we can say import type, request, response, and next coming from Express. Then we can check if process.env.node.env is set to test. In that case, we can just skip the testing middleware. We don't have to do security analysis on a test environment. Then I'll open up a new try and catch block. In the catch, we will simply console log our error by saying console.error, Arcjet middleware error, and we can display it right here. And I'll also send a res.status of 500.json where we can render an error saying internal error alongside a message saying something went wrong with security middleware. Perfect. And now we can focus on the main part, which is going to be the try block. So what are we actually testing for? First, we can define the user role by saying const role of a type rate limit role is going to be equal to rec.user !role, or by default, it'll be set to guest. This rate limit role is going to be a TypeScript type that we can create within the source folder and create a new file called type.d.ts. And within it, we can create the type for the user roles, as well as the rate limit role, which can be either one of these 3 or just guest. Now, why are we creating this rate limit role in the first place? Well, that's because every request will pass through this authentication middleware, which will get user information and set user role. If no user, it'll set user to null. So for example, we can allow certain types of users, such as admins or teachers, to make more requests than students can make. So let's set up those limits. I'll say let limit of a type number to define it, and let message of a type string. Then we can create a new switch statement that's going to take a look at the role, and in case the role is set to admin, in that case, we can limit it to 20 and give a message such as admin request limit exceeded, and we can say 20 per minute. And then we go ahead and break it. And now we can duplicate this case a few times. We'll do it once more for teachers and students. So I'll say if case is teacher or if case is student. In that case, we can set the limit to 10, for example. Here it was supposed to be 20. And we can say user request limit exceeded, 10 per minute. Please wait. And here we can say something like slow down. We can also give a default. By default, we can set it to something like 5 with a message set to guest request limit exceeded, 5 per minute. So they're going to have the lowest limit. And then we can say, please sign up for higher limits. And then we can break it. We can now collapse this switch, and right below it, we can create a new Arcjet client by saying const client is equal to AJ. And this AJ is referring to the instance of Arcjet that we created in that previous configuration file. So go ahead and import it at the top by saying import AJ from /config/arcjet.ts, like this. Then we can say aj.withRule of sliding window, so the same one we used before. We can set the mode to be live. Then we can set the interval to be 1 minute. And then we can make the max number of requests per interval dynamic by setting it to the limit that depends on the user role. Finally, below it, we can also intercept the request by saying const arcjet request, which is going to be of a type arcjet node request. It'll have the headers set to rec.headers. It'll get the method of the request set to rec.method. It'll also get the URL, which is going to be rec.original URL or just rec.url if that one doesn't exist, as well as the socket, where we can define the remote address set to rec.socket.remote address, or if that doesn't exist, then rec.ip, or if that doesn't exist, then 0000, which is going to be the default. Now that we have the client and the Arcjet request, we can make a decision. So I'll say const decision is equal to await client.protect Arcjet request. So when I said we can make a decision, it's not really us. It's really Arcjet making it for us based on the parameters that we already defined for it. And now we can have different clauses depending on what the decision outcome is. So that's going to be if decision is denied, if that is the case, and if decision.reason.is bought, well, then we know what's happening, right? So we can return a new response.status of 403 with a JSON message of error set to forbidden, as well as a message set to automated requests are not allowed. This is incredibly powerful. When you're developing your API, it is highly likely that some bots are going to try to access it. And if we didn't have Arcjet, it would just be exposed to all of these bots, because implementing logic to prevent them on your own would add so much additional overhead to your code, and it just doesn't make sense to do on smaller APIs. So this way, you're getting enterprise-grade security even for maybe your small API, or who knows, maybe you implement it within your company later on. Now, there can be a couple of other decisions that are happening. So I'll paste it below a few more times. The second times it is denied, maybe the reason is that it is a shield protection. So if it is a shield protection, I'll change the message to request blocked by security policy. And for the third one, maybe it is the rate limit. So is rate limit. There, we will say very simply too many requests. And then we'll just render the message that is already coming from the top. So message is message like this. That message will be rendered right here, and it'll be completely dynamic depending on which option it is or which role the user is authenticated with. Finally, if we pass all of these blocks, this middleware finally served its purpose and can say, yes, please proceed. So we can call the next function. Don't forget to export this default security middleware so that we can actually use it within our server. Doing that is super simple, but before we use it, let's see, we have a warning right here saying that our configuration Arcjet has no default export. We can head over into this file, and it looks like I forgot to export it. So just at the bottom, you can say export default AJ to export this instance of Arcjet that we created. Now it's no longer complaining, and we can now head over into our server. That's going to be our index.ts. And right at the top of it, below express.json, we can add another middleware, app.use security middleware, which we can just type like this and automatically import coming from middleware security. Now, to test it out, we can check out to a new branch by running git checkout-b feat security with Arcjet, then run git add dot git commit-m implement security middleware, and run git push. Of course, we'll have to set the upstream to push it over to our remote repo. Once you do that, open it up and open up the pull request. And as usual, let's see how CodeRabbit will rate our security implementation. This PR adds rate limiting and bot detection security to an Express application using Arcjet. A new middleware enforces role-based rate limits, admin 20, teacher student 10, guests 5 per minute, performs bot detection with shield protection, and also responds with 403 for violations. And here is a new sequence diagram that we just get. When a client makes a request to our Express app, the Express app then talks with the security middleware, which extracts the user role, and also talks to Arcjet services to protect us. If bots are detected, it's going to deny it with a reason of bot. If it's a shield policy violation, it'll also deny it. Same thing for the rate limit. Otherwise, it's going to allow it and let it through to make a request. Otherwise, we're going to get an error. Let's take a look at the feedback that we got. Here we have one major issue, and that is to apply a refactor to pre-configure Arcjet clients by role instead of calling with rule on every request. Arcjet's best practices recommend creating a single client and calling with rule outside of the request handler. Currently, AJ with rule is invoked inside the middleware for every incoming request, so creating a new client instance every time. This adds unnecessary overhead. Instead, we can create augmented clients for each role at module level. Okay, this is interesting. And pretty cool to see that this is the first time that I've noticed the CodeRabbit not actually providing us with the final code we need, but it's giving this to us as a suggestion that we can implement on our own, or it gives us a prompt for an AI agent to execute. So feel free to feed this over into Journey and solve it. And another issue that CodeRabbit found is that we should use HTTP 429 for rate limiting instead of 403. 403 stands for forbidden, indicates that the client is not authorized, while 429 is the standard for rate limiting, as it literally means too many requests. So using the correct status code allows clients to implement proper retry logic with backoff. In this case, we get a proposed fix, and that is to return a 429 for rate limits. Okay, that was a nice catch. So if I head back over here into our security middleware, specifically where we're dealing with the too many requests, we want to simply make this 429. Now, it might also be a good idea to display these errors on the front-end side, so when the user is being rate limited, they know what's happening. We can do that right here if we head over to our data provider. That's going to be in source, providers, data, but on the front-end side. So very quickly, I'll head here under providers, data, and right at the top of our options, I'll create a new function that'll form the error object so we can then read it out on the front end. Const build HTTP error is equal to an asynchronous function where we get access to a response of a type response, and it returns a promise which results in an HTTP error. Within it, we can form some kind of a message, which by default can be set to request failed. But then we'll open up a try and catch block. Within the catch, we'll simply ignore the errors and return the default message. which is going to be request failed. But in the try, we can get access to the payload by awaiting response.json as message string. So if we have access to it, if it exists, if payload $.message exists, then we want to update the message to be equal to the payload message. And finally, at the end, we can return an object containing the message and the status code that's going to be response.status. So now that we have this build HTTP error, we can use it when we map the responses. So right here under map responses, right at the top, I can say if no response.OK, we can then throw await build HTTP error and pass in the response that we got. I'll do the same thing right here for get total count. This way, if you now test rate limiting by reloading the page aggressively a couple of times, you'll see an error in a toast while the table shows no data. So just reload, it'll continue loading to try to fetch it, and then you'll see a status code of 429, guest request limit exceeded, 5 per minute, please sign up for higher limits. Wonderful. We now connected Arcjet with our backend and with the frontend too. Now, this code was over on our frontend side, but let's still get it pushed by switching over to cd classroom frontend, running git status. We are on main, git add dot git commit -m, add toast for rate limiting, and git push. And I believe our backend PR is ready to be merged. With this PR merged, you have successfully implemented enterprise-level security with Arcjet to our full-stack application. Congrats. Oh, and just so I don't forget, if you head over to your Arcjet dashboard, you'll now be able to see your project is active, and under requests, you can filter them and see exactly what went wrong and why. We tested it once by making a curl request, and you can see here that it was blocked because it got recognized as a bot. So now you can dive deeper into this bot and see exactly which bot it was, or maybe who tried to hack you, by getting access to some additional information. In this case, it was denied because it was a regular curl request. You can also check out our other rate limits right here, and this one is also pretty clear. The rate limit happened because we tried to make too many requests within a specified amount of time. But you can also get more information about the full request. Arcjet also allows you to add remote rules, which are great for just-in-time attack protection without having to redeploy the code. You can add the rules right here. Then there's the analytics, so you can see how many requests were allowed, which were good, and how many were denied. In this case, of course, since we were just testing it with aggressively reloading the page, more actually got denied, but you can track all of that here. And then finally, you have some more SDK configuration. Perfect. In this lesson, we'll finally implement the authentication system you've been waiting for. This is needed as classes can be created without a teacher, and the teacher is basically just a user. So authentication has to come first and then other features of the app. You can head over to Better-Auth documentation under Get Started and Installation, and we can follow the process to get it installed on the front end. Let's start by first installing Better-Auth. I'll actually put this side by side so we can see it a bit better. Open up my terminal. And we have to make sure that we're within our backend repo. So do a cd ... cd classroom backend. And then run npm install Better-Auth if you are located within the backend folder. The second step is to set up environment variables. First is the secret key, and they provide this convenient button to generate a secret, and then you can copy it alongside with your secret. Head over to your backend env file, and right below Arcjet, we can also provide Better-Auth, where you can paste this env you just copied. You'll also need to make sure that you have your frontend URL right here. I'll call this application and put it right above the Better-Auth envs. And at the top, we have the database env. Perfect. The package got installed, so we are ready to proceed to step number 3, and that is to create a Better-Auth instance in one of these locations. In this case, we'll do it within the lib folder. So you simply can copy this part, head over within source, and create a new folder then called lib. And within lib, create a new file called auth.ts, where you can paste this instance of Better-Auth. Then the next step is to configure the Postgres database in the same file. So right here, you can select Postgres and copy this file right here and simply paste it. You'll notice that we import Better-Auth, we import pool from PG, and create a new database pool right here. But the next step says, if you prefer to use an ORM, you can also use one of the built-in adapters. So that's exactly what we're going to do. We're going to go with Postgres drizzle. So you can actually override this one. Still, make sure to fix this import of our drizzle instance by saying /db, as that's where it's coming from. Perfect. In this case, we don't have to create any database tables as we have already done that before, but the only thing we need to do is set up only email and password authentication method within this auth file. So below database, I'll say email and password, and I'll set this enabled to true. Now, if you continue scrolling down, here you can see different setup methods, and then comes step number 7, mount handler. To handle API requests, you need to set up a route handler on your server. So create a new file or route in your framework's designed catch-all route handler. This route should handle requests for the path, API, auth, anything, unless you've configured a different base path. Here, make sure to increase the size of your browser, as you'll be able to see new options pop up right here, and definitely make sure to choose Express. Here, you'll see that Express.js v5 introduced breaking changes to route path matching by switching to path2 regex version 6. Wildcard routes like asterisk should now be written using the new named syntax, any, to properly capture all patterns. As a result, the implementation should look like this. So go ahead and copy this line of code, and they give you an example right here below. So let me show you how to do it. Head over within your server where we have all of the other middleware. Head below our course. And here you can say app.all API auth, and then you can use what they provided here, asterisk any. But if you dive deeper into the docs, when it comes to the migration, if you scroll down a bit, you'll be able to see that part where they mention the word splat. The wildcard must have a name matching the behavior of parameters. And specifically, splat matches any path without the root path. So that's exactly what we're going to use. Like this, /splat. And this is also mentioned within Better-Auth documentation. If you scroll down and search for splat, to enable Better-Auth to handle requests, we need to mount the handler to the API route, create a catch-all route in case of Express.js v4 or API auth splat in case of Express.js v5, do this. Okay, makes sense. Basically, the difference is that before you had to do this, now you had to do this. A bit weird, but hey, it is what it is. Then we have this toNode handler, which we can import coming from Better-Auth node, and then we have to pass the instance of auth. So you can simply import this coming from lib.auth, the one we just created. We've already configured course, so we're good there. This is the minimal setup needed for Better-Auth. It's that simple and easy, but we have to configure it a bit further, like mentioning these two custom fields that we have added in the user table, role and Cloudinary ID. So Better-Auth can refer to auth tables and add users. To do that, we can head back over to auth for just a second and configure it further by adding a secret right here, saying process.env.better-auth secret and adding an exclamation mark because we know it exists. Then we can add trusted origins, process.env.frontend URL, and then we can go a bit down and specify the custom fields that we have added to the user object. So I'll say additional fields. It's going to be role of a type string. They'll also have a required field set to true, a default value set to student, as well as input set to true, which allows the role to be set during registration. And I will also duplicate this below and rename it for image CLD pub ID. This is for the profile photo, type string, required false. Not everybody has to update it. No default value, and the input will be set to true. This allows it to be set during registration. And we're all set. With the path config that we implemented right here, any request matching that path will be handled by Better-Auth for us, and it'll authenticate users on our behalf. We don't have to write any JWTs, tokens, or handle sessions and all that. Better-Auth will do it. You can see an example of specific requests that we can make that'll automatically be handled by Better-Auth right here. Under usage, when you try to sign up, you can see how this request will look like on the client side. We can make a request to authclient.signup using a specific email. And then our backend will read this and will be able to authenticate the user. We can actually test this out by copying this object right here, or you can write it by hand with me, and opening up HTTP or any other API client of your choice. You can make a request to localhost 8000 /API /auth /sign-up /email, and you can pass an additional JSON body. So you can enter the text. It'll contain a name of something like teacher Tom. We can remove these comments right here. It'll also contain an email, which can be something like tom@teacher.com. That's a pretty cool email to have, right? Then we can enter a password like password1234. Make sure this is in double quoted strings. And finally, we don't need an image as it is optional, and so is the callback URL. We could provide the role though. So right here, if you add a role, that's going to be set to teacher. Perfect. Now, if you try making a request, you'll get this weird error saying something about localhost 5173 for allow control access origin, but in general, you're just getting a 500. And this is not super useful. What is useful, on the other hand, is the error that you're getting within your backend terminal. It says Better-Auth, Jizzle, the model user, was not found in the schema object. Please pass the schema directly to adapter options. That's pretty clear, right? We have to head over to the auth, and right here below the database, or still within the database, we have to provide a schema. And this schema has to be imported right here. Import everything as schema coming from /db/schema/auth. And that way, it'll know that these users exist. So if we head back over here and retry it, you'll get a transaction in progress. And would you look at that? We got a 200. The user was created successfully. Teacher Tom is now the first teacher in our classroom dashboard. It has all the necessary fields such as created at, updated at, and the role of the teacher. We can now use this token value in setCookie to sign in using API auth sign-in email route, but more on that later. For now, the session has been created and cookie is set. If you head over to your NeonDB console under tables and under users, you'll be able to see teacher Tom successfully got added into our database thanks to Better-Auth. You can play around and make requests to other routes provided to us by Better-Auth to try to sign in, sign out, create a new account, and so on. Perfect. We didn't really add a lot of code here. Mostly it was just Better-Auth setup. So for now, let's just push it. I think we forgot to switch back to the main branch after we implemented Arcjet. So in this case, you can just run git add git commit -m and then say implement Better-Auth. And then back on GitHub, you'll have to open up another PR on the same branch and then merge it to main. Same what we have been doing so far. After you do it, you can run git checkout main and then git pull. That way you'll have the latest code on the main branch. And with that, our auth on the backend side is now done, which means that soon enough, our users are going to be able to be more than users. students, teachers, and more, which is going to enable additional functionalities within our application, such as joining departments, classes, creating subjects, and more. Now, before we add more features to this application, by utilizing the powers of authentication, allowing teachers to create new subjects and students to enroll them, let me teach you how you can monitor your application's performance. Your backend application is running fine. Users are signing up, APIs are responding, and everything seems okay. But as soon as you've got some traffic, you get more users and they do things in a way you don't initially imagine, and your application is crashed. Plus, you've got a little to none information as you don't know what the heck the user just did. This is where you realize that building an application is only half the job. Monitoring it in production is the other half. Check any industry projects and you'll never see it without monitoring, except for the vibe-coded SaaS apps, but they're not really industry projects anyway. So what I'm trying to say here is that as much as building a proper backend is essential, so is the ability to monitor it. But many devs think that monitoring simply means checking the uptime status. Is the app up or down? But modern backend systems need much more, like performance visibility, error tracking, dependency monitoring, resource usage, code level insights, and more, which is where application monitoring platforms come in. And one such platform is Site 24/7 that I'll teach you how to implement in this course. It's a full stack monitoring platform that helps you monitor websites, servers, cloud infrastructure, APIs, and most importantly for us, applications. Instead of using multiple tools for logs, performance, errors, infrastructure, Site 24/7 brings everything together in one place. The link is down in the description, so you can go ahead and open it up and set up your account. And today, for this backend project, we'll use their APM feature. APM stands for Application Performance Monitoring, and it helps you understand how your application behaves in real time, how requests flow through your backend, where time is spent inside your code, why errors happen, and why our dependencies are slow. Basically, APM tells you what's happening inside your backend while it's running. With APM integrated, you can track every API request, check response times of each route, see slow database queries, examine external API delays, find errors and exceptions, get info on CPU and memory usage, and understand event loop delays happening due to your code. It's a pretty useful tool to track your backend inside out. You might feel the UI of Site 24/7 a bit old-fashioned, but what they have to offer is pretty serious. So now let's go ahead and implement APM insights in our application. To set it up, click the special Site 24/7 link down in the description and create your account. Once you verify your account, you should be able to see a dashboard that looks something like this. We'll get back to it soon. But for now, head over to your backend application, specifically within the terminal, and run npm i apm insight --save. This is the package that'll help us monitor our application's performance. While it's installing, create a new file in the root directory of your backend and call it apm insight node.json. Then, if you head over to settings, make sure to scroll down vertically right here to admin, and then scroll down again to get to developer. Under developer, there's going to be the API. Specifically, we're looking for the device key. Here, you can show the device key, copy it, and then you can add it right here within this JSON file. That's going to be license key, and set it to the key you just copied. Then also choose the app name. This can be anything. In this case, we can set it to classroom-backend, and you can choose the port. In this case, we can make it run on port 10,000. Now we want to open up our backend app that's going to be within source index.ts, and we have to add the following lines at the top of the file before any import statements. Import agent API coming from APM insight, and then run agent API.config. this will configure the agent that will run our performance monitoring. As soon as you restart your application, so if you head over to Backend, stop it from running and then rerun it one more time by running npm run dev. And when you rerun the application, you'll be able to see a new folder created for us automatically that includes the APM insight data. Within it, we have some logs right here, and a new folder got created. Now we need to push these updates over to GitHub. So open up our terminal, make sure that you're within the backend repo, and run git status. Make sure that you're on the main branch. Looks like we are. Run git add dot git commit -m implement APM with site 24/7 and run git push. Now, for us to be able to monitor our application, we have to ship it over to production. Or in other words, we have to deploy it. I was looking for the simplest and cheapest way to deploy a backend application in 2026 and beyond, and Railway was the choice that came on top. Deploying an app over there is super simple. You just click deploy a new project, you choose GitHub repository, and you log in with GitHub. You agree to their terms of service, and that you will not deploy anything illegal, and you should be able to see your repo right here, Classroom Backend. Now, very soon, you'll be able to see that your backend deployment will have crashed. And that's totally expected. It's because we haven't yet set up the build commands, the start commands, nor added our backend environment variables. So first, click on that project that failed, and then head over to settings. Not the settings on top right, but the settings right here within the project. Then, right here, you'll see networking. Under networking, click generate domain. Choose the port 8080, and then click generate domain. Then copy the backend URL. Once you copy it, head over to your Classroom frontend under envs, and for now, let's temporarily paste it right here. This is gonna be our backend URL, but I'll add a note to be updated. We'll use this later on. Now, let's also update the custom build command. So if you scroll down, you'll be able to see build, and under custom build command right here, click add command, and then say npm install, and $& npm run build. And make sure to verify it by clicking this check mark right here. Then we'll also have to add the additional start command under the deploy section. So add it right here by running node.dist/index.js. And again, make sure to verify it right here. For the region, you can maybe choose one that is closest to you. Then from settings, let's head over into variables, and we'll have to add our own environment variables. So go to a raw editor, then go to our backend envs and copy all the environment variables from here, and then simply paste them right here and click update variables. They'll automatically get added. Then click deploy and wait for it to finish building. It'll apply all the changes and restart it right now. Perfect. You can pause the video while you're waiting for it to build, and I'll do the same on my end. And very quickly, you'll see a green online sign. Hopefully, if it went right on your end. Then you'll be able to click on your URL to open it up. And if you're hoping to see a deployed backend, well, we're not there yet. Looks like there's an issue, and that we can learn a bit more about that issue within our deploy logs. So simply head over to our application under logs, and you should be able to see an error that happened not that long ago. In this case, it looks like that it was not able to find a module, app.dist routes subjects, imported from app.dist index.js. Okay, this is because of ESM modules and the fact that they require complete file extensions. So you cannot just say routes subjects, you need to say routes subjects.js or whatever the file extension is, which means that we have to manually go over the files within our code base and modify the file extensions right here to match the real ones. So for example, for the subjects router and security middleware, you have to add a .js extension at the end. Why JS and not TS? Well, that's because Node never executes TypeScript. It only executes JavaScript files that exist at runtime. So we have done these two. Now moving over to subjects. Here we have the departments, DB schema, and the DB file. Let's see how this one is called. This one under DB is called DB index.js. So you have to be specific. Import ./DB / index.ts. Or in this case, JS, don't forget, because we have to make sure that Node.js can actually execute it. And then we have the schema also pointing to index.js. Then let's head over to the middleware where we have the config Arcjet. Let's see. Yep, that is just arcjet.js. After that, we have the lib auth, which also has the database. So that is / index.js. And for the second one, we need to point it over to auth.js. So this is not an index file. It is just auth.js like this. Then most importantly, within DB schema under the index, we have to point out to these two files, that is app.js and auth.js. And these don't have any local imports besides the schema app.js, which is pointing to auth. So that's going to be auth.js. And then that is it. If you added all the extensions, simply close all the files, make sure you don't have any errors, and then run git add dot, git commit -m, add file extensions, and then run git push. As soon as you do this, your build within Railway should restart, and within about a minute, you'll be able to see that the build has completed. But before you let it rebuild, I just figured I have a little issue right here, and that is that I set my port to 8080, which was the placeholder option right here for the backend, but ours is running on 8000. So go ahead and modify this custom port to 8000. And just like that, if you head to your deployed URL, you'll be able to see hello and welcome to the Classroom API. This means that if you now take this URL and type /API /subjects at the end of it, you should be able to see a JSON output right here. I have a Chrome extension that displays it in a nicer way. You can just Google for JSON viewer. But what matters most is that we actually get back our backend data within our browser, which means that it's successfully deployed to the internet. Now, if you head back over to Site 24/7, you'll see one monitor status that is set to up on your Classroom backend. You'll immediately be able to see a lot of different data points and information about your backend, such as the app deck score, which shows you how happy your users are, the average response times, request throughput, error count, exception count, and more. You'll be able to also see the average response times on a specific endpoint. The more we use application, the more data we'll get. You can also see all the transactions happening and even more data about each one of these transactions. All of this will help us spot performance issues early, understand why your app feels slow or unreliable, and fix problems before our users notice. Very soon, when we deploy the front-end part of the application as well, we will enable RUM, which will give us additional data points from the perspective of the browser, platform, geography, the internet service provider, and more. But to actually get some more data that we can actually work with, we need to finalize the work on our create a class form and actually allow teachers to submit a class. So let's do that next. Before we implement the class submission, let's go ahead and quickly change the theme of our application because it's so easy to do. Twitter seems like an interesting one. So I'll go ahead and take the code and just copy it. Then back within our frontend, specifically in source app.css, we can replace the last three parts and paste the new ones right here. Immediately, our app will get that Twitter feel. And you can also turn on the dark mode. Now, in this lesson, to be able to finalize the create class form, we'll need to create a get list for getting all the teachers so we can actually select them from the database and attach them to a class. We'll then also create another route to actually create the class. Since you've already learned how to create get routes to get the list of all the subjects, like what we have done right here, the same exact process will apply to any other get routes for users, classes, or anything. So instead of repeating the same process we did, it's better to get some help using AI. So go ahead and open up Journey, and in the video kit link down in the description, I'll give you the prompt that we can use. Basically, we're telling it to study the existing codebase, how we're implementing the get route for the subjects, and we want to do the same thing with the route for teachers. Refine is amazing with things like this because it has a very clearly defined structure. If you go to Pages, you'll be able to see that we have subjects, list, and it's pretty clear what we're doing. Now, to be able to get another page with a complete table and all the columns and everything, it would take a lot of manual writing. But if we can tell Journey to just do it for us, it'll be easy because both you and it now understand the structure of our application. So just go ahead and submit it. It immediately edited a new users.ts file, and it's asking us to run some terminal commands as well. There we go. It is done. It added users.ts and a change in the index file where it imported the users right here. This is done on the backend side of things because, like Refine, Express also follows a very clearly defined structure for fetching the data with optional search, filtering, and pagination. So let's go ahead and test it by making a request to localhost 8000 /API/users. If you do this and if you get back teacher Tom, congrats, it's working. And it took us, half a minute to implement it. And you can also use the same one, so localhost 8000, and then you can go to API users, but change the role to a student, like this. I don't think we'll have any in our database, so you should be able to see that it is empty. Now, back within our application, if you head over into source, routes, and then create a new file called classes.ts, we'll create a post request for submitting a class. You can do that by saying const router is equal to express.router, and then define a new post route that's going to point to a /, and it'll have an asynchronous request response function where you can open up a try and catch block. In the catch, we can simply console.error the actual error by saying something like post /classes error, and then we can show where it actually failed, alongside returning a res.status of 500 and a JSON message, including the error. So now don't forget to export this router by saying export default router so we can actually use it. But now let's implement the functionality of creating a new class. We can do that by first destructuring all of the important properties that we're passing from the frontend to the backend from our form. And we can do that by destructuring the data coming from request.body. So right here, you can destructure the name, the teacher ID, the subject ID, the capacity, description, status, the banner URL, and the banner CLD pub ID. Perfect. So now we can use them to create a class. You can do that by destructuring the created class, and that's going to be coming from a call to await db. Make sure to import it from index.ts. Don't forget that you actually have to provide a complete file extension. So that is db /index.ts like this, or we're using JS when Node actually executes these files. And then you simply want to say .insert into the classes table. Of course, you can import those classes, and these are going to be coming from /db /schema, but specifically, I think it's going to be schema /index.js. Perfect. So we're inserting into classes, and which values are we inserting? So we're inserting the values of, well, basically all the values coming from the rec body. So maybe instead of destructuring them, we can just spread them out. So I'll say rec.body. And we'll also attach a couple more, such as the invite code, which we can set to a random number. So math.random. We can then stringify it, so toString. Maybe it can have 36 characters, and we can take a substring of something like 2 to 9. So that's going to be the invite code for our application. we can also add the schedules of those classes, which can be set to an empty array. But of course, we have to provide the values in an object format to be able to spread this in the first place. And then you don't have to destructure any data at the top. Finally, you can say dot returning, and we can request that we get back the ID, which is going to be classes.id. Finally, you can check if there is no created class. In that case, we can throw an error, but else, if everything goes right, we can return a status of 201, means created, .json, where we set the data to a created class. That's it. This is the only thing it takes to create a post route. This is a basic version of creating a post route. Usually, you also have to parse your request using libraries like Zod. Then you'll have to make sure things exist properly, like that the subject ID already exists in the database. Same for the teachers. We'll, of course, pass those IDs from the front end, but you shouldn't just rely on them, because in future, somebody might expose your API endpoints and hackers or users might try to abuse it by sending the wrong subject teacher IDs. And if you let that happen, your database and frontend both will fail. We might get back this later on to fully secure it. But for now, let's use this class within our server. So that's going to be within index.ts. And right here, where we have subjects and users, we will also have app.use/API/classes. And then we will render the classes router, which we have to import at the top. That's going to be coming from data/routes classes.js, and I'll rename it to classes router. Perfect. Now let's switch back to the frontend repo, and first let's replace those dummy subjects and teachers with the real data coming in. Specifically, I'm talking to the drop-down fields within our create form. So those are going to be within source, pages, classes, create, and then here you'll be able to see that we have some fake subjects and teachers. We can remove both of these, and then we can manually fetch real ones. You can do that by saying const query, which you can rename as subjects query, is equal to use list coming from refine dev core. We can specify that this will return a subject, and then within it, we can define exactly what we want to get back, such as the resource of subjects with a pagination and a page size set to 100. This subject has to be imported from types. Once you do this, you can then duplicate this below to fetch the teachers as well. We'll rename this as teachers query. It's going to fetch the user type. So again, make sure to import this from types. Resource will be users, but we'll filter it a bit by applying a filters of a field role should be equal to, so I'll say operator EQ, the value of teacher. This is how you can very easily filter things with refine. Pagination can be set to 100. Finally, we'll need to access the subjects from the actual query by saying subjects is equal to subjects query (data) (data) or an empty array if they don't exist. And we'll also need to create a state whether they're loading. So subjects loading is going to be equal to subjects query dot is loading. And then we will need to duplicate this below to do the same thing for teachers. So teachers coming from the teachers query and teachers loading as well, coming from the teachers query loading like this. Once you do that, if you head over to the select field, we have it right here below. Select, there we go. This is the select for the subject ID. The only thing we'll have to do is apply a disabled state, and it'll be disabled while the subjects are loading. And we want to do the same thing for the teachers. So right here where we have the second select, we'll give it a disabled state, and we'll say teachers loading. Other than that, it should automatically map over the teachers that are now coming from the backend. So back within our application, if you reload, you were able to see that at the start, the field was disabled, same for the subjects, but now you can see teacher Tom and you can actually select it, which means that this data as well, subjects, data structures and signals are actually coming from the backend. We're fetching them, we're disabling the state of the input, and then once they're fetched, we can actually select it and create a class with the real data coming from the database. But now to bind the post-creation events like creating a class or an enrollment, we have to modify the data provider of Refine to tell it how to call APIs and what data it should expect. So head over into source, providers, data, and then let's create the create endpoint to our data provider. We can do it right here below the get list, and it'll be called create. This create will also have a get endpoint, which will simply return the resource that we pass into it. It'll have the build body params. That's going to be an asynchronous function that takes in the variables and it simply returns them. And finally, we'll need to map out the response by making it an asynchronous function. And as before, we get access to the JSON of a type create response coming from types by making it equal to response.json. And once we get it, we can simply return json.data or an empty array. So now we have enabled the create functionalities within our REST API data provider. Finally, back within our classes create, this is the page that we were on just now, we have to call the refines onFinish function to pass the values to the API and create a class. We can get access to that by directly taking it out from the form. Here we get refine core, and then from it, we get onFinish functionality. So when the form is finished, and then right here within onSubmit, the only thing you have to do is call await onFinish and pass in all the values. That's it. We can now give it a shot and test it by uploading a new image or simply finding one from Unsplash. Let's go with something like Python Foundations. So maybe we can find a Python. I was more so thinking about a Python programming language, but having something like this, I guess, works as well. Somebody might think it's a biology class, but it'll do. So I'll go ahead and upload it. And then we can enter a class. In this case, we can do something like Python Foundations. Subjects can be, we can set it to signals for now. Teacher Tom has to give Python lessons because he's the only teacher there, with a capacity of 30, a status of active, and a description. Well, you can type anything, something like intro to programming focused on Python syntax. And go ahead and click create class. Oh, you were able to see that it took some time to load. The loading was automatically there. We didn't have to add the spinners, and we automatically got re-navigated over to the classes list, even though we haven't implemented it yet, but it is there. So how do we know that it actually got created? Well, if you head over to our Neon console under tables, you'll be able to see under classes that there's a new class right here connected with a specific subject that has the ID of the subject. There's a teacher ID right here connecting it to the teacher. There's the invite code we created for it. There's the name, the banner that points directly to the Cloudinary uploads, a banner URL, and a description. Everything is here. You can also see relationships with different entities within our application. I mean, this is really starting to take shape as a real full stack PERN application. And I hope this connection between everything we're doing makes sense. So now that we have implemented it and we verify that it is working, don't forget to push all the changes to GitHub. You can check the status to make sure that you're in the main branch. We'll first push over the backend by running git add dot, git commit -m, implement fetch teachers, and create classes, and run git push. Then you can cd ... and cd into classroom frontend. Check the status as well. It's going to be set to origin main, and just run git add dot, git commit -m, finalize, create classes form, and run git push. Wonderful. Not that long ago, we implemented APM Insights with Site24/7 to check how our backend performs. So far, our ApeDeck score is good, but I promised you that we're going to also add the web RUM functionalities. So before we implement it, let me give you a bit more information on what that actually is. Real user monitoring will give you visibility into behind-the-scenes performance of a web application and accurate insights into end user experience. RUM will visualize application interaction patterns and give you in-depth understanding of problems affecting real users, accessing websites and applications in real time. You'll also get to analyze application performance from every aspect, like browser, platform, geography, ISP, and more. The way it works is users simply need to generate a small JavaScript snippet and install it in the header or footer part of HTML. From there on, Site24/7 will capture and present all the data. So let's follow the steps. First, log in into Site24/7, which we have already done. Then select APM. This is Application Performance Monitoring. And right below it, you'll be able to see Web RUM, Real User Monitoring. Click Add Application. Adjust the display name, which you can select as JSM Classroom App. And then here, we'll need to paste the URL of our deployed frontend application. So that means that finally, we have to deploy the frontend too. You can do that by heading over to vercel.com/new. And there, you'll be able to find Classroom Frontend. So simply import it and make sure that you've pushed all the latest changes. Vercel will automatically recognize that you used Vite, and you can also enter your environment variables. You can, of course, get them if you head over into your .env of the frontend application, where you'll be able to see your connection to the backend base URL, as well as some information for Cloudinary. You can copy it and paste it right here. You'll notice that our current Vite backend base URL points to localhost, but that's no longer the case. Since this is going to be a production deployed frontend, we need to point to a production deployed backend as well, which is coming right here from Railway. So simply open up your deployment and copy the URL. Once you get it, you can simply override it right here to point to https:// classroom backend production up Railway app /API/. Just like that. For you, of course, it's going to be a bit different, but in general, it should stay the same. So once you make those changes, go ahead and click deploy. It's now going to start with the deployment, but since this is our first deployment in a long time, it is highly likely that we're going to have some little warnings or errors, most likely by TypeScript, letting us know that we missed adding a couple of types. And just as I was saying it, take a look at that. TypeScript is complaining a bit. So what we can do for now is make use of TypeScript locally as we're developing, but we can make it not make errors when trying to build the application. To bypass it, you can head over into your code and head over to your package.json of the frontend application. Then if you take a look at the scripts, in this case, we just want to remove the TSC part of it in front. And then you can simply push the change over to GitHub, which is going to try to rebuild the application. So run git add dot, git commit -m, skip TypeScript during builds, and then run git push. As soon as you do that, and go back to your Vercel dashboard under deployments, and you can see that it is being built right now. So if you open it up, let's see how it goes. Oh, it looks like it got deployed in about 27 seconds. That is great. So if you actually click visit right here, we are redirected back to the dashboard, which is a great sign. And then if you head over to subjects, this is the moment of truth to see whether the connection to the backend has been established. And unfortunately, it fails. But if you think about it, it makes sense that it's failing. We have added the URL of our backend to our frontend, but we didn't yet tell our backend that our frontend is now live. And we couldn't have done that because we just got the URL like 10 seconds ago. So if you inspect it, you'll see that access to fetch at this deployed backend URL from origin, this is the new URL that we're on, has been blocked by course policy, which makes sense, right? Currently, it's allowing only our local frontend, but not the production one. So fixing this is pretty straightforward. You can head over to Railway and go to your project, variables, and find the frontend URL. It's no longer localhost 5173, is it? It's now the URL of our deployed application. So copy it and paste it right here. By editing it, that's going to be classroom frontend, some random characters, vercel.app, and you don't have to add anything else after it, just like this. And once you save it, you'll need to redeploy. So let's wait until our backend is back in action. And there we go. Our classroom backend is now back online with the updated frontend URL. Now, if you go back to home and then click on subjects, you'll see that they'll load. But if you just reloaded the page, you will likely have gotten a 404. This time coming from the frontend side and not the backend. This is a classic single-page application routing issue with Vite on Vercel. Nothing is broken in your app, but since your app uses client-side routing to go to, for example, dashboard or subject and so on, these pages don't exist as real files. So on refresh, Vercel tries to find it, and it can't. Instead, we need to point back to the index.html and let React handle the routing. Thankfully, the fix is pretty simple. You just have to create a new file in the root of the classroom frontend application called vercel.json. Within it, you can open up a new JSON object and say rewrites, which is going to be equal to an array of an object where the source is set to any route that is not the homepage. So that's going to be / anything. And then the destination for any of these pages will be set to / index.html. And just before we commit it and push the changes, just make sure to add a dot here. It is supposed to be .* to match all the routes. Then you can type git add dot, git commit -m, fix React single page application routing issue, and type git push. This will push it over to Vercel, which will automatically start a new rebuild. In just 17 seconds, it is ready. But I noticed when I was adding the frontend URL back over to the backend route, I was under a specific deployment, and each deployment has its own specific URL. Pretty cool that Vercel does that. But in this case, we just needed to be on the main domain, which is the latest deployment that we have. So you'll have to copy the URL from that one, and then back on Railway, you'll have to update the frontend URL to not have a specific deployment ID right here. Rather, it'll just have to be a clean one like this, and make sure to remove the / at the end. It has to be exactly like this, of course, with your production URL. So save it and redeploy it. Within about a minute, you'll be able to head back over to the front end, and the connection between the backend and front end will be established, this time in production. And now, if you head over to subjects, you'll be able to see that it fetches them properly. You can also head over to that URL and then manually navigate over to classes / create to be able to create a new class. Of course, theming and everything works just as it did before, and now you can actually reload on the same page without it breaking. This is a huge thing. Your full stack PERN application is now deployed and live on the internet, as well as its two major parts are connected and are speaking to each other. So this is the time where your users can actually start joining the application. And that makes it the perfect time to add real user monitoring from the get-go. So let's continue going through the docs. And of course, we'll check out all of this within the dashboard very soon. But now we can use our frontend URL directly right here to add a real user monitor. So simply paste your website URL and change the application framework type from traditional to a single page application. These are the only settings you have to change, so click save. Once it is saved, it might take a couple of seconds to redirect you to a different page, and you'll get the steps needed to configure RUM. You can copy this script right here, but don't close this page yet. Then go to your front-end application, specifically within index.html, and you can add this script at the top of the head where you have all the meta tags. just above the title. Then we need to push this code over to production by running git add dot git commit -m implement site 24/7 rum and run git push. Wait for Vercel to redeploy, and then back within site 24/7, you'll need to paste the URL of your application, and then click verify. It'll analyze your website for the presence of the snippet. And there we go. It says we have identified the rum script on your website. Data collection will start shortly. And that's it. You've successfully integrated rum, real user monitoring, into our application. If you click on APM, you'll be able to see that one site is up. And with APM, we were mostly focused on our backend APIs. Databases, server-side code, performance errors, how much time it takes for a specific transaction to go through, and so much more. But honestly, users don't care how clean your backend architecture is. They don't care how optimized your database queries are. You care about that. But they care about one thing. Does the app feel fast or not? And that's exactly where rum comes into play. As the name suggests, rum will show us what the real users are experiencing when they use our application. Currently, the data is fully empty, and that makes sense because we just set it up. But as your app is now live and on the internet, hopefully you'll get some users. Those users will be making some requests. They will click around, they will try to expand things, break things, change the theme, and just mess with your application in general. They might also try to find some random URLs that don't exist on the page yet, and that might break it. Or they will find some that do, such as classes, create. Maybe some will actually use your application and create some classes. This time, instead of Python, maybe they're gonna work on some algorithms and data structures. We can find an algorithms banner on Unsplash using Cloudinary, or you can try to upload your own. In this case, let's say that the class name is gonna be set to data structures. The subject is gonna be data structures as well, with teacher Tom, of course, our main teacher, a capacity of 10, a status of active, and data structures are gonna focus on performance analysis and algorithmic thinking. So let's create a class, and once again, we'll be redirected to a classes list page, making us think that we have actually successfully created a class, but unfortunately we can't see it yet, which for sure means that that is the next thing that we have to implement as soon as we're done with the monitoring. But as I have been clicking around the site right now, we are expecting to get some data. And would you look at that, I'm the only user that's currently using the site, and it looks like my AppDex satisfaction score is 1, which is great. I'm coming from this little country right here in the middle of Europe. If you didn't know that up to this point, you know now. So if you came to this point of the video, feel free to let me know down in the comments down below that you actually came to this point and tell me where you are from. But with that in mind, you'll also be able to see some web transactions, such as users making a request to random sites, which they might think exist, and the response time for that 404 was, for example, longer than it was to get to the actual route that we have. There, you'll be able to see the average, minimum, maximum, and all the other information about how your users are using the site and whether there are any errors. Again, this data will just continue to fill up with more information as more users use your site. So you'll be able to know the response time by browser, for example, by geography, even by the operating system or the type of the machine that your users use. You'll know everything, and you'll be able to fix it if your site gets slow. So now that we have both rum and APM in place, you can see the full picture. APM tells us what's happening inside of our backend, while rum tells us what users experience outside in the browser. So when something feels slow, you'll be able to trace it properly. Users opens up a page, frontend loads, API call, backend processing, speaking to our database, you get a response, and only then you get a UI update. This is how real production systems work and how they're monitored, and it's exactly the difference between hobby projects and real industry-grade applications. Real projects don't just run, they're observed, And with RAM integrated, you're no longer guessing how users feel about your app. You actually know. And combined with APM, you now have full visibility from browser to backend. This is the kind of setup that keeps you ahead, not just of bugs, but of those AI slop, no monitoring, ship and pray projects. This is different. Now, finally, in the next lesson, let's display all of the classes we've created so far. In this lesson, we'll finally create a get route to get the list of all the courses created so far with filtering, search, and pagination, and then hook it up on the front-end side to display the list of all of these classes. Exactly the same as we've done with the subjects. But before we move on, I hate to be that guy, but I want to give you a bit of homework. You should be able to handle all of this on your own, especially after everything we've covered from building routes and connecting them to the front end, and also displaying the data using Refine's hook and Chatsien components. It isn't some complex new logic. It's the same exact process that we used for the subjects. And if you can't replicate it on your own for classes, then what are you really learning? So please pause the video right now and try to create a get route on the backend for the classes, because right now we only have the post there, so we need a get route, and then consume it from the front end on your own. You can take a look at what we're doing with the subjects as an example, where we're getting them, and also where we're using them on the front end. So pause the video right now and do it. I'll walk you through the solution soon. In 3, 2, 1. How did you do? Hopefully you were able to do it well. To catch up with you, I'll let Junie bring me up to speed. Again, don't think that Junie can replace you. You first need to go through it and do it a couple of times yourself. And then when you understand how it works behind the scenes, you can use it to speed up your workflows. So if you want, I'll also provide this prompt in the video kit down below. So let's go ahead and run it. And then I'll walk you through everything that you needed to do. And there we go. It is done. So let's go ahead and take a look at the changes that it made. Take a look at the routes, classes, and it implemented the route to get all the classes with optional search, filtering, and pagination. This is exactly what we wanted. If you were struggling with joining the tables a bit to make this work, don't worry, as that's totally fine. Here, we're really diving into more complicated database structures. And if you want to learn how to get to this point where you can do this and even more yourself, I'll leave the link to the ultimate backend course waitlist in the description so you can be the first one to check it out when it's out. I'll also leave the final routes classes.ts code in the video kit, so in case you made a typo or if you're missing some little details, you can still get the full app to function. To test it out, you can make a request to localhost 8000/API/classes and press enter. And with that, you can see that we indeed get back 2 classes that we created, one on data structures and the other on Python foundations with the hosted banner URL from Cloudinary. And now that the backend is done, switch over to the front end where we have to develop the pages, classes, list component. This is the empty page that we've been seeing for quite some time now. Once again, you can give this a shot on your own by comparing it to subjects list. You should be able to get pretty far by just duplicating this page into the classes list and then modifying the data that we're getting in. So pause the video right now and give it a shot. We'll continue in 3, 2, 1. And how did it go? Were you able to render the classes as we're rendering the subjects? I'll ask Junie to do it for us now, and then we can go through the code together. I'll also provide the complete prompt that I use in the video kit link down in the description. So let me run it. And it's so nice to see in real time that it's editing the list and then the whole file just pops up here with a lot of code that would, let's be honest, take us some time to make. And with that in mind, it has implemented the changes in only 2 files. It changed the complete list file, which I'll provide to you in the description down below, just so you have it as well in case you weren't able to bring it to 100%. And then a couple of lines in the data part right here. So let's go through the classes list together. Starting from the top, we also have the search query for searching, and 2 filters for the subject and the teacher. We have to make requests to get both the subjects and the teachers so that we can properly filter the options. Then we apply some filters right here, and we start defining the columns for the banner URL, the name, the status, subject, capacity, and then we finally pass all of that into the table and display it just as we did before. So the moment of truth, if I head over into the classes, would you take a look at that? I am super amazed with this. It even picked up and rendered the banner image that is deployed on Cloudinary, the class name, the status, the subject, the teacher, and the capacity. All the details are right here. And take a look at this. You can even filter it based on subjects as well as teachers. And if the search works, let's see, I'll search for Python. It works like a charm, and you can also navigate over to the create page. Journey absolutely killed it right here, and hopefully you were able to replicate the subjects page to get to this point. You can totally fix up the UI a bit, but I think I'm super zoomed in. So as I start zooming out, it's gonna start looking better. And by default, it should already be responsive on mobile devices. So if I go all the way here, take a look at this, it works like a charm. Let's not forget to push all the changes to GitHub, including the ones on the backend. So I'll do frontend first by running git add dot, git commit -m, implement classes list page, and git push. I will take that same commit message for the backend as well. So do cd dot cd classroom backend, run git add dot, git commit -m, implement classes list page, and git push. With that in mind, we've done huge improvements to our code base, and this is a proper full stack application now. But in the next lesson, together, you and me will code out the class details page so that you can click on it and get additional details about everything happening in that class. For that one, we won't use any AI and we'll finalize it on our own. So let's do that next. In this lesson, we'll create a get route to fetch the details of a class and then use it on the front-end side to display that information. So back within our application, open up your backend repository and navigate to source, routes, classes.ts. Here we have the router.get as well as the router.post. And now we want to add a third route that gets the class details with teacher, subject, and department information. We can do it by creating a new router.get route, and this time it'll be a dynamic ID route. So it's going to change depending on which specific class we're on. First things first, we want to get the class ID so we can fetch the rest of the details. So we can say class ID is equal to, we'll turn it into a number, and it's going to be coming from rect.params.id. You have to turn it into a number because everything that comes through the rect params is converted into a string beforehand because it's a part of the URL. Then if class ID is not a number, so if not number dot is finite class ID, in that case, we will return res.status of 400, and we will return a JSON output of error, no class found. But then if we do find a class, we are ready to return the class details. So I'll say const destructure the class details from an array and make it equal to await db.select. We're selecting it, and now we have to specify specifically what we're selecting. We can say get table columns from classes. Then on it, we're also going to add the subject information by getting the table columns from subjects. Outside of that, we'll also get the department information. So I'll say department, and that's going to be set to get table columns from departments. Make sure to import this right here from the top. That's going to be coming from here, Schema app.js. And we want to get access to the teacher information as well, which is going to be set to get table columns of the user that posted that class. Then we will chain a dot from classes onto the dot select so that we know where to get it from. And we will join some additional pieces of information, such as the subjects, where the subject ID is equal to subjects.id. And we also want to join the teacher information. So I'll say left join user, where the teacher ID is equal to user ID. And we also want to join one more thing, and that's going to be the departments. Class's department ID is departments.id, but the department is going to belong to subjects. So we'll say subjects.department ID, not classes. And finally, we'll add a dot where eq classes.id matches the class ID that we're searching for. So it has to be a very specific class details that we want to return, one whose ID matches the params at the top. Finally, if there are no class details, in that case, we can just return a res.status of 404, no class found. But if there is one, we can simply return a res.status of 200 and bring back the data that's going to be set to the class details. Now we want to switch back to the frontend repo and create a new page component that renders all of these details. We can do that by switching over to frontend, source, pages, classes, and this one in Refine Core Dictionary is called show. So it's going to be classes show.tsx and run rafce. This one will open up to show the details. We can define this new class route within our app.tsx. So you can head over here, and where we define the classes resource, we can also define the show and point it to /classes /show / and then colon ID. And then we can also add its route right here below in classes, where the path matches show / ID. We will then show classes, not create, but classes show, which we have to import right here at the top. That's going to be classes show coming from classes show.tsx. Perfect. Now we can add an option to go to the class details page from the class list page. So head over into classes list, and there is only one column that we have to add to the table columns. So if you scroll all the way up where we have the table columns, let's add one more table right here. It's going to be a column with ID of details, a size of 140, a header component that will render a p tag that says details, and finally a cell that gets access to the value of the row, and then it will automatically return a new show button. This show button is coming right here from the top from Refine Buttons Show, and it has some built-in redirection capabilities. Still, we have to pass it some props so it knows what to do. This button will say view, so we can view the details. And then we have to let it know the details of what do we want to show. The resource is going to be classes. The record item ID will be set to the row original ID. The variant will be set to outline. And size will be set to small. If you head back over to your application, you should be able to see a new details column where you have this view button that when you click on it, it properly redirects to localhost classes show 2 or classes show 1. So that means that we are ready to implement the show page. But just before we do that, quickly head over to providers, data.ts, and we have to define the endpoint that processes the request on your behalf and provides you with the right data on that page. So right here under options, right where we have the get list and create, we also need to have another one, which is get one. This get one will have the endpoint where it gets access to the resource as well as the ID of the resource. And then it just returns it like this by saying template string resource / and then the ID of that resource. And then we also need to map the response and that's going to be equal to an asynchronous function where we get access to the response. And as usual, we can get access to the JSON information. So this is going to be get one response, which is going to be equal to await response.json. And then we simply need to return JSON data or an empty array if that doesn't exist. This is to get the details of one resource, like the details of a class, subject, and so on. We only have to do this once, because later on when we work with other resources, we will already have implemented the get one functionality in our provider options. So now we are ready to develop the class details page by heading over to classes show, and we can first get access to the class data. Refine makes that super simple. The only thing you have to do is say const, destructure the query, and call the use show hook coming from refine dev core. To it, you can define the type of data that we're going to get back, such as class details. And then to it, you can say which resource you want to get back. In this case, we want to get back the classes. Once you have the query, we can further destructure the data by saying const class details is equal to query dot data question mark dot data. We have to do this because that's how we're sending it from the backend. From the query, we also need to get some additional details. Now, let me show you an alternative way to get access to this variable of data. You can do that by saying const and then destructure the data coming from query. From this data, we of course have to destructure data one more time and then rename that to class details. What this syntax allows us to do though is to get some more information out of the query, such as the is loading state and is error states. Once we have those states, we can have some if statements right here to check whether everything is correct. And that can be if is loading, or if is error, or if there's no class details. In that case, we can return a new show view, which you can import from show view, that'll have a class name set to class view and class show like this. And let's also check why we have this error right here. It says that property data does not exist on class details. Well, that's interesting. Maybe while I was destructuring it, I went one layer too deep. We'll take a look at that later. For now, we're working on what happens if we don't have any data. And I think we can immediately display this right here if I collapse the screen a bit and then head over to something like classes show 3, because if we're on 3, then the class details will be empty. But yeah, first we have to fix the way in which we're destructuring it. Currently data is undefined. So what if I go ahead and just destructure the data like this from the query? I can console log it and see what this data will be equal to. It seems that it is undefined. So for this reason, the fact that query comes undefined at first means that unfortunately we can't destructure it like what I have done here. What we have to do instead is destructure it in 2 lines. So first we destructure the class details as we did before, and then we can also get the is loading and is error out of it. But unfortunately, we're still getting a 500 from the server. So if you open up our terminal and go to backend, you'll see why that error is happening. And it seems like our query fails. So let's head back over to the backend for a second. That's going to be within our classroom backend, source, and then we go over to routes, classes, and let's make sure that our query is correct. Oh, and I think I can notice it right here under departments. I was right when I said that departments depend on subjects. So subjects.department ID. But here I still needed to use the departments.id, and instead I had user, which I copied over from here. That was a mistake on my end. So if we fix this and then go back and reload, you should be able to see that show comes back. And if you console log the class details now and head over to console, you'll be able to see that we get back the object with the full class details that we can then display on the screen. Perfect. But now let's handle the case what happens if we are showing an error or loading or something like that. We can still show the view header with a resource of classes and a title set to class details. That's fine. But we'll render a p tag with a class name set to state-message that'll check if we're currently loading. And if that is the case, then we will render the string that says loading class details, ... Then we can check if maybe we are not loading. And if that is the case, we will check if we have an error. Then we will say something like failed to load class details. And then else we will say class details not found. Because if we're not loading and we don't have any errors, then class details don't exist. So we handled all the unfortunate cases now, and now we can focus on actually dealing with relevant data. First, we can get access to the teacher name, and that's going to be coming from class details dot teacher question mark dot name, or maybe it's going to be unknown if we don't have that name. Then we need to grab the teacher's initials to be able to show them. That's going to be equal to teacher name dot split. We're going to split it by empty spaces. Dot filter, Boolean. If you do it like this, it'll just remove all the empty spaces. Then we want to slice it from 0 to 2. Then we want to map over the slices over each part. And for each part, we'll take the first letter and we will uppercase it. And only then we will join it back together with no spaces in between. So this is how you create initials in JavaScript. Dot split, dot filter, dot slice, dot map to uppercase, and then finally dot join. Finally, we'll also have to render some kind of a profile photo or a placeholder of a profile photo for teachers. So we can say const placeholder URL is equal to https://placehold.co/600 times 400 question mark text is equal to. Now you want to call encode URI component, and into it you want to pass the teacher's initials, or NA, doesn't exist. This will give us the URL. And finally, we are ready to create the JSX. So first, we will return what Refine provides us with, and that is the show view, specifically with a class name set to class view and class show. And then within it, we can render the show view header with a resource of classes and a title of class details. This allows you to automatically refresh it or edit it in real time. Then we can render some kind of a banner by creating a div with a class name of banner. Within it, we can render the class details and check if a banner URL exists. If it does, then we will render Cloudinary's advanced image. And if it doesn't, we will simply render a div that has a class name of placeholder. Very soon, we'll pick this up from Cloudinary. But for now, let's continue with the rest of the details. Right below the div that has a class name of banner, I'll render a card. This card will have a class name set to details-card. And then within it, we can create a div with a class name set to details-header. And within it, another div within which we can have an h1 that'll render the class details.name, and below it a p tag that'll render the class details.description. And here you can see data structures and then its description. Now, just so we don't have to repeat ourselves every now and then by saying class details dot something, class details dot something, and so on, what we can do is we can automatically destructure the values from the class details right here by saying const destructure the banner URL. We can also destructure the name, the description, and so on. And that's going to be coming from class details. Thankfully, we already know what the class details are consisted of, so we can head over into it and we can automatically just copy all the fields that we think we might need. We can easily just remove them later on. For now, I will copy them and just put them right here. And don't forget to add commas in between, and then we can put them into a single line. Perfect. Now, you no longer have to say .banner URL, .name, and so on. It's just going to be name, description. It makes sense because we're talking about the class. All of this is specifically about the class. Now, below this little div, still within the header, create another div within which there's going to be a badge coming from components UI badge with a variant of outline, and it'll render the capacity. And then we can say 10 spots. Below it, we can render another badge. This one will have a variant of if status is set to active, then we'll give it a default color or default variant, else we'll give it a secondary variant. And this one will have a data status of status, and it'll of course render, you can guess it, status dot to uppercase. So it says active. Then we can go a few divs down and we can render the details grid. That's a div with the class name of details grid. And here we'll render another div with a class name of instructor. And here we can render the information about the instructor. We can do that right below this p tag within a div where we'll render an image with a source link of teacher.image. We can do .image in case if it's not there, or we can render the placeholder URL if it doesn't exist. So here we get TT. I think that stands for teacher Tom. And we can also give it an alt tag, which is going to be set to the teacher name. Now, below the image, we can render another div that'll render the p tag with a teacher name, and below it we can also render the teacher.email, teacher Tom, and then we can see the email right here. We can head 3 more divs down, still within the details grid, but below the instructor information, we can render a div that'll have a class name set to department, and within the department we can render a p tag that'll say department, and then below it another div that'll render the department.name, as well as below it department.description. There we go. You can see electronics and communication, and then you can see what it is all about. If they don't exist, we can just add a question mark right here just to be safe. Same thing goes here. And we can also add a bit of space by turning these into p tags. So p right here, and this one will be a p tag as well, just so we give them some breathing room and styling. Now we can head below all of those divs and render a separator. Of course, we have to import this separator from somewhere. It's going to be coming from components UI separator. And then we can also render some information about the subject. So I'll do a div that'll have a class name set to subject, a p tag that says subject right here, then another div that'll render a badge that'll have a variant of outline, and here we can render the code of the subject. So I will say code is going to be set to subject.code with a question mark in between, and then below the badge we can render a p tag that'll render the subject.name, and below it subject.description, same as with the department. There we go. We can see that here. And finally, we can have the join class section. So separate this subject div with another separator, and below it render a div that'll have a class name of join, where we can have an h2 that'll say join class. Below it, I'll render an OL, an ordered list, within a couple of LIs. First, we'll say ask your teacher for the invite code. Then I will say something like click on join class button, and we can say paste the code and click join. This way it's super clear exactly what they have to do. And finally, we will render a button right below this div This button will be coming from components UI button with a size of LG, a class name of w-full, and this button will simply say join class. Perfect. So later on, we'll be able to implement the functionality for this. And finally, now that the full details are done, this is how our details page looks. Pretty cool, right? The only thing that we're missing is the banner image for the class. Remember that Python and this woman teaching data structures? Well, yeah, we want to display it here, but it's highly likely that the image that a teacher uploads isn't going to be the right format, right? So think about how you usually work with images. You allow your users to upload them, then they don't fit what you imagined, and then you start fixing the UI. You add border radiuses with CSS, you place text on top of it using divs, resize it, and change media queries. That works, but it also means the browser is doing a lot of work with an image that was never really meant for that screen. Since we're using Cloudinary to upload and store those images, the idea is a bit different. You only need to upload an image once. After that, you describe what you want to happen. Do you want to resize it, crop it, focus on the face, round the corners, add text, optimize it, and you do all of that within just a few lines of code using their SDK that modifies the main URL so that the original image is never hurt. So instead of styling it, Cloudinary gives you exact images you need before they reach the browser. And you might wonder why that matters. Why don't we just add border radius or text overlay using CSS? Well, that's because the CSS doesn't change the image. And if somebody downloads it later on, that's not how it's going to look like. Cloudinary will transform the image itself. If you ask for a smaller image, fewer pixels are going to be delivered. If you want to round the corners, the image is already rounded. In my opinion, that's what makes Cloudinary powerful. Not just the transformations, but where they happen and how easy they are to use. That said, let's add some transformations to this banner image, such as rounded corners and overlay text that shows the class name on top of the banner. Create a new file right within your source under lib and call it cloudinary.ts. And we can create this new function by exporting it and creating it and calling it banner photo. That'll accept the image CLD pub ID of the image of a type string, as well as the name of the image of a type string, and it'll automatically return CLD. This CLD is the instance of Cloudinary that we'll create right here. So const CLD is equal to new Cloudinary. This Cloudinary is something that we have to import. So right here, we can say import Cloudinary coming from @Cloudinary/URL-gen. And it seems like it's not imported. Oh, and that's because I added this file within the backend lib folder. We don't want to do that, so copy this code, remove it from the backend, because all of this is happening directly within the frontend part, under source, lib, and create a new Cloudinary.ts file over here. And if you paste it now, we'll still have to install this package. So let's run install @Cloudinary/URL-gen. And then we can pass some additional options where we're creating this Cloudinary instance, such as cloud. And you can enter the cloud name, which will be set to the Cloudinary_cloud_name coming from constants. Now we actually have it because they're coming from the frontend part. And then we can define what we want to do with this image. So I'll say CLD.image, image CLD pub ID. Then we want to resize it. Specifically, we want to set it to fill with a width of 200 and a height of about, let's do 300. This fill has to be imported from Cloudinary, coming from Cloudinary URL-gen actions resize. Then we can also optimize it for the web by saying .delivery is going to be set to format, which we also have to import from Cloudinary. And then we're going to set the format to auto. We can also set the quality to auto, and we can finally set the DPR, which stands for the device pixel ratio, to also be set to auto. Then we want to overlay it with the name. So for this, we have to get the source coming from overlay. To it, we want to pass the text. So also import that from Cloudinary. Text is going to render the name of the class, and we can choose in which style. So I'll say new text style of Roboto 42 with a font weight set to bold, and you can exit two of these parentheses. Text color set to white. You also have to import this text style coming from Cloudinary. You can do that by saying import text style coming from @Cloudinary /URL gen /qualifiers /text style. Finally, we have to position that text somewhere. So add a .position property and choose a new position. This is also coming from Cloudinary. That's going to have a .gravity field set to compass, also coming from Cloudinary, set to south_west with a .offset y set to 0.2 and a .offset x set to 0.02. I found these values to work the best. If we space this out properly, this is how it's supposed to look like, and make sure that you close everything properly. Here, I have an instant return, but if you have just a regular function block that looks like this, then you'll have to add return in front of it. Either way is totally fine. Now we can go back and actually use this advanced image from Cloudinary. I'll display it like this, and we have to add it here. If a banner URL exists, then render a new component that's going to be an advanced image, which is going to be self-closing. And this advanced image is coming from @Cloudinary /React. If we haven't yet installed that package, now might be a good time. So run npm install @Cloudinary /React. And you can already see that there's space for this image to appear right here. Now we need to pass additional props to it, such as the alt tag of class banner, and also the CLD img. And within it, we can call our banner photo. This is the function that we created in that other file. To it, we need to pass the banner CLD pub ID, as well as the name of the class, which is the second parameter. If you save this, we'll get something that looks like this. And now you can further play with exactly what you want to do with this image. For example, we don't even have to set the width. In our case, I think we can also remove the height too. That way we'll get a higher res image. I'll leave all of these delivery optimizations. But hey, where is the class name? I can't really see it on this image. If I open it up in a new tab, you can see it right here, Python Foundations. It's going to be a bit below what is actually showing on the image. So we might need to change where it's actually showing. I'll remove the gravity part and the offsets. That'll bring it to the center. So if I just turn on the gravity and set it to west, that'll move it all the way here to the left. We can also set the offset X to 0.02, which is going to give it some padding. And of course, we need to increase the size of the text because currently it's way too small. So let's go with something like 100. And this would be super useful if you had some generic image right here that doesn't say anything about a class, but you want to immediately grab the class name to display it. And if we go to this one, you can see that it changes to data structures, and this makes so much sense. If I make it smaller, you'll see that it'll still look great. So the responsiveness is done, and so is our class details page. In this one, we wrote a lot of code, and we definitely want to get it tested. So let's go ahead and fix this little warning right here, saying that if we don't have a banner CLD pub ID, we can just pass in an empty string, and we can remove these unused variables that we have destructured from the class details. Perfect. With that in mind, let's go ahead and push our code. We can push the backend, sure, by running git add dot git commit -m, and then we'll say implement class details and git push. But what I care more about is pushing the frontend too. So I'll cd into classroom frontend, run git status to check which branch we're on, and then we can create and check out to a new branch. Git checkout -b feat class details. Then run git add dot git commit -m, implement class details page, and git push. Of course, we'll have to set the upstream, and in a matter of seconds, you'll be able to see your code pushed right here. So let's go ahead and compare it and open up the pull request. And let's see what CodeRabbit has to say about this one. And in this lesson, we implemented a dedicated class details page displaying comprehensive information, including the instructor profile, department, subject details, capacity, and status. We also added the details button in the classes list so we can quickly access that page, and we improved the image support for branded class banners with text overlays. Will we get a nice looking sequence diagram this time? It looks like we do, and this one is for the class details page. Shows you exactly how users are navigating, how we speak with our data provider that then speaks with our backend, that then also speaks with the Cloudinary service, and finally returns all the data back. And as usual, we get back some super useful information, such as adding additional input validation for the banner photo function, because right now it doesn't validate that these are non-empty strings. And here it automatically proposes a fix that we can add. It's just a single if statement that throws an error if we pass in empty strings. In this case, we have a little logical inconsistency. We are checking for the banner URL, but then within the actual image, we are rendering the banner CLD pub ID. I think in our app, if we have one, we'll have the other, but CodeRabbit is right to point this inconsistency that I wouldn't have noticed. If we wanted to be 100% sure that we are rendering it properly, in the ternary operator right here, we should also be checking for the banner CLD pub ID. Here we have a small one where I missed a strict equality operator, which is always better to use in JavaScript, and some minor issues checking if a teacher actually exists. And then another issue right here. This is interesting. Before, when we were fetching the list, I returned an empty array if we were not able to fetch the data. But within show, we are returning a single record, not multiple. So returning an empty array doesn't make sense. We should have been returning an empty object instead. You can go ahead and make the changes that CodeRabbit suggested on your end, and then repush it and finally merge it. With that in mind, our app is looking better and better every second. We have a comprehensive subjects list, a classes list where we can filter everything. Sure, our home dashboard is pretty empty right now, but once we have all of this data within our application, it's going to be super simple to show it all on the dashboard. I'll leave the final code down in the description so you can refer to it and implement this dashboard yourself. But let's just quickly check the class details page one final time. And yep, I know I'm repeating this so many times, but this is a real full stack PERN application in the full sense of that word. We're dealing with backend, frontend, and database and connecting it all together in a nice looking dashboard. So by this point, every other feature that we add is mostly going to be just repetitive. So in the next lesson, I want to teach you something entirely different. A skill that'll allow you to take everything you've learned so far throughout this crash course, but then 10x it and be so much more productive. We've already added a ton of features to our application, but what if we can do more? Take a look at this dashboard. One part that was still pending, but that would take a lot of manual work to make all of these fetches and then display all of this data right here. It's not hard, but it is manual and takes time. And remember how before we used Refine to very quickly recreate some features that we developed up to that point? Well, now that we've manually developed everything so far, we will recreate that and more using Refine in a matter of minutes. If you didn't follow along before and create your free account, you can do that right now. Again, the link is down in the description. And with that special link, Refine will give you extra credits so that you can develop much more than just this project. Once you click the link, start for free. Then connect to your GitHub and you can create a new project. In this case, we already have our classroom portal, dashboard, and subjects that we have developed before. If you remember our plan, we already developed a huge portion of it. The basic dashboards and subjects browser, everything that we manually coded up to that point. But now is the time to bring it to the next level. Now, whether you're starting from scratch to rebuild this entire project using Refine to see just how good it is, or you followed along when I used refine before, either way, our next prompt is going to be the same. I'll provide it in the video kit link down in the description, just so we don't have to type it out manually and to make sure that we get as similar results as possible, but we'll go through it together to make sure that it all makes sense. Okay, so what do we tell it? I'll expand this just so we can see it a bit better. And we're telling it to build a full stack admin dashboard for a classroom management system. Here, we're talking a bit about the data, where we have users, admin, teacher, student, departments, subjects, classes with invite codes, capacity, and schedules, and finally, enrollments of users and students into those classes. So let's dive into the specific features. First, we want to implement CRUD, create, read, update, and delete. So full CRUD functionalities for everything in our database. Users, departments, subjects, classes, including list views with search, filters, sorting, and pagination. And this is pretty cool because this is a lot of work. But at this point in time, you know exactly how to do that manually. So it's not like it's going to do some magic. You know what the code does. And then also we want to do the create and edit forms for all of these columns, detail pages, and delete constraints. We want to talk about enrollments, how we can manage them within class detail pages, where we can enroll or unenroll students, view enrolled students list, and so on. Then we want to add some information to the dashboard, such as the overview cards, 4 charts for enrollment trends, classes by department, capacity status, user distribution, activity feed, key metrics, just some data to show on the dashboard. Finally, we want to add search and filters. We're not talking about list-specific search, but rather global search header, where we can automatically search across the entire application for a specific class, or student, or teacher, or department, or literally anything. We also want to add some filters for role, status, dates, capacity, and the URL state. Finally, we are introducing a complete invite code system where we can invite some students to classes. Let's go ahead and click send. Refine will now take this into consideration and update our existing plan. And again, this plan.md file is just a checklist of all the tasks needed to build the app. The AI will organize the task by features and groups and group them into different phases, so it's easy to follow. With our first prompt, we implemented the phase 1. But now we want to enhance the dashboard. At least this was the phase 2 before we inputted this additional prompt. So now you can see right here that it's creating a full plan for this comprehensive admin dashboard where it'll actually update it. And just like that, you can see that there's now an updated plan.md. Now we no longer just have a couple of phases, but there are 10 different phases where it's going to implement subjects management, department management, classes management, enrollments management, all of those things separately so that it can do them well. I'll go ahead and collapse everything so we can read through everything that it wrote down. This plan will help keep the build organized, like we are developing it on our own, to make sure that nothing is missed. So let's go through the plan together. There are 10 phases. The first one is to implement login and sign-up pages using the existing Better-Auth provider. Then we implement the users management, which includes complete CRUD with role filtering, search, and detailed pages. Then we implement CRUD with subject counts, totals, and constraint handling for departments. We do the same thing for subjects, classes, and enrollments. Finally, we take all of that data that we have and we display it in nice looking cards within the dashboard. And we then improve the dashboard by adding 4 additional charts for visualizing the data. Finally, we add that special feature which handles the search and filtering globally across the entire application and implement that invite code system. This builds everything we requested. Full CRUD for all resources, enrollments with class pages, dashboard, global search, and invite codes. So let's go ahead and execute. This is obviously a huge build. I mean, just the video took more than 7 hours. It might have taken you weeks to follow along with the video and actually implement it. So let's see how Refine will handle it. what you can notice is that it'll tell you exactly on which phase is it on. And then that phase will have a specific number of steps. You can pay attention and see exactly what it is doing under each step by expanding it. This is what I love to see with those AI tools that generate code, and that is that they tell you exactly what they're working on in real time, so that you're not just sitting there and thinking, why is this loader just spinning? It tells you that it's actually updating the form file, implementing the authentication page, and what I love about Refine even more is that you can see those changes in real time by switching over to the editor tab. And then in this case, it mentioned the sign up form. So if you head over to pages, auth, and then login or register, you can see exactly where that sign up form is being used. And you can head over into components, Refine UI, form, and find this new sign in and sign up form. Again, the code is written incredibly well. It is just how you would write it on your own, maybe even better. And the best thing about this is that you don't have to reload your browser to be able to see the changes that it is making. This means that as you're looking at it, some new changes might come in as it's developing it like a real developer would. And alongside taking a look at the code, you can also open up the preview to see exactly how the website is looking in real time. Of course, as when we're developing it manually, some issues might pop up on the way, but as soon as those are resolved, the real preview will show up. It's fixing it on its own right now. And there we go. In about 30 seconds or so, it looks like we now have a fully active preview, which means that Refine was able to debug and fix the error that it encountered. And we have a nice looking sign-in page. Is it going to work if I switch over to sign up? It actually does. Sure, there are some little tweaks to fix, such as the padding right here between the name and the email. But those are super simple to fix. You can just tell it. But yeah, you can see it automatically created roles when we're creating accounts, password confirmation, switches between sign in and sign up, and we can just easily tell it to add password reset too. So let's see what it does next. Now, if you notice that it's loading for some time, you might try to reload the page. There we go. I knew to reload because as I was looking the changes that it was making, it just wasn't adding any new file reads or writes, so I assumed that it is actually done. This is just a bug that the Refine team might have already fixed by the time that you're watching this video. Either way, a reload doesn't hurt. So the phase 1 is now complete. The authentication is now set up with a sign-in page, sign-up page, protected routes for authenticated users, and the logout functionality. Now, what do you say that we actually test it out? I'll head over to sign up and create a new account. I'll enter my name. That's going to be Adrian JS Mastery. I'll enter my email, my password, confirm it as well, and select the role of, let's say, an admin for now, and go ahead and click sign up. And would you look at that? The sign up actually worked, and we got redirected to our dashboard. Here, you can play with the application and do everything that you did before. You can also change the theme of the application, and you can open up all the different lists which haven't yet been created. Thankfully, that's exactly what we're going to do next. Now that the authentication phase is done, the next one is the users management. And after that, then we'll be able to visualize the list of departments. So let's go ahead and do that right away. I will just allow it to continue. Much simpler than having to code it ourselves now that we know what we're actually doing, right? This time, we're diving into phase 2, which is going to have 6 steps instead of 1. So now we can track what it is doing on those 6 steps. The first one is to create a users list page, then to add a role filter and search to users list, create a user form, create an edit form, create user details page, and finally, add delete user functionality. If you want, you can pay attention to see exactly what it is doing. Maybe we can take a look at the streaming features that we have by heading over into users, list, and see how it is implementing new changes. It just added this new file, updated the app.tsx, so now it actually shows it, and that's it. Now it'll add a role filter to the users list that is right here, which means that it'll have to modify this table. So if you stay here, you'll notice that new changes are going to come in instantly. And the role filter and search has been added to the list. What I also love about Refine is that the editor wasn't just an afterthought. You can see just how well it functions. You can collapse and open up the files, and you can also switch between the different tabs, close them, and also, as we said, take a look at the preview, which is super nice to see how it already implemented the users list right here with the complete role. And does the filtering work immediately? Let's check it out by trying to apply it for the admin role. And yep, it does work. We already have some test users. So I'll search for, let's go with JS Mastery. Yep, that works as well. I'm super excited about just how well this is working. Now, I'm not gonna bother you with everything else happening. Let's go ahead and give Refine some time to proceed with all the other tasks, and then I'll be back once phase 2 is done. And then again, if you notice that it's loading a long time for something that seems simple even to you, you can just reload the page and check whether it brings it any further along in the process. Like, yeah, in this case, we're already on step 5, where we now have the finished create user page. So we can now create additional users. We can enter a unique user ID here. We can enter a name. Let's go with Adrian JavaScript Mastery this time, full name. We can enter the email address, which should be unique. So I'll do jsmastery.com with a role of, let's do teacher. And I'll go ahead and create a user. You can see this user was created successfully and it got added to the table, which means that create works. Now we cannot yet click on this row to be able to get the details. So let's wait until it implements the user details page as well. And there we go. The phase 2 is now complete, where we can now list users' names, filter the role, create a user, which we also just tried, edit the user form with validation. So if you click this edit button, you should be able to edit it. Again, this is gonna depend on your role. We also have the pagination right here at the bottom. So in case you wanna show 10, you can totally do that and then switch pages. And then there should also be a delete functionality if you click show to go to that user's details page. Now, is there something that we could still improve, or that there is a bug with the code that was just developed? Well, technically, this is a little improvement that we can do. It's not really a bug. If we go to full screen, it'll be more visible, as you can see right here. But still, we're missing a piece of text of the edit button on smaller devices. So let's try to get Refine to fix this bug before proceeding to the next phase. I'll say on smaller screen sizes, the edit button within the users list row is not fully visible. It's like it doesn't fit on the screen. Make sure the edit button is fully visible within the screen, even on smaller screen sizes. In other words, make it mobile responsive. So let's go ahead and send it and see how well Refine fixes the bug that was there while it was implementing features that we requested it to do. So now you can see that it'll think for about 2 seconds, and then it says that it'll fix it right away. Let's see just how well it does. Is it as good as it thinks it is? Let's see what it is doing. I'll fix the responsiveness issue. Oh, wait, something is happening. Okay. I see the issue. The data table component already has a built-in support for horizontal scrolling and sticky columns, but we need to adjust the column sizes for better mobile display visibility. What it did is it showed the full show text, and then for the edit, it just showed the edit icon. I am totally okay with that. So if we click on it, that works. And if we switch over to a mobile view, which is also another huge feature that works like a charm directly within Refine, we can navigate over here and take a look at what it did. It made the actions always visible, so we never miss them. Maybe I was a bit too strict when giving it rules to make sure that it's always there, but hey, it did exactly what I asked. So now it looks good on all screen sizes. With that in mind, we can continue to the next part of the plan, phase number 3. So how do we do that now that the continue button is disabled? Well, just think about it. That's the reason there's a plan in the first place, for you to not have to think about what's next. It's here, and we just need to follow the plan. So we can just say something along the lines of proceed with phase 3. Let's go, and click send. Not sure if you have to be as enthusiastic. I think it's gonna work either way. And there we go. It's starting to create the departments list page and following all the other steps within the plan. This plan has 6 steps, so it's gonna start implementing them one by one. While it is doing that, let's take a look at the tab that we haven't visited yet, and that is the Resources tab. This opens up in full screen. Again, the editor is incredibly intuitive, and you can see the different parts that we have within our application. These have everything to do with our database. We have full connections between all the tables in our database. Specifically right now, we're working on departments. So you can see that we have 8 different endpoints that can be used on the departments table, such as the API departments that returns the paginated list of department list items. Wait, this is actually pretty well documented. And the query parameters that you can pass to it. You can also create a new department, retrieve departments with totals, and then update it, delete it, and even get the classes of a department. This is so well documented. I'm actually super excited about just how well this works. You can see that this is the primary key, that an ID is an integer, and different types of columns within this table. There's also the Secrets tab that keeps track of your API keys. Now, if you head back over to the plan, you can see that it already implemented 2 steps out of phase 3. So if you want to watch it do it, go ahead and go to the editor. If not, you can just head over to the preview and take a look at the changes. Yep, we already have fully functional departments. And notice how it was paying attention to what I told it, and now actions are always visible. Perfect. It also created a create a department form. And I think I want to use this opportunity to say that for you, the output might be a bit different, and that is completely normal, right? AIs can never be 100% deterministic, so the output is gonna differ from time to time. So for me, the edit button was not showing. For you, it might have worked from the start, but maybe something else was wrong when you were developing it. Whatever happened, you now know how to use it. You just simply let it proceed with all of the steps of a specific phase, and then you can talk to it to either fix some bugs that you notice are happening. Maybe in plan phase 3, one of the tasks is to be able to create a department, but you go ahead to the preview, try to do that, and notice that for whatever reason, it didn't work for you, even though it did for me. You can just go ahead and after it finishes, tell it, department creation isn't working, go ahead and fix it. And it'll do it for you straight away. Or if it's not a bug, but you want to add an additional feature to what it developed on top of the things in the plan, you can also just tell it, go ahead and add it. And then once it adds it, you can continue with the rest of the phases of the plan. Now, let's let it do its work. And there we go. Phase 3 is now complete. Departments management is now fully functional with departments list that you can search, filter, edit, and create, and even delete specific departments as well. Notice how the department details page, let's not look at this ASD one, but maybe like CS 101, if you open it up, already has a lot of information showing right here, such as basic information about the code, which later on, we won't use this code, but we'll use the code for the classes to be able to invite the students in. And then later on, once we implement all of these additional tables, they will all be interconnected with the departments, so you'll be able to see all the subjects, classes, and even teachers and students within a specific department. And of course, you can edit it and you can delete it. Oh, wonderful. So yeah, you can see how great AI is for accelerating the development of UI, specifically for tables and dashboard. It's perfect for rapidly creating a proof of concept or generating the initial UI, which can then be refined, no pun intended, or customized further. From here on, we can repeat the same process and continue executing the upcoming phases. So I'll go ahead and click continue to move to phase number 4. As before, it'll refer to the plan, which I'll collapse the previous ones and move to phase 4. We're already here. This one has 6 steps as well. Most of them are going to have 6 for me because they're all dealing with CRUD functionalities of different tables. And from here on, we can just keep clicking continue for the rest of the phases. Sure, as I said, results may vary a bit, but I hope they'll be different for you because then you'll get a chance to experiment a bit, maybe ask it to add an additional feature to some of these elements, maybe ask it to fix these icons that we can see on our sidebar, or to fix a specific bug. You need to own it because you understand what's happening behind the hood and you orchestrate the AI that is working for you. The most important thing is that now we see how AI can significantly speed up the process while making sure that the code it generates still follows proper coding standards. So I'll speed up the video right now as I continue going through the other phases. And there we go. Phase 4 is now complete. That was quick, wasn't it? We have the subjects management fully functional. As before, we can go to the preview to check it out. We have a couple of subjects right here. Oh, if you go to the subject details, look, it looks like I have a little bug or inconsistency on my end. Again, this might be totally working for you, but I'm actually glad it happened to me, so I can guide you through the process of fixing it. I'm not gonna let it continue. I wanted to fix this bug first. So I'll say on the subjects details page, under created at and updated at fields, within the basic information section, it says invalid date and doesn't show a nice human readable date format. Fix it and click send. Let's see just how well it does in fixing the bug that we just noticed. It thought for 0.6 seconds and it'll now fix the invalid date display. And would you look at that? The date formatting has been fixed successfully. This is exactly what I wanted to see. The date issue is now fixed. Created at fields are now properly formatted, January 15 instead of invalid date. Wonderful. Now, if we head over to the editor, I want to show you a super important thing. And that is that Refine is not locking you into anything. What do I mean by that? Well, we've auto-generated a wide range of different features with AI, but beyond automation, you still have full control. You can refine the UI, adjust styles, and manually edit the code right inside the editor. For example, if we head over to the page we were just on, that is the show subjects, right here under the header where you're showing the basic information about the subject, if you want to say, I am editing manually right here because I am a real programmer, you can do that and click save, and it'll notice the changes. And then if you head over to the preview, take a look, basic information, the file got edited. This means that you can edit every single piece of the code on your own. But hey, even though this editor is pretty good, you have your preferences. For example, you like another text editor or an IDE like WebStorm. How can you get this code over there? It's not like you're gonna manually copy and paste every single file. Nope, you don't have to do that. What you can do instead is just click the download button at the top right. It'll automatically prepare the download and get the code base down for you. But there's no reason why you would want to do that while you're still developing the project. Of course, we want to finish it within the platform with Refine AI to get all the benefits that we just discussed. A real use case why you might want to download the codebase though, if you want to host it somewhere else other than Netlify. Why Netlify? That's because Refine has integrated super quick one-click deployments to Netlify. And of course, I'll show you how to do that later on. But again, no lock-ins. If you want to download the code and host it somewhere else, you can totally do that. So let me remove this piece of text that I added right here. We don't want to mess with what Refine is doing as it's been doing it super well. And we want to just allow it to move to the next phase, which is phase number 5, classes management. So I'll just open up the preview, head over to classes, which don't yet exist, and tell it proceed to phase 5. And as this phase is similar to all the other phases, I don't have to talk over it. I'm just gonna let you speed run through this and see how it does it. And there we go. It's been some time and the refine is done with the 8th phase of building the application. So I just wanted to quickly jump in as I think we have a lot to see already. I just quickly asked it to also add some icons to all of the lists right here within a sidebar, and it did that without any issues. But yeah, this dashboard already is looking great. We get more information right here, so our users can instantly see what's happening on the dashboard. Things such as top department, top subjects, and so on. We have the quick navigations to navigate to other departments. There are also enrollment trends and graphs so you can visually see what's happening. There's also the recent activity. I can see here that for some it says 9 years ago. So this is definitely one of those little fixes that we can ask Refine to make. But also polishing is part of the last phase when we'll be able to make those final changes. And then even when we're done with the phases, if you have something else that you want to develop or some additional features that you want to add, you just need to ask it and the plan will be updated. The process for the last 2 phases is going to be the same, but before I go ahead and complete the application on my end, I want to walk you through the process of deployment. As I mentioned before, Refine allows you to deploy your application in almost a single click. As it uses Netlify under the hood, it allows you to deploy your application to the internet directly from the Refine AI environment. There are no deployments yet, so as soon as you finish all the phases of the build on your end, go ahead and deploy it. With that in mind, I'm already super happy with what Refine has built, and I'll take some additional time playing with it on my own and trying it out on some new projects. You can do the same. And this brings us to the end of this huge course. First of all, congratulations. If you're watching this right now, it means you've made it all the way, and that's a huge achievement. You didn't just watch a tutorial. You built, you debugged, you learned, and you explored 4 different ways of thinking and solving problems across the full stack. You went from front-end to back-end to database design, authentication, monitoring, integrations, and even AI-assisted refinements. You've done it all. So you should be genuinely proud of yourself. What you can do next is extend this application with a lot of other features, like assignments, schedules, announcements, many other user roles, or you can turn this app from university management to the management of something entirely different, like building new SaaS applications, or managing any kind of a dashboard you can imagine, because now you know how to do it entirely on your own, or you can use AI to move even faster. The choice is yours, but now there are absolutely no limits. So go ahead, experiment, break things, improve them, and build something even bigger. Whatever you do, I'd love to hear about it. So let me know if you enjoyed the course in the comments down below and what you end up building from it. And if you came to the end of this course, then you're just the type of developer I want to have on jsmastery.com. If you want to go even deeper on testing, so you can make sure that your applications are actually safe and work in production, or maybe you want to learn how to develop super performant and fast applications using the latest version of Next.js, or develop crazy animations using GSAP, or you already have plenty of skills and you're ready to improve your career. That's what the Dev Career Accelerator is for. Either way, all of these different courses and more are part of JS Mastery Pro, where you get a ton of stuff by becoming a member. The link is in the description, and I hope to see you there. Oh, and before I forget, the complete backend course is coming soon. The waitlist link is down in the description. But if you become a member, you'll be the first one to get the initial lessons. With that in mind, thank you so much for learning with me, and I'll see you in the next one. Have a wonderful day.